Good morning, everyone. Welcome to the second edition of the Zak Engineered Timber Envelopes Conference. My name is Ahmed. I'm part of the organizing committee here from Zak Exhibitions and Conferences. I'll quickly give an introduction about the event. I'll probably talk about the inspiration of this event. So we are basically organizers of the conference called Zak World of Facades. We've been doing this since 2012, in the UK since 2016. We've completed around 110 editions. Late 2019, we had a lot of references to timber being used in the external envelope. And then came 2020. There was a lot of time during the lockdown to think and to plan something new and different. We looked at other mass timber events and we thought we could probably try to do a mass timber event with a twist, something different, focusing only on timber in the usage of timber in the external envelope. And then we formed this event called Engineered Timber Envelopes. We did the first edition in London last year. I think it went well. So we are here for the second time. It's a fine balance between structures, facades, roofs, different people talking. We've got architects, consultants, we've got insurers, we've got cost consultants. So we've got suppliers, we've got a fine balance of people talking. I hope you'll enjoy today's agenda. As you see, we've been doing the Zak World of Facades conference literally throughout the globe. 35 countries is where we are present. And every country is different ways of looking at the facade. And this is probably the reason why we're actually doing this event, because we learned a lot from the World of Facade conference series. And timber is definitely the way forward for meeting our low carbon targets. But there are challenges here. So we're trying to see what can be done with the usage of mass timber or engineered timber in buildings. I'd like to thank our event partners, without whom we wouldn't have been able to do this event. All of them have a booth on top. Please go visit them during the breaks. Accoya Wood is part of the Accsys group. They have a very interesting engineered timber product. Ecological Building Systems is the UK distributor of Proclima, a membrane company out of Germany. Grupo Gamas is a Spanish timber engineering contractor. Proctor Group is a British manufacturer of membranes for facades, for timbers, for modular construction. RAICO is a German system company. They have an interesting timber unitized solution. Rotoblas is an Italian innovative timber solutions provider, screws, fixing systems, membranes. These are our 6 partners for the event. And just want to quickly run you through our next event. So our next event is obviously on the facade segment. We're in Melbourne, down under Australia next week, followed by New Zealand. Again, a very unique place. A lot of timber construction there. One of our best events are executed in New Zealand. We've got the Middle East with Dubai. We've got Singapore. We've got Istanbul. We've got Madrid in Europe. We've got Mexico City. And closer to home, Birmingham. It's our regional event with the World of Facade series. We were doing Manchester and Dublin. We decided we'll do Birmingham. Birmingham's growing. And of course, our biggest event in the series is our London event. So we've collaborated with the Society of Facade Engineering to host their Facade 2023 awards once again this year. So this is the big event which we do globally, followed by New York. So this is it from us. For those who had not heard of us and those who already know of us, this is what we've been doing. We speak about best engineering practices in the world of doors, windows, and facades, and now I want to talk of engineered timber in the building envelope. That's it from me. I'd like to call upon today's event host and convener, Timothy Snelson. He's a structural engineering director at Arup. He's going to be hosting today's event. He'll be introducing today's speakers. And yes, he'll take you through. I hope you enjoy today's event. We've recorded the event. Presentations which are not confidential, we'll be sharing them with you after the event via our YouTube link. And yeah, that's it from me. Over to you, Timothy.
Successfully navigated the giant leap for speaker kind. So welcome again this morning to Zak Timber Conference. The UN Breakthrough Outcomes have targeted net zero by 2030, combined with a 40% reduction in embodied carbon. But actually, if we're going to hit the 1.5 degree temperature rise target, we really need to be looking at halving our embodied carbon now. And we can do it because we have the technology. The question is shaping our industry, getting everyone aligned, an industry that's traditionally a bit slow to innovate. Concrete has been on the go for centuries, not as long as trees, of course, but timber has seen a great drive in innovation in the last 50 years or so, particularly accelerating this millennia, and that's brought with it some challenges in terms of keeping testing up to speed, keeping regulations up to speed, design guidance, all that kind of thing. A bit of bad news, unfortunately. The UN again, don't boo the UN every time I mention them today, but their global status report issued in November says that construction emissions actually went up by 2%, not down. So we're not really heading in the right direction. At COP26, Arup committed to measuring life cycle carbon on all our projects. So since then, we have gathered data from over 1,000 projects, and we've learned some interesting things. Our carbon handprint is about 350 times our carbon footprint as an organization. And I'm sure for many people in this room, that stat is quite similar. So we have an enormous responsibility for shaping these UN outcomes for the benefit of our society. The other thing we learnt is that we have responsibility for around 1.6 million square meters of floor plate coming online before 2030. So we need to act now. And of course, we're facing increasing urbanization, anticipation of 20% increase in floor area needed by the end of this decade, which is about 5.5 billion square meters. So the contractors, you can stop licking your lips now. But that's kind of equivalent of building Paris every month until the end of the decade. So big numbers, big responsibility, and really for my message is that for the built environment, because it can take 5 years between commission and opening day, 2030 is now. So we need to act now, and we have the ability to halve embodied carbon. You'll hear case studies today that will no doubt tell you stats like that. Our award ceremonies in the last year or two have shown exemplars that can halve embodied carbon. And of course, we're here because I assume we all believe that timber has a very strong part to play in that low carbon future and is a key component of our transition to low carbon construction. And if our industry is going to meet that challenge, then really we've got to hit 3 things together: productivity, efficiency, and reliability. Productivity, we've got to be able to sustainably generate enough wood to meet the demand while safeguarding future generations, supply of timber and ecosystems, biodiversity, etc. Efficiency, that means we've got to make the best of what we've got, use it efficiently, and find second, third, and fourth lives for our timber products. And reliability, investors, clients, insurers, and users need to have confidence that when they commission timber products, they will last for their lifetime. So events like this and other events where we gather and share information are about pooling our collective experience and working together to make timber construction better for everyone. That's why Arup invested in our independent fire tests published through the Code Red papers. And we're now testing prototypes for new floor systems in hybrid setups that will help to meet and prove all these reliability challenges. So today we're going to hear from a stellar lineup of speakers with case studies of best practice and tips for hard lessons learnt, and a few practical things about good manners. Please keep your phones on silent. Nobody wants to hear that silly ringtone. There are no Q&A sessions within the sessions, but obviously there's plenty of networking time during the coffee breaks. So please don't forget to come and meet the speakers, ask your questions, visit the sponsor booths, and make the most of the time we've got here today. And if you are a speaker, can we ask that you please come on the stage again if you've left, or remain on the stage at the end of your session for the obligatory photo opportunity. And make sure you've done your hair. So first up, I'd like to introduce Dominic Lyon from Gallagher's Insurance. And I'll give you 3 guesses as to what he's going to talk about. Insurance. Okay, take it.
Challenge 1 achieved. Thanks, Tim. Thanks, everyone. Thanks for having me. Thanks for turning up, knowing that there's an insurance guy talking first. I really appreciate it. It's rare, but I'm humbled. Thanks, especially if you were here last year and you saw me speak and you've come back. That's even more amazing. So hopefully I've got some new stuff. There might be things you've seen before as well, but I'll try and make it interesting. I've got half an hour. I'll try and fly through where I can. Tim, I didn't warn you I was going to say this, but I do just want to advocate Arup, actually. I was with them yesterday and a client. And I'm an optimist, by the way. You'll hopefully get that theme throughout my presentation. But a client who just put out a tender on 2 new buildings, and the 4 responses had come back, and all 4 contractors, without being told, had come back with a timber solution in some variation. So it's happening. We're going in the right direction, but it needs to happen quicker, faster, more enthusiastically. So anyway, who am I? Why am I here? That's what I'll try and cover off quickly. I'll then give you an insurance market overview. I did this last year. I think that's really crucial because I think an awful lot of the challenges that my industry faces around things like mass timber come down to context and the market as a whole, and not necessarily timber. Where are we since you last heard me speak in terms of mass timber and insurance? And then how do you deal with it? What would you say to an insurer if you're in a room tomorrow presenting a new scheme? What top tips can I give you? What are the big red flags, etc.? So here we go. So why am I here? Who am I? Why have you got an insurance guy in front of you? Hopefully, I'm a broker. So for those of you who don't know insurance at all or very little, I'm a middleman. I insure nothing, so I take no responsibility, which is great. I just understand what you're doing and try and relay that to the insurance market. I work across property and construction. I sit on the board of the Structural Timber Association. Don't ask me why. I think they just like a punching bag, but it's quite good fun. I also sit on the advisory board of TD UK, Timber Development UK, which was the merger of TTF and Trotter. We're a Built by Nature front runner. If you don't know who Built by Nature are, please do Google them. Great work that they're doing, and I'm sure you'll hear a bit more about them and the Loudest Foundation later. I've also been asked to advise on the government's timber and construction roadmap. Again, I'm not really sure why, but that's exciting. And it's exciting that the government wants to build or write a timber and construction roadmap. So that's, again, moving in the right direction. And I've got 7 and a bit years of mass timber experience. I know I don't look old enough, thank you. And then at the bottom there, just some nice fancy pictures about who Gallagher are and where I sit within the business, and we're quite big. We're the 3rd biggest broker in the world now, I think, so there's 45,000 of us around the world, pretty much every country you can think of. We're actually an American firm, but our 2nd biggest territory is the UK, so there's about 7,500 of us in the UK. One of the biggest people you've probably never heard of, unless you're a rugby fan. We sponsor the Premiership, so trying to get the brand out there. So that's why I'm here. Hopefully that gives you some context to why I know a little bit about timber. I don't profess to know anything like what my subsequent speakers do, so I probably won't try and go into any detail. But I do know a bit about insurance. So where are we when it comes to insurance? We are in what we call a hard, but I would suggest stable market, i.e. prices are quite high, but thankfully not skyrocketing any further than they have been in the last couple of years, aka stable. So roll back to sort of 2018, 19, we'd probably had 10 or 12 years of a soft market, low prices, loads of capacity, lots of insurers trying to grow, trying to write lots of business, an absolute combination of factors, some of which I'm going to talk through in a second, have basically in the last 4 or 5 years led us into a hard market cycle. Now, insurance has been going since the 1600s. It is a cyclical market. What goes up must come down. So this isn't something we haven't seen before, but it's interesting to talk about the kind of macroeconomic picture that's caused that. And so we'll delve into that in a little bit more detail. I'm afraid that was there last year, and it still is. Grenfell and the tragedy that it was is still impacting our market. And the reason it is not really that to do with combustible facades anymore, although that's still an issue. I think it just was a sort of a tipping point where my industry realized that we didn't really understand what your industry had been doing for the last 15 years in terms of how you build buildings, complex wall systems, etc. And so it was a kind of watershed moment where we went, what's an EWS1 form, but what is a complex wall system? We thought you built walls in bricks, and you don't anymore. They're very much more complicated than that. Why are there loads of voids behind those wall systems, etc., etc.? And it opened a can of worms far beyond combustible cladding, which we're still trying to get our heads around as an industry and understand what you do. Escape of water, again, I'm afraid that was there last year. It's still there. It's the death of 1,000 cuts in my industry. It's the thing that really hurts because they're not necessarily the ones that make the headlines, but they're the ones that hit the insurer's balance sheet. The fires are the big, headline-making claims, but the ones that really hurt in the background and ultimately cost insurers money, which costs you money, are the escape of water issues. And I particularly mention escape of water, so bursting pipes, plumbing issues, things coming from the inside, getting out, rather than the other way around, although obviously flood is a massive issue and growing as water levels rise. Inflation, that's new for this year. Again, unless you've been living under a rock, I think I don't need to tell you what inflation is or the fact that it's high, but it's hitting my industry, both in terms of the cost of materials, and the cost of materials means the cost of claims go up. So even if your claim was no greater than it was last year in terms of what happened, the cost of repairing it's going to go up. So the cost of insurance has to go up, sadly. So, and then you've got the double whammy of you guys as clients, if you are clients, and your buildings, the values of those buildings to reinstate them have just gone up because of inflation. So even if my industry is, as I say, sort of plateauing in terms of rating, my client's biggest issue in the last 12 months has been the revaluation of their portfolios and trying to figure out what it would cost to rebuild their assets if they had to tomorrow. And that's been pushing premiums up, even if actually the underlying insurance rate has remained pretty flat. It's been the inflationary cost of the building values that's going up, and then insurers also wanting to tag on a bit for increasing claims costs. So inflation is hitting insurance in a nutshell, as it's hitting the rest of us and in every way possible. And then we had a pretty awful year, and I wrote this somewhere else, but it feels like last year was the first year where climate change, to my mind, really hit the global agenda in terms of natural catastrophe losses on a really kind of widespread scale. So Hurricane Ian cost my industry many billions and is still doing so. The European heat wave actually had a massive impact on our industry as well. The Pakistani floods, sadly, less of that was insured because of the nature of the nation, which is devastating in its own way, but still hit the insurance industry pretty hard. What does that do? That drives up reinsurance pressures. What's reinsurance? It's where insurers go to buy insurance. Believe it or not, that's a thing. So insurers every year buy their own insurance. So if things go really badly wrong for them, they've got a buffer. What happens in reinsurance first ultimately then feeds into the insurance market. Something like 95% of global property reinsurance programs are written through London, and they renew on the 1st of January. So it's a really good indicator of what's going to happen in the year. They all renewed on the 1st of January. Thankfully, they did all pretty much renew, but rates were anywhere from 20 to 40% increases as a pretty sort of standard. So that market, which has had probably 10 years of a relatively soft cycle and was probably lagging behind the direct insurance market, has caught up rapidly this year. And so I think we're waiting to see how that plays out in terms of your direct insurance costs, but we're expecting that to start feeding through pretty soon into the direct property insurance market, because if insurers' costs of insurance are going up, they're going to pass it on to customers, sadly. And then ESG, thankfully there's some green, literally and metaphorically, at the end of the tunnel, some light at the end of the tunnel. Insurers are finally getting there, I think. As I say, I'm an optimist. When it comes to sustainability and ESG, they're waking up and realizing that they have a massive responsibility to get on the bandwagon to prevent climate change. And as the CEO of Aviva put it quite aptly last year, unless we limit global warming to 1.5 degrees, we won't have an insurance industry because it will become unsustainable to sell insurance. We won't be able to price it adequately that you would want to buy it. So the whole thing falls down anyway. So they are waking up and recognizing they need to do something drastic about helping the globe limit the effects of climate change. Otherwise, we are shooting ourselves in the foot. It's far slower than it should be or needs to be, but there's some really good stuff happening, and I'll come on to a bit more of that in the background in a few slides. And then a shameless plug for a report that we put out a few weeks ago. I'm sure if you stick Gallagher Real Estate Insurance Market Outlook 23 or something like that into Google, you should be able to find it. That covers off a sort of a slightly longer version of what I've just said, talking about reinsurance and everything in between when it comes to property and construction and where we think the market's going. So please do take a read if that was not enough for you. So that's the insurance market, and I'm running just about on time. And I think that's important because that's showing you the pressures on the insurance market. And I didn't say timber once, I don't think, in that whole spiel. So that all of that impacts on the pricing of your insurance and insurers' attitude towards risk before you even throw timber into the mix. So, you know, the anecdote I always use is if you try to place a £50 million steel and concrete building, if you tried to place the construction insurance for that 5 years ago, you might have paid £50,000 for your CAR insurance. If you tried to do that today, you might pay £200,000. It's gone up 4 times. And that's, again, that's just the market. That's where the market's gone, that's where pricing's gone. I didn't say timber again in that sentence. It's nothing to do with timber. The market's just gone up by 4x. Ironically, that might have slightly helped the timber industry because it's kind of shrunk the gap when the insurers then look to add an increase on top for the increased risk of timber. But there we are. So mass timber 12 months on, where are we? Well, I wanted to start with some examples of stuff that's happened in the last 12 months in the world of mass timber. Exciting projects that have been insured. I still, again, one of my things that you've probably heard me say before, if you've ever heard me speak, is I still don't know of a building that isn't insured. So people say that to me, oh, I just can't get insurance on that. Well, I don't necessarily believe you, I'm afraid. Everything's insurable, in my opinion. It just comes at a price, and sometimes that is a price that nobody likes, including myself. But I still don't know to this day of a project or a building that isn't insured, made of timber or otherwise. So what have we been working on the last 12 months? I will fly through this because I'm conscious there's some far better speakers going into far more depth into some of these after me. But we did the insurances for the Edge London Bridge scheme, which is, hopefully you've seen in the press, an amazing building, 26 stories, right on the river. It's got some timber in the floor plate. I won't pretend it's a mass timber building, but it's what we're sort of generally referring to amongst our team as a hybrid of a sort. It's a steel and concrete building with some timber infill, but it's moving in the right direction, and it's very sustainable in many other ways as well. So it's definitely a step in the right direction, and especially when you talk about a 26-story building in central London with some timber in, getting that through an insurance market at a reasonable price and getting it home. To give myself a pat on the back, I think was a good result and a real step in the right direction. And it also allowed us to take the insurance market on a long journey of what's happening. We started 12 months before we needed to place the insurance with that, talking to the insurance market, getting the client in front of the market, explaining what's going on, why they shouldn't run a mile, etc. And it was a really positive process. The black and white building, as I say, I'm not going to dwell on this at all because there's lots more to be said about this, but we did the construction insurance, ironically in a very soft market, which I'll probably do myself a disservice, but was remarkably easy. I'm quite glad it happened in 2018, that one. But it's completed and it's insured as a property. Sadly, that wasn't me, so I won't lay claim to that, but it is. I can't pretend that I know the final figures of what it was insured for, but my sources tell me it wasn't drastically more than if it was steel or concrete, which is great news. So again, another positive news story of a fully timber building in central London being insured. The third one on there, again, bit of a selfless plug, but it was a Gallagher job in Milwaukee. You've probably heard of the Ascent building. I think it's trying to claim to be the tallest timber building in the world. I mean, it is 7 or 8 stories of concrete underneath 18 stories of timber, but it is significant volumes of timber residential. in Milwaukee, and we did the construction and the property insurance on that, and it's all placed, all insured, clients happy. Not drastically happy with the premium, if I'm brutally honest, but happy. And it's insured. That's the main thing. And then a few more examples here. So other things that we've seen happen, and I can't lay claim to all of these, but Australia are building their scheme in Berkeley Square. That's on site with construction insurance. Again, that'll be an interesting barometer for where the market's going, because it's probably the leading in terms of time big hybrid office scheme in London, 9 stories of steel with CLT infill. So the fact that it got insured in the first place was great news. It will really be interesting to see where that goes when it comes to PC as well, as a kind of barometer for where the market's going on that stuff, because there are a lot more, I think, hybrid buildings coming down the track. Certainly we're seeing them. Land Security's Timber Square, I know it's been a bit delayed, but they've already got their construction insurance banked, and there's lots of timber in there. And then Art Invest, client of ours, looking to build a number of buildings on a massive master plan, including a 12-story hybrid scheme, which we're in the market with currently. So there's been lots of progress, is probably the summary I'd like you to take away from that, in terms of we've had lots of timber schemes come to market. We've had lots of timber schemes insured. Particularly on the construction side, we're still waiting for them to feed through into the property market, but where they have done, they've been insured relatively successfully, probably more successfully, if I'm brutally honest, than I expected. So, you know, even me as an optimist. So we are trending in the right direction, and with every scheme that comes, and every time we take one of these things to market, it's a chance to educate. It's a chance to get the insurers on board. It's a chance to kind of look them in the whites of their eyes and say, guys, come on, you've got a moral responsibility here as well as an actual one to assist in this. And I know my industry has a bad reputation, and I get it, and probably a lot of it's fair, but there are some really good people in my industry. There are a lot of underwriters out there who want to do the right thing, and they are trying to find ways to do the right thing, and it's just a case of that meeting in the middle with their actuaries and finding a way to price it that they can still stay in business, because if we're brutally honest, they're still commercial businesses. They still have to make money at the end of the day, but they want to do it. So there is an appetite for change and an appetite for progress, which is really exciting. Other industry initiatives and progress. So poor old Ollie's coming after me and said he wanted to talk about this, but I'm going to totally steal his thunder. There's a thing called the Mass Timber Insurance Playbook that is coming out soon. That is funded, supported by the Loudest Foundation, Built by Nature, that I mentioned before, the philanthropy. It is going to be a guide for clients, architects, engineers, pretty much anyone, to be honest, and insurers, as to how you might go about procuring insurance for a scheme involving timber. Basically to try and level the playing field a bit, because I think we're in a market at the moment where if you're a big client with a big provider who has some knowledge, you probably will know most of what's in the playbook. But if you're not, and you don't, then you probably wouldn't have a clue where to start and how. And this is trying to level the playing field, following the RUBA stages to say, at stage 0, you need to think about this from an insurance perspective. At stage 1, you need to talk to this guy, this gal, and trying to sort of walk you through the process. So that should be a really positive step in the right direction for the industry, and kind of give everyone the ammunition to know how to deal with us. Fire testing continues all over the world. Code Red tests were mentioned by Tim, but there's so many going on. And the Fire Hub, I won't profess to be a knowledge on this, but it's, again, another industry initiative trying to bring together, it's sort of pivoted slightly, but essentially it's trying to be the starting point for if you're a fire engineer and you wanted to understand how you might approach a timber scheme, you go to the Fire Hub. The Fire Hub is a starting point to say, what are the basic principles that I need to consider if I was to try and start building a scheme in timber at some point in the near future? And it will steer you in certain directions. It will then refer you to more technical guidance if you need it. But it's a really good attempt to try and kind of bring together everything that's happened in fragments around the globe and say, right, this is where we are as a global timber sector industry. And this is what you need to be thinking about. I've thrown the STA Special Interest Group large scale tests in there because they were excellent. We're still trying to figure out a way to get the good news story from them to the masses. I think even if you're a qualified fire engineer at the moment, you might struggle to read the report. It was like reading French to me, and I don't speak French. So we're trying to get better, I think, as well as an industry of of translation and communication, so that we with my timber hat on do lots of great stuff, but I don't think we're great at communicating it. Our PR and comms needs some work, so there's definitely some work to be done there, but there's some good stuff that's happened. Mass Timber Property Insurance Forum, I just wanted to make you aware that happens, because I think it's good for you to know. It's run by me. I basically try and pull together a load of underwriters and risk engineers from insurers about 3 times a year, either on Teams or in person if we can, and get them to listen to someone who knows a lot more about timber than I do, and explain to them what's going on in the world of mass timber and why they shouldn't be terrified of it. It's an ongoing education piece to break down some of those barriers and preconceived ideas that are incorrect. The new model building, I probably am stealing someone else's thunder here as well, so I won't say too much, but again, another amazing piece of work that's been done in conjunction with Built by Nature and the Loudest Foundation and War Thistleton, who are part of a panel later for sure, looking at how do we get around the current regulatory challenges in the UK around using timber in resi schemes of a certain size and scale. It's been tough. I'm sure they would agree with that, particularly with my lot and the warranty providers, people like NHBC, but they're almost there, and it's really exciting. So keep an eye out for that in the new model building. And then I mentioned it at the start, timber and construction workshops and the roadmap. So the government, if it decides to keep its housing minister for more than about 5 minutes, will at some point convene a load of industry people to try and bring together what they're calling their timber and construction roadmap. They basically asked industry to tell them how to use more timber and construction safely. So there's a response being pulled together by a number of industry bodies at the moment in the UK as to how they might go about doing that. That's across all areas, so it's not mass timber, it's housing, it's schools, it's you name it. But it's really exciting. The government's realised that timber needs to play a massive part in their net zero agenda in the built environment, and they're asking industry how to do it, which has got to be the right starting point, right? So that's exciting. So lots of initiatives going on, and I'm sure there'll be more. So what does all that mean for if you are going out tomorrow with a nice new brand shiny scheme and you want to take it to the insurance market and you wouldn't have the first clue about what to do and what insurers might think and say and ask? I'll try and give you some top tips. I stole this slide from a colleague, so thanks, Sam. We've lost a bit of screen anyway. Experience at the moment. So insurance is, as you probably are mostly aware, predicated. Insurers underwrite on experience predominantly. They like data, they like experience, they like to know what's happened in the past so they can model for the future as risk-averse creatures that they are. We don't have enough of that in the world of mass timber, unfortunately. So what do we then rely on? We tend to then rely on, and my advice to you is rely on actual experience of the professional team appointed on the job, and really sell that, really promote that. And if you haven't got vast amounts of experience, get some peer reviewers in. Don't be afraid to use experts to peer review the work. Pretty much every major mass timber scheme, hybrid scheme I'm involved in at the moment, particularly on the fire engineering side, is following, partly because of building regulations, and the regulators and building control, but partly because of insurance, following a peer review process on the fire piece specifically. Don't be afraid to go down that route and sell your experience. Sell your experience to the market and why they should trust you. Fire risk management, I think that's pretty patently obvious, so I won't dwell on that. Water risk, our industry has, in the last 4 or 5 years, pretty much mandated on any scheme of any size that you now have a robust water risk management plan, but it becomes, again, more pertinent when you talk about timber. So make sure you've thought about and are addressing your water risk management. Get rid of hidden spaces and voids. Hopefully, again, that's a little bit obvious, but insurers hate them. That's where fire travels up through external wall systems and spreads from compartment to compartment. Try and design them out where you can. And if you can't, be blooming well sure and confident that you're going to get good fire breaks in there, and you can pitch that to insurers and evidence it to them and take photos of them. And that's crucial. Hot works, again, hopefully patently obvious, but if you're using a load of flammable material like timber, try and avoid hot works and using lots of heat near it where you can. Security, what are you going to do about site security? I don't know whether this is fair, but insurers are quite paranoid about arson. It is still amazing, even on non-timber schemes, how many schemes are subject to someone throwing a fag over the fence late at night and no one's spotting it, and it's setting fire to a rubbish bin, and that's setting fire to the building or whatever. It's amazing how many losses we still have in that space. So I mean physical security there of the site. Have a think about what your physical security looks like, whether you're using, man security, CCTV, etc., and articulate that to the insurers. They'll really appreciate that. Storage, if you're bringing timber to site and not immediately putting it up, you've probably got your scheme wrong in the first place. But if you are, store it well, store it away from the rest of the building, store it safely, protect it, make it secure, have someone watching it, whatever you might need to do. Keep it dry as well. I mean, that's not really an insurance thing, but keep it dry. And store it well. Replacement plan, that refers to, so a lot of insurers, when they're underwriting a construction scheme in particular, are thinking, okay, so if something goes wrong, how quickly can we rectify the problem? Because that all implicates the overall cost of the claim. And if it's going to take ages to put the building back together, there might be knock-on effects in terms of financial losses that they're also insuring. So again, it may sound obvious, but tell an insurer that you thought about, if something were to go wrong, this is my supplier, this is where they are, this is how long I think it will take them to provide the replacement parts, pieces, etc., so that I realistically have a plan about how I'm going to put this all back together. I think, we're all adults, we need to recognize that things do go wrong. I think there's no shame in admitting that you've thought ahead and planned for if something were to go wrong. I think that actually just shows good risk management. So tell them about that. And then timber supplier and treatment, that just refers to, again, insurers are actually starting to become interested now in where your timber's coming from, who the supplier is, whether they have a reputation, and if you're treating your timber in any way, they're going to want to know about that as well, and why. They need to know why, because they won't know why. You need to tell them that. And effective communication with 3 M's. I'm going to pretend that was deliberate. It's not. Understand, this was a slide from last year as well, so I apologize if you were here last year. Understand, sadly, that still most insurers' starting point is probably no. That's slowly changing, but I would say, broadly speaking, if you were to go into the insurance market tomorrow, you could split them in 3. There's the insurers who say, no thanks, no chance, I don't like timber. There's insurers who say, okay, I'm trying to be helpful, progressive, save the world, let's talk. And there's a third of them who we call follow insurers, where basically they're not big enough to lead schemes of any major size, but if you get someone at the front of the scheme insuring it who they trust and is reputable, then they'll probably follow behind. So crudely, that's probably where we are. But there's an awful lot of nervousness still about timber in the insurance industry, so recognize that. Engage early and often. I think that's common sense in life, but they don't know what they don't know, insurers, and if you don't tell them, they assume the worst. That's how our industry was born and is what it's predicated on again. So tell them, engage early, bring them on the journey, make them feel like they're part of the whole process, make them feel like they're a valued member of the team on the project, and their input matters. And if you can make, it's like relationships, right? If you can make a concession here or there, insurers love that. It sounds like you've really listened to their feedback and taken it on board. So take them on that journey. Sell the scheme. Hopefully that's not obvious. Hopefully that's fairly obvious, but it is a bit of a sales pitch. And that's partly my job, sure, but explain why you're doing what you're doing. Do play up to the carbon piece. I think insurers need to have that rammed down their throats, because again, that's still otherwise really easy for them to just ignore it. So tell them why you're using timber, and what the fact that you have up front address their concerns, and sort of it's okay, we recognize that you're worried about X, Y, and Z. Here's what we've done to address those. What else? That needs to be your starting position when you talk to them. Use experts, we talked about that. And this last one is quite an insurance-specific thing, but focus on articulating design measures that will reduce the estimated maximum loss. The estimated maximum loss is a crude insurance underwriting metric that sits behind most insurers and how they price stuff. It's basically saying, what will happen if there is a single seat fire somewhere in the building after 2 hours, assuming all prevention measures fail. So sprinklers don't work, fire brigade don't turn up, everything goes wrong, and I've had 2 hours worth of fire. what's happened? What have I lost? And what am I going to be paying for to be replaced? That, very crudely, is what an EML is. So what you need to be telling them essentially is, here's why you can take your EML, estimated maximum loss, down from you're going to lose the whole building, because we have designed robust compartments that will withstand fire, even if all else fails, for 2 hours, as a crude bit of advice. And I think with 1 minute 50 to go, I've made it. Yeah, thank you. So hopefully that was helpful. I appreciate insurance is a bit of a curveball first up, but hopefully it's helpful. I know we're a necessary evil, I get that, but you probably do want to get some insurance somewhere along the line for your scheme. So hopefully that's given you some useful advice, context, and tips as to how to do it. We don't have time for questions. I think Tim said that. I'm frankly relieved, because I'm sure you'd ask me stuff I wouldn't know the answer to. But if you would like to drop me an email, please do. If you'd like to drop me a text or pick up the phone, please do. All the stuff's there, and I'd be happy to try and help. My agenda here is nothing more than to prevent climate change, and try and make insurers do that too. So that's why I'm here. And if I can help you do that by using more timber, then I'd be happy to try. My boss might think differently, but I'll do my best. So thanks for having me. Enjoy the rest of the day, and I'll pass back to Tim.
So our next speaker, thanks Dominic, that was great. And from personal experience on current live project, I have to say we found Dominic and Gallagher's very helpful and constructive in getting that dialogue going about how we're going to address the risks on the job and get the job insured. So our next speaker is Oliver Booth from G&T. He's a partner there. And G&T have been running mass timber breakfasts, which I'm sure many of you will have attended. And I believe you're going to talk to us a bit about that. Yeah. I think they're going to reboot the screen for a few minutes. So, Oliver, we're going to do a little Q&A on the fly then. Okay. So you're talking about a mass timber roadmap. I guess, what do you think were the key takeaways for you guys from the mass timber forum that you started?
Yeah, thanks, Tim, and morning, everybody. I think it's very poignant, actually, that Don was up here first, because a massive roadblock to the uptake, I think, of more timber buildings in all uses is insurance, and that's not necessarily the insurer's fault. I think there definitely was a disconnect, and we need to kind of draw a conduit between consultants like yourself, structural engineers, quantity surveyors, clients, architects, etc., and we needed to talk the language of the insurers, and the insurers needed to understand the language that we were talking. So I think what Timber Buildings has actually done is helped us become more eloquent in each other's languages, and it shouldn't just apply to timber building. I think on all buildings we should be closer. They should know exactly what we're doing. They should know the competent people that we're employing, the amount of work that's gone on during the design stages to make sure that we've thought about all the things that help them apply a more appropriate premium. So I think that was a huge takeaway for us. We actually did a lot of live polls. As you know, you're one of our panelists, Tim, and thank you for that. And you know, some of the stuff that came back was fascinating. You know, when we said, what's the most important thing to the developers who are on the forum? You know, is it cost? Is it program? Is it sustainability, well-being? Literally, it was nearly 99%. Everybody cared about sustainability, biodiversity, low carbon, and the environment. And cost and program were actually right at the bottom, which was quite refreshing. So, yeah, I think they were probably the big takeaways from the forum.
Yeah, I echo what you said, really. I thought it was really valuable to bring together all the different stakeholders, all the different skills, and just really learn to talk each other's language a bit. So I'll leave you to get on with it. The screen seems to be fixed. Good luck.
Okay, fingers crossed. Good morning, everybody. There'll be lots to talk about the black and white building today. It is the new building in town that everyone's talking about. It's as timber as you can get. So I'll do a couple of slides on it, but I don't want to steal too many people's thunder. So that's a picture of it. It's on Rivington Street. It's very, very worth going and having a look at that. So in terms of the agenda for today, I'll introduce myself very quickly, although Tim's kind of already done that for me. Thank you, Tim. What was the G&T Mass Timber Commercial Office Forum, which again we just touched on. I want to talk about the stakeholder map and how we mapped out all of the people and pretty much every stakeholder in the industry that has an impact on mass timber, I would wager is in this room today, actually. So that's quite an interesting thing to look over. The kind of key considerations and things that came out, opportunities and key findings. I want to talk a little bit about hybrid construction, and that whilst we all want to promote the use of mass timber, we don't want to kind of force that square peg round hole scenario. We don't want to just force timber into buildings. We should use it efficiently and make sure that there are hybrid opportunities whereby we can still use timber, but maybe suit the type of building we have, the spans in our building, and the design that we're looking for, and flexibility. I'll talk a little bit about the Storenzo office manual, which is a couple of years old now, but it's available online, and it's a really great kind of beginning if you're looking at doing offices, the things to consider. I'll talk a little bit about the mass timber insurance playbook, which Dom's touched on as well, but I think that is going to be a huge benefit to the industry when it comes out in a couple of months' time. I'll do a very quick case study on the black and white building, which that's another picture actually from it there. And we'll talk about the residential new model building, which again, Dom touched on, and then just a quick slide on the future of mass timber in the UK from my perspective. God, it's even worse on a big picture, sorry about that. 17 years at G&T. I'm a partner based in the London office in the cost management. Basically, I'm a quantity surveyor. That's a fancy word for quantity surveyor. I am a G&T kind of mass timber MMC specialist, but the reality is I work on all kinds of buildings, traditional concrete, steel. But thankfully, the company supported me in exploring and researching these kind of fields. I've been doing that for about 12 years. My first CLT building was about 12 years ago now. I've got experience in various sectors, and I'm a very proud member of the TD UK Advisory Council. So what was the G&T Mass Timber Commercial Office Forum? And I just focus on the word commercial because we would like to have captured all uses, but because of Grenfell and the combustible ban, we found that very sadly, timber got wrapped up in that what constitutes combustible in an external wall. So the residential timber buildings really started to dwindle. So we thought, well, we'll focus on the offices because that seems to have skirted around the ban. You don't tend to have timber in the external wall of an office building. It's a lot more open plan as opposed to residential. And all our clients wanted to build timber buildings. So we found ourselves giving the very same presentations to the British Lands, the Land Securities, the Derwents, et cetera, developers of all shapes and sizes. And so actually it was British Land and Landsec's idea. They said, why don't we try and get a forum and have kind of expert panels on all the topics that you see up there, and we'll just debate them in the room. So we thought this is a great idea. So in January 2020, we booked the boardroom for first Tuesday of every month, and we had a stellar lineup of insurance, fire consultants, sustainability, best practice, that was basically the contractors, people like Lend-Lease and the like, cost procurement and procurement, which was our bit, capacity, supply chain, etc., structures, which was Tim and some of his colleagues, and Kelly as well, who's at the front here at Whitby Wood, leasing and sales and architecture and design. And then February, March, the pandemic happened and we had a bit of a problem. But like all problems, there can be opportunities. And so we decided to switch it online. So instead of having only 50 people in the boardroom, we now have about something like 250 people signed up to it. And anybody here who's not part of it would be very welcome to. And really, it's just us asking questions, the audience asking questions and talking to people like Tim and asking them what they think. And we started basically by mapping out all of those stakeholders that actually make up the mass timber industry. And they're all just as important as each other, but by mapping it out and understanding what everybody wanted, we kind of identified very quickly that the main problems were around fire, water management, and the insurers, basically. Most people who wanted to do a timber building couldn't get insurance for it. They might be able to get there on the construction insurance, but it was the property insurance seemed to be more of a challenge. And so we managed to find Dominic, who basically gave freely of his time. And now the insurers, it's really very much on their radar. And to Dom's point, most of those projects he put up, we've been involved in with himself and other brokers and other insurers. And it's not insurmountable anymore. And it's really that conversation. But all of these are important parts, we think, of the mass timber industry. And it's only by collaborating and talking to each other and understanding the language that we all speak that we really will crack this nut of the fact that we all want to build more timber buildings and we're more timber envelopes, if you like. But ultimately, once we've got these all aligned and we're all on the same page, then we'll make real traction. These were just some of the things that came out of the forum. So, we've talked first about insurance, the importance of, let's not just force a timber structure, let's use the timber carefully, efficiently, whilst this is all sustainably forested timber, PEFC, FSC if required in some cases. Ultimately, let's use that's what Storer's mantra is actually, is let's use as little timber as possible, but to get the structural kind of outcome that we want. Hybrid technology, so using steel and CLT, using concrete and CLT. Let's use the right material for the purpose that it's actually serving in the building. Collaborating with the supply chain. I honestly can't think of a better industry than the timber industry, from suppliers to subcontractors, who give so freely with their time just to sit down with you and talk to you about what they do, and how to design your building effectively, efficiently. So again, I think that was a really important part, and I think again we're getting better and better at talking to each other. A holistic approach to cost planning. Quantity surveyors have had to learn again, because it's not as simple as measuring concrete, which is mass concrete, reinforcement, formwork. These are modern methods of construction, and there's a lot more complexity in understanding them and costing them. What goes into the factory, the transport of the material going backwards and forwards. So we've had to learn, and we've had to cost plan in a different way. And I think the RICS and quantity surveyors alike are getting better and better at that. And I would say that most of the projects we look at now, cost is not what's stopping timber envelopes, what's stopping mass timber from going forward. Cost is not the problem, but we're finding on most projects nowadays. Again, fire is just making sure you've got competent fire engineers involved. Building regulations, again, just making sure that you're talking to building regulations and LFB throughout, or wherever your regional fire person is. Acoustics, understanding that. Consistent guidance, I think, is a big thing, and hopefully that will come across in the presentation today, that once we have these roadmaps, I think that's going to get used a lot, that term today. Once we have these roadmaps in place, we have these guidance, these manuals, this kind of shared collaborative information across the industry, I genuinely think that this will become a lot easier, because we won't be reinventing the wheel every time. Ironically, with the insurers, as Dom touched on, water management is more of an issue, I think, than fire with timber. Everybody just assumes it's fire, but I think most of the claims that the insurers get, Dom, is probably to do with water ingress. And that's not just a timber problem, but it obviously affects timber perhaps more than other materials. Costs, sustainability, that session was probably the most positive of all of the sessions in the Timber Forum, because it literally everybody in the room was on the same page. And they're making the environmental assessment methods recognise more the importance of timber, low embodied carbon, high sequestered carbon. Yes, there's a question about what happens to the timber at the end of its life, but there's no reason why it can't be recycled, it can't be demountable and reused again. So I'd like to see sequestered carbon perhaps be more prominent in the credit scorings of the various environmental assessment methods, and perhaps we need a new one just for timber. So really, I guess the major outcomes that came of the sessions, which ran over about 9 months, and we do tend to pick them up every year and just do a lessons learned with a kind of a stellar new panel. We look sustainability and well-being with a big positives, the big reason why we were all there. Collaboration and expertise and competence, regulation standards and testing, stuff that we can all go to, places we can all go to make sure that we're doing things. We're not reinventing the wheel, that we're just following that guidance, and then hybrid development. So I've just put some images of projects, pretty much all projects that we've been involved in, and many of you have in the room here as well. And just that point that it doesn't have to be like the black and white, whereby the client was visionary in that they wanted an all-timber building, timber columns, timber beams, timber CLT floor plates, timber roof structure, timber core, timber stairs, tulip wood brise-soleil, a timber stick curtain walling system, a RAICO system, who are one of the sponsors here today, with openable windows, which is now becoming a real thing since the pandemic. It seems every building wants openable windows. As quantity surveyors, we're just trying to limit quite how many they get, because they seem to be peppered over every facade. But that seems to have come out of it. And so if that's that you want the pure timber building, that's what you can go for. But that can come with some restrictions on flexibility in the future. Again, glulam and CLT floors. If you want to go for a hybrid like the Berkeley Square scheme that Dom mentioned earlier. Steel with castellated beams to run services and whatnot, and CLT. You generally can get pretty good spans as well, so that's another option. The bottom left is the rib slab and glulam and CLT. The bottom middle one's actually an interesting one. That is a Barbuca LVL beams and columns, but with a precast concrete floor. in King's Cross. And this last one down on the right there is, we're getting this more and more, and I'm not sure it's necessarily the best solution, but people want timber buildings or to put timber in a building so much that we're now looking at concrete frame buildings with CLT infills. I'm not sure it's the right answer. I mean, it's great that we're using timber, but ultimately there's lots of concessions to do that. And the reason why it's a CGI is because, to my knowledge, no one's actually quite done it yet. But I think there's lots of stuff on the design, on the design board. And again, so we're adapting all the time, and we're working out how best to get timber in our buildings. So this is the Renzo office manual. Again, you can get this online. This was just an entry level, if you like, of things to consider about your building in terms of spans, in terms of grids, in terms of slab thicknesses. And ultimately, it's just again, it's all about that collaborative approach, working together and sharing this information. We will get more timber buildings naturally because we understand more and more. We're not keeping that information to ourselves. Then there's the Mass Timber Insurance Playbook. So this should be out in the next couple of months. And really, it's just a guide that's been written and kind of built and also bought into by Marsh and Zurich and Jim Glockling, who is literally a font of knowledge on all things kind of fire and insurance. And really, it's just will be free for people to get hold of. And it's just starting right at the beginning and saying, REBA stage 0 all the way through. How do we talk the language of the insurers and make sure that we're doing things and liaising and collaborating with the insurance world to give you the very best chance to get insurance? And again, I think this is what's wonderful about timber buildings is that all of this stuff, I think, should probably be actually available for any building, whether it's concrete, steel, whatever. It's just so happened is that there's a real focus on timber because of people associate natural risk with timber. And actually, I think it's leading the way in some of the best designed buildings that we have of all, because there is such a focus, such a concentrated scrutiny of how we're designing these buildings. So ultimately, the Mass Timber Insurance Playbook will pick up on those things on the right. Fire, flood, escape of water, security. There's 26 different things in there that they basically pick up on, things that you need to consider and make sure that you're liaising with your broker and telling them, ultimately, this is what we're doing about this is what we're doing about that. Take them on the journey rather than leave it too late down the line and not telling them enough. And then ultimately you attract higher premiums or worse, perhaps not even getting the insurance as well. And again, that's just a kind of a flow chart, if you like, of how it will work. You want to build a building, you read the guidance, then you start looking through the REBA stages and at each stage ticking off the boxes and whatnot, making sure you're following the guidance as much as possible. And ultimately, hopefully, it will lead you to getting your insurance at the end of it. So that's something to look out for as well. Obviously, picked up a lot on the black and white building, but these are some photos that I thought I would take. As I say, it's well worth going and visit. It's owned by the Office Group, a co-working company. We started on that journey, I think, 2016. And, to see it finished is great. And I think it just illustrates that the more built examples of timber building we have, and the more data that we can provide the insurers and we can provide each other, the more of these are we going to actually see. So, I mean, as I say, it doesn't get more purist than the black and white building. Literally everything, as you can see there, is made out of timber. Even the concrete basement, single-story basement, has got a timber effect finish to it as well. So, literally, we've done our best, and I'm sure the guys will talk more about that later. The new model building, I'm really hopeful for this because whilst the offices seems to be really pushing on, schools still seem to be doing really well out of timber envelopes. The residential is still suffering a lot because of the combustibles ban. So a group of people have got together, and one of the best things that came out of the forum was meeting the Loudest Foundation and Built by Nature, and they have been very generous in sponsoring a whole team of consultants to work together and essentially overcome the issues and come up with a good guidance manual, if you like, or playbook, again, if you like, of how to build a mass timber residential building with lots of good information on how the build-ups might be for roofs or structure, facades that might be suitable. NHBC have been part of it. They're, again, linked to the insurance industry, a big part of the puzzle in all of this. But we've also had Jose Terrero, who was advised on the Grenfell scenario from a fire perspective. So we've got lots of people together to work together to come up with a guidance of how you might do a residential building. And I'm really hoping that we're going to start seeing more timber residential buildings again, because from my little silo as cost consultant, I can't really see why we can't do it. And we know that timber has a lot of benefits. So what do I think the future of mass timber in the UK looks like? I think it's a pretty positive outcome, to be honest with you. I think it's already happening by all of you in the room here today and being so positive. I think improved stakeholder knowledge and understanding, and we can't just keep the information to ourselves. We've got to start sharing it. And all of these things are online, and it just through conversations, which I'm sure will happen today, there'll be other things that are happening, other people doing good stuff. So we're hoping that information will be shared, and the knowledge will just increase across the industry. I think there'll be better availability of built data and analysis, which will help everybody as well. More consistent guidance. I think this whole roadmap is all about how we just follow the footsteps of others and don't reinvent the wheel. I think there's a real opportunity as well to reuse existing buildings using timber, whether it's extending up, whether it's extending out, whether it's filling in the middle. I think ultimately we're all trying to hit these magic targets of, below 500 kilos per square meter of carbon, and it's so difficult to do with new buildings. But with reusing existing buildings, repurposing existing buildings, and really timber plays really well into that. So I'd like to think that we'll see more of that kick on and kick forward now. So more mass timber buildings. I think I'd like to see more sustainable buildings generally, improved health and well-being of end users, and a reduction in carbon and better carbon capture, I think, is ultimately all of our goal. And better recognition, as I said earlier, by the environmental assessment methods for the big role that timber has to play in doing all of those things and improving the industry generally. So lots of stuff on there. If you need my details or you want to go through the Zak conference, guys, I'll give you links to all of these things. And let's just share information better and try and build more timber buildings where we can. That's it. Thank you.
Hi, Jim. How you doing? Okay, thanks, Oliver. Great wealth of information there, flashed through very quickly. So as Ollie says, make sure you pick up with him afterwards. And our next speaker is Jim Heverin. He's a director at Zaha Hadid Architects. And he is going to give us a much more upbeat talk by the sounds of it. Design possibilities with mass timber. Great, thanks, Jim.
Morning, you can hear me? My name is Jim Heverin. I'm an architect at Zaha Hadid Architects. That was very informative, I have to say. We were just having a discussion with an institutional client in the UK, both for residential and offices, and pretty much at one of the first meetings, the structural engineer sold to the client the timber was not possible at all for residential, that with concrete you get fire protection, acoustic properties, all for free. And I think generally it's great to see this guidance coming forward and more information in the UK market to be able to put forward onto the table. Thankfully, in that case, the client is very interested in the hybrid office, and the fact that they can see so many hybrid offices coming forward really gives them a lot of confidence that they can participate in this and deal with all of these issues that have been talked about. So, I mean, we are not pioneers in terms of mass timber, so I think my presentation is really about our journey to try and do more and try and educate ourselves and educate our clients. I didn't think about it when I put this presentation together. This first image actually has a concrete slab in it. And I mean, we have had a love affair with concrete, and we will continue to have a love affair with concrete because it's still an extremely efficient and versatile material. But we recognize that concrete itself has to change and that we need to see a lot more timber for its low carbon properties. And this project did have timber. It had timber in terms of lining, culturally and materially to fit in with the context of Oxford. But we also sought, and we did the upper volume in glulam, and it proved to be a very successful material, particularly in terms of how malleable and adaptable it was to that formwork. But there is just the reality in this context and in many other contexts where concrete is the solution for that type of complex basement, that type of complex structure, that this was sitting between two listed buildings, and the strength and the efficiency of concrete. So it is, and I'm very glad to hear the conversation, that this is not about being Puritan or absolute. It's about finding hybrids and compromises and finding the appropriate use of each material. And this was GGBS concrete with recycled aggregate. So we did as much to reduce the impact of that carbon itself in the concrete and tried to balance that and use the mass timber where it was appropriate. And we've done much more elaborate interiors. And timber is always a very easy sell to clients. I mean, it's compared to materials such as steel or concrete. When you start talking to clients about timber and its natural properties, its the kind of qualities that it conveys to us, all of us, I think it's a very, very easy sell. And in this case, it certainly was. And it was certainly the case also when we were talking to the Olympic Authority in London about lining the underside of the large roof that spanned over the Aquatic Centre in London. And we did do a study to look at if mass timber could be used, but it actually transpired in the end that given the span that was necessary, if you might remember during the games, these glass elevations were gone. We had 2 temporary seating stands to get the necessary seating capacity for the Olympic Games. So it had to do a span over 110 meters. And by the stage that you get to use mass timber at that scale for that type of span and the amount of steel components, it started to look equivalent in terms of its carbon footprint to steel. So at that point, and there was also the issue of the availability in the market of mass timber when we were procuring this, and it just wasn't there to be competitive to steel at that point. I mean, I'll come on to a project later that we're doing here in the UK, but price still remains a real issue with putting timber on the table. I'm glad to hear that the engineer that we're using for a project for a small stadium, which I'll show, was telling me that in Germany, at the moment, when they went out recently for a glulam roof, that it came in even lower than steel. But this is not the experience that we're having in the UK at the moment. So it would be good to understand. I'm glad to hear that you were saying from G&T that actually it can be lower, so, or maybe it's about how QSs are looking at it, or even suppliers are adding risks and contingencies into how they're estimated. But this is obviously, as we know, one of the key factors that prohibits people progressing with timber is the cost. And timber is not free of responsibility, as I think we all know. It comes with a large amount of deforestation and supply concerns, and there is a real responsibility on all of us to look at responsible sourcing, to know exactly where the timber that we are specifying and going to use in our projects, where it's coming from, and that it's going to be replenished in a responsible way. And that was very much the story of when we looked at the specification of the timber for the ceiling in the aquatics. I think in the end, we could not have got to this end solution without the helpful and positive involvement of the supplier, who was Finnforest Merck. So originally we had specified that all of that lining would be solid hardwood timber. Initially, we're also looking at a Western red cedar, but we could not get that to be responsibly sourced, even though it comes from Canada. There's lots of land issues, land ownership rights contested about the cedar. So to get an FSC timber, we actually ended up with a Brazilian hardwood, which sounds very contradictory, but it had the FSC certification. They had a whole chain of custody that they could demonstrate. Finnforest were able to satisfy themselves and us as well about that. That was one aspect, and the other aspect was that Finnforest was able to bring the experience that you were talking about and the test certificates from Germany, from mainland Europe, to here to show us that actually if we change the majority of the cladding to a veneer on the interior, that this would be able to withstand the humidity and all of the other performance requirements that you would expect from the interior of a swimming pool. And without that ability to demonstrate that, it would have been very difficult for us to make this change, so that we swapped out most of the solid timber to just the exterior and went with a veneer on the interior, thanks to the involvement of the suppliers. And they also brought in a change to change all of the substructure away from an aluminium system that we had to an LVL system, so that we were able to replace all of it. And also, of course, we found that the LVL, again, timber is so malleable in terms of being able to make geometries, adapt to forms that we want, that all architects, I think, are looking for, no matter what stylistics are they're pursuing. So it's got an immense ability, and of course it goes back to the origins of construction in that sense. So this was part of that whole process of looking at where that timber was coming from, ensuring that what they were cutting was done in a responsible way, and ended up with the right certification and the chain of custody to demonstrate to us. And I think we've taken this forward on all projects, that we try to engage in the responsible sourcing aspect of the use of timber. And it's been a real shame, as we all know, of the cloud that has been cast on the use of timber given Grenfell. And we cannot forget that in other countries they are building high-rise. This is in Norway. I think many of you might be familiar with it. A mixed-use building using mass timber. And it really demonstrates to us that we should have the confidence that actually timber plays, and it can play a significant role, and it needs to play a significant role in our built environment. And for us in particular, because one of our projects, which I'll come on to, is looking at an old timber stadium in the UK. It's also the context of previous fires, and this was the fire at Bradford City in 1985. And it's important to look at this and to understand what happened here is very, very different to what we are proposing today. They had a fire that had if you see on the right-hand side, they actually had an open timber terrace built above an old concrete terrace with this void in between where rubbish built up. This is where the fire started. Somebody threw a cigarette onto the terrace, it went through the gap, and it caught fire with that rubbish. They had a undersized timber joist, literally timber joist you would buy out of a hardware merchant for the roof construction. So it's no wonder that this fire happened. And not only that, the whole way that the terracing was designed, and since then, there has been immense progress in terms of engineering timber, its safety, its testing, the properties that we are much more aware of. But unfortunately, part of what we're going to have to deal with when we're talking to inspectors is the context that they probably initially always think of the Bradford City fire and how that. But even in terms of how we design stadiums, it's immensely different. So on the top, you can see that this was that stand at Bradford City. It had very limited routes out from the seats. It had very limited, in fact, very congested turnstiles to exit. Whereas today we design by the Green Guide, a very recognized standard that we use both in the UK and internationally. We calculate the evacuation time to be 6 minutes, depending on the fire risk. And we then design the width of the vomitories and the escape routes, so they're much more, they're properly sized. So there has been immense progress in terms of the spatial design for safety, but also the progress in terms of the quality of timber. And we brought all of this to play when we were actually designing this stadium in Qatar for the World Cup. This was the Al Janoub Stadium. And timber was a natural solution for this project for the secondary structure, so not for these primary trusses, but we had proposed that all of what you see in the kind of darker ribs, that this be all engineered timber. It both worked for their aspirations to deliver a low carbon tournament, And also they had a cultural aspiration that this stadium referenced a traditional timber boat. So for us, this was a win-win situation, and it was quite an interesting learning cycle for us. I've taken this from one of our fellow architects who are Thistleton Warren, who are really pioneers in this, but just the basic metrics of what a lump of timber is compared to steel or concrete just shows you why we need to use much, much more timber, because it's just a basic fundamental fact that as a starting point, it is extremely low compared to these other materials. But there are other factors involved, and one of the key factors that came into play in this was the transportation and what that added to the carbon. So those blocks, I'm not quite sure how much transportation is calculated into that, but when we did the calculation, and you could only reasonably get that type of engineered timber from Europe, so the transportation from Europe to Qatar added sufficient carbon to that it actually started to become equivalent or reasonably close to the steel. So it started to undermine the argument. And we do need to look at this holistically. There's no point just fooling ourselves that that is the full carbon story, that there is other aspects, and particularly the transportation in this case. But I still think it would have been the right decision. They could afford to do it. They could afford to make that type of statement. And the thing about using timber in this day and age is that you don't need to explain that this is a progressive project that's trying to aspire to be non-conventional and push us into the future to deal with the climate emergency. So for all of those reasons, the Qataris should have stuck with timber. But in the end, unfortunately, it went a design and build route, and the contractor, unfortunately, under the pressure to deliver his price, he took out the timber and replaced it with steel. But one of the very interesting facts that you learn when you start to look at timber, as we did, is that if you oversize the timber, it will char and it will stabilize. So in terms of its structural properties under fire, it's immensely better compared to steel, which you see at the top. And on the graph, the gray is the steel, and you can see how that just continually degrades. Whereas there is a natural ability within timber, if it's oversized, to stabilize. And this is an immense property that steel has to overcome with applications and fire. So it was a really cornerstone of our proposal and our design in the Qatar project, but unfortunately it got value engineered out. And what was quite a funny thing is that although we had worked on several national and international sports, so London, Tokyo, Qatar, the most aspiring and ambitious client we met is a private owner of a small club in the west of England called Dale Vince. And he bought a local club called Forest Green Rovers. He supplies energy through windmills and other means back to the grid. That's his main business, called Ecotricity. And really, Dale Vince has taken this club and not only decided that he wanted a new stadium and that that stadium should be low carbon, but he looks at every aspect. So he looks at their shirts. He says, okay, their shirts will come from recycled coffee beans. Their food will be all vegan. So he's looking at every aspect of the club and showing all of the big boys, all of the Premier League clubs, that actually you need to look at your full supply chain, and you can do a lot with your purchasing power. And he is really demonstrating this and taking the club forward, which is now in League One, and hopefully will stay up. So it's a very small club outside of Stroud. We won this in an open competition in 2016, and it has been going through quite a protracted planning process. But central to it was that this would be built in a greenfield, albeit it's a greenfield beside the M5, so beside a motorway, which is why it's suitable for a stadium. And this is a county where most people are driving, so it is a desire that eventually there will be a modal shift in terms of how people arrive at this stadium, but you still need to recognize the reality that people drive to get to this club. And what was very key for us as architects was to really replicate the cultural references, and particularly the barn, the oak barn traditions, and to do a design that felt in infinity with this green field. And so timber was really key to that, and it was key to that both culturally and in terms of its representative values, but also in terms of its performance values. He wanted a low carbon stadium, as low as possible. So we have looked at designing a stadium, and we are now starting the detailed design on this. Apart from the substructure, which will be concrete, but apart from that, everything above grade will be timber. So all of the superstructure, all of the bleachers will be timber. And the design is inspired really about replicating the effect of what the beauty and the affinity that timber gives us to nature, and that feeling, and how that could be replicated into the stadium, and how this, not only on event day, but on non-event day, that this can contribute to the landscape. So that the silhouette and how it sits in this context was very important, but also referencing our centuries-old tradition of working with timber in this country, and particularly in where it has continued, and particularly a lot of our oak barns, and how this culture, this reference could be echoed into a modern football stadium. And instead of using oak, using glulam and CLT, and this is an image from the General Spectator Concourse, where you can see part of the back of the bowl structure and the open nature of the concourse. And stadiums are really kind of the opposite of your normal building in terms of where their carbon is. So in the top, your typical building, most of your carbon is going to sit in your operational carbon. But in a stadium, given that the operational side, apart from the lights and some of the conditioning you have for the hospitality areas, is quite low. So your carbon footprint is predominantly in the embodied carbon. So it is really key to tackle that and to look at using timber to do so. And so the idea is to describe this volume with straight mass timber elements, both for the roof and for the seating bowl, and to use a semi-transparent membrane on top so that you can have the daylight coming through. Obviously helps with the turf growth, but also the overall light quality that you get around the field of play. And here we can see the main superstructure in glulam, the roof, and also the raker beams for the seating bowl. And then we propose to use CLT planks to do the bleachers or the terracing, so that the majority, if not all of it, can be done in timber. This will be sprinklered in in concourse in the hospitality areas. And we're just beginning this discussion of where to put fire breaks, so that although this will be oversized, although we're very confident of that argument, that there still is the issue that you could have, and we don't want to segregate all of the concourses with compartments. So it may be necessary, and probably will be necessary, so that every fifth or sixth bay to introduce a non-combustible material, so you don't have the ability of a fire to spread the whole way around. But the ambition is to use the CLT and glulam to do the majority of the work, to apply a weatherproof membrane to the CLT, because this will be exposed. And I think weathering is as much a consideration, and the water as much a consideration as fire. So that all of when you actually are in the seating bowl, you will not see timber, unfortunately, but you will from the underside. But it is a necessary compromise to make sure that that's protected, particularly in the areas where the oculus is not fully protecting the seating bowl. And what you get from all of this is it's significantly reduced, and we hope to improve on this in terms of where this sits by comparison to other stadiums. And again, for the client, it's really for him a demonstration, and he is asking the question, can he source this in the UK? Can he buy a forest in Scotland and actually be able to look at taking out that travel component? And unfortunately, it looks quite difficult to do so. But I think as a country, this is what we need to start to gear towards. And we're already finding that we can find installers, but we're not able to find people who are actually growing and making these types of products in the UK. They're importing them from Europe. I think that's very different from what we see in countries like France, where their public procurement is not only pushing timber, it's also stipulating that it has to be sourced within a certain mileage from where it's going to be used. So we have a lot more steps to do and a lot more opportunities for our industry, our construction industry, to really switch away from the conventional materials and really start to fill this gap and not have to import this type of material. So the quality will continue through the projects. And just some recent projects. This was two recent competitions. This one is for a stadium in Denmark, 30,000 seats. And it will have timber, but only as a lining. So unfortunately, in terms of where this one came, and again, this was a municipal client, so finding it much more difficult to be as ambitious as a private client, and we continue to find this is the issue. So that this has a concrete bowl structure and a steel roof, and we hope to improve on this, but I think this is not like one giant leap forward and then we just continue to go. We will be coming back and forward and refining and still having to mix. But we also won another competition in a much more exotic location in the South Pacific, in Tahiti. It's for 3 theaters, 1 large exhibition hall and a convention center in the middle. And we set the objective from the beginning to use small section-sized timber that they can supply and produce locally in Tahiti, and to only design the structures based on that type of timber size. So no engineered timber, only looking at what they can supply from Tahiti, and using that as the module, so to speak, to design both long spans and short spans. But all of the structures that you see there, apart from the base, are made in small section-sized timber. And doing so reduced the initial estimates in terms of the overall embodied carbon that this project would have. And I think for us, it's a fantastic design challenge, and it had no loss in terms of the quality or the flexibility or the creativity that we wanted to apply. It's got a very wonderful climate, so that you can have the foyers in kind of these open spaces and then protected by these naturally ventilated canopies. And you can kind of see the structure sizing there, that it's based on very small section sizes, with some steel to do some of the spans, but predominantly small section timber. And it's not very clear, but the longer spans are done using an old design idea that the engineers, Bureau Happel, brought, which is a Belfast truss, something that was pretty common in the war, I believe. And it's used, again, because of the limitations in the war of just having small section-sized timber. You can do long spans by creating this type of lattice with the small section timber. So there are ways, and there are... And that people have not thought about this before. And I think for us, this was a very interesting exercise in terms of how you can really use timber, no matter where you are, to try and find a solution that can deliver a low carbon output. Thank you.
Thanks, Jim. And so our last speaker before the break, previous speakers, remember, don't go too far because you need to have your mugshot taken before you go for your break. But our final speaker is Justin Peckham from Accoya Accsys Systems, and he's going to be talking about validating the 50-year warranty and longer lifespans in timber. Thank you.
Good morning, everyone. My name's Justin Peckham, and I work for Accsys Technologies. That's the company behind the modified wood Accoya. And I wanted to share with you this morning some of our experiences, some of the journey that we've been through in bringing a new high-performance material to the market. It's not just all about production, how we produce this on a large scale. It's how we convince the market that essentially the product does what it says on the tin. So this came in against a background of a common perception of timber as being a sustainable material, readily available material, easily to work. I mean, you only have to have an ounce of practical ability and the right tools, and you can knock up a nice kennel here for young George. But the challenge is that timber rots over time and it moves. And so the timber isn't going to last for very many years. But nor will George. So for certain applications, externally, it's fine. But our company over many years has developed a way of improving the performance of timber sustainably and non-toxic manner so that we can extend the boundaries of performance of timber. But how do we convince all you guys out there that this is the case when your perception is often otherwise? I won't bore you too much with the details of the process because many of you will know this product. And we have a stand upstairs that if you do want to know more. But essentially, we take a sustainably grown softwood and we put it through a process that scientists call acetylation. We can think of it as pickling the wood. And that changes the nature, the composition of the molecules in the cell walls of the wood, such that the wood's cells no longer draw moisture in from the capillaries. And that's the cause of most of the problems with water in wood. You can have as much water as you like in the capillaries, and it's not going to cause the wood to rot, and it won't cause it to swell. It's only when it gets into the cell walls. So what we have done is to engineer a way that stops that water getting into the cell walls. Okay. So this is a very high performance wood. How do we convince the world that it will perform well? Acetylation of wood, the technical term for this process, has been around for many, many years, long before we brought it to the market. But the evidence was in the form of ad hoc trials that didn't necessarily conform to any standards. And the skeptics out there understandably wouldn't accept that as a stamp of approval. So how do we go about convincing the specifiers out there that, particularly in terms of durability, which is what I'm going to focus on at the moment, that it will perform as we said it's going to be? Well, it turns out that there are already standards in place that allow us to do that. We can tap into the system, if you like. It's not a black art. As long as the process is followed properly, we can tap into a series of standards and demonstrate that a coil will do what we claim. And the process is thus. So it starts off with laboratory screening. So there's an EN standard and a couple of technical standards that essentially allow you to assess the performance of a timber over a short period, only 16 weeks, with in-lab tests. So these are small samples, typically a couple of inches by 20 mil by 15 mil, in a controlled humidity box at a set temperature, inoculated individually with one rot species at a time. So very, very much artificial conditions. But over a short period of time, this allows you to get an idea of the performance of that treatment or modification of the wood. And the process, the standard was brought into existence as a means of screening different levels of treatment and modification to find out what is the most appropriate treatment level to achieve the performance level that you want. But in order to get a proper view of how that's going to perform in real life, you really need to do some long-term field testing. And there are more tests available for that, standard tests available for timber. Some are in-ground testing like EN252. Some are above-ground testing. And those typically take about 10 years to do. And then once you've got the results from those tests, you combine them with the EN 113 tests, and through a desk study, you can derive via EN 350 what's called the durability class of the timber, something you might be familiar with. But what is more important for you guys is to understand what's the service life expectation. Durability class is one thing, and that's if you like, an inherent property of the wood, but it depends how you use that wood as to how long it will actually last. Clearly, wood is going to last a lot longer internally than it will do, which is use class 1, than it will do in the bottom of the ocean, which is use class 5. And we're talking here about the external environment, the facades. That's typically use class 3 and bang in the middle of the risk there. So how do you know what a durability, if you've got a durability class of X, how do you know how long that's going to perform on the outside of the building? Well, that's where BS 8417 comes in. That allows you to link those two together. Going back to the start, EN 113, as I said, this is a short-term lab test, and it has its value. But it's not really a proper indication of how that material is going to perform externally over long periods of time. We all understand that testing anything under laboratory conditions is not really necessarily indicative of how something's going to perform long term. However, there have been various industry lobbies over the years that allow us now to take a durability class statement purely from EN 113. Technically, it's an indicative statement of durability. It's not a true statement of durability. And the challenge is that there's quite a few timber products out there in the realms of modified woods that have simply taken those laboratory tests and stated the durability based on that without the long-term field tests. These take 10 years or so it's a real challenge when you're bringing a new product to the market to take the time to do that. But in our minds, that's really important. And that's what we have done with Accoya over the years. So we've done all the EN 113 testing. We've done external tests, field trials for 10 years or so in multiple locations, which is also important. And we've been through the EN 350 assessment, and we've come up with a class 1 rating for durability. If you're planning to use your timber in what's called use class 4, so that's in-ground contact, the standard EN 350 states that you have to do long-term field tests. An example, as I said, is the field trials EN 252, which is a stake test. You literally put stakes into the ground and you assess them over a period of time. And you need to prove to get class 1 durability, which Accoya has achieved, that your performance is at least 5 times better than that of the standards, which would be typically Scots pine, sapwood, or beech sapwood. And here's an examples of the type of tests, these longer-term field tests. So on your left, we have the stake tests. In this particular case, this is one of the tests we did in New Zealand. And then on the right, you have an L-joint test. So this is a test whereby you take your timber that you're testing, you create a corner joint for a window, for example, very simple joint. You spray the wood, you paint the wood. Then once the paint is dried, you pull the joint apart, thereby breaking any seal that the coating would have made. You put the joints back together again, you stick them out on a rack, typically at an angle, to encourage water to collect within the joint, and you assess the performance over many, many years. And as I said earlier, we have undertaken these tests on multiple field sites in a variety of different geographical conditions and soil conditions, as the map illustrates here. And these are some examples of some of the testing. So on the left, this is the stake test, the in-ground test. And you can see the control sample, the pine, in this case it would have been radiata pine, I think, has rotted away after 3 years. We've also had teak in the test, and you can see that's sort of in the middle there. but the Accoya has well outperformed both products, particularly the teak, and way in excess of the 5 times performance that's required for durability class 1. An example of EN330, which is the L-joint test in Hawaii. Again, Accoya after 4 years in this instance, not affected at all, whereas the pine had rotted away. And these are examples of a comparison with, in this case, thermally modified treatments. So the stake joint test, thermally modified wood, has performed not so well. That's to be expected, to be honest. Thermal modification, it's well known that it doesn't perform very well on in-ground tests. And similarly, though, above ground, even though in the L-joint tests, it's not performed as well, anywhere near as Accoya. So this is an extract from BS 8417. This is a table which allows you to take the durability class of the timber you're using. It depends how you use it, but in most cases, you might be aiming for a specific service life in a particular service class. So this table then tells you what is the minimum durability class of timber that you want in order to achieve that. So for example, for external timber cladding, which is use class 3, if you desired service life, minimum service life is 60 years, you need to use a class 1 durability timber. Now, as I've hopefully illustrated, there's class 1 durability and there's class 1 durability. So you need to think carefully and look at the evidence behind that class 1 durability. Is it a provisional statement or is it an actual statement based on long-term exterior coatings trials? And how consistent is that product? Now, how representative is that sample that was tested of the general production of the material? In the case of Accoya, we have a factory in the Netherlands where we make it, and there's a quality control system there. Originally, it was set out by Como, some of you may know as the body that looks after, certifies building materials in the Netherlands. More latterly, we've got ISO 9001. But essentially, we test every batch that we produce. There's a chemical assessment of every batch that tells us how far that batch has been modified. And there's a direct relationship between that and the performance of the wood. An example on the chart here showing that we have a set durability class 1 threshold. We know as long as we acetylate to the minimum threshold, it will be class 1 durability. And you can see here a number of batches, 4 batches on the bottom, and you can see the variation is quite minimal for each batch, but everything is above that class 1 threshold. I'm whittling through this, you'll be pleased to hear. But there's, what about the other properties of Accoya? Durability is one thing. What about stability? What about resistance to things like termites? Well, I've spoken primarily about the durability testing we've done, but there's a whole raft of other testing undertaken, as you might imagine. And examples of that here, termite testing in Australia. So the form here is that you dig a trench next to a termite mound of a known species of termites, and you put a control wood in there, and you test the wood that you're wanting to assess as well alongside it. You dig a trench, fill it in, and then every so often you pull the pieces of wood out and you assess how they've performed. And all the pieces of wood start out with a score of 10, and as they get eaten away by the termites, the score goes down and down. So in this particular test here, you can see that after 10 years, most of the species on test had been gobbled up by the termites. Accoya is affected a little bit, but nowhere near as other timbers. So again, a real-life field test. Dimensional stability is another key one, and I've pinched the chart here from a Trada document on modified woods. They tested a whole range of modified woods, some of which are no longer on the market, for their stability. So how does the wood move as you wet it and then as you dry it out? And again, it scores really strongly in that respect. So I'm just going to finish off with a few case studies some of you may have seen where Accoya is being used on or in the facades of buildings. So there's a project in the States, Ernst & Young building, where Accoya is being used. I think this was mentioned by a colleague at a previous Zak conference, within the glazing as a shading system. Here, the durability is not an issue, clearly, because it's protected by the glass, but stability is. There's a lot of heat there, and you don't want these pieces of wood to move or, worst case, crack. And that concept has been taken on further for a proposed building in office building in California later this year. This is the headquarters for the Roche company in Barcelona. And this is a facade supplied by our distributor in Spain, Gamis, who happens to have a stand upstairs here. But here, Accoya is being used purely for shading, but you need that stability. These pieces, I think, are roughly 25 mil by 200 mil wide, but you don't want these nice straight lines to get distorted over time. So the stability and durability is key for this sort of external application. This is the Wood City project in Helsinki. There are a number of buildings here. I'm not sure no, the laser's not working on here, but there are, at the moment, now 3 buildings there and a 4th one about to be added. And to the right of the picture, you can see the frozen sea, so it's right on the waterfront there. And the story here is that Finland grows a lot of timber, but historically they don't use a lot in construction. And this was a project initiated by Stora Enso, one of the big timber companies in Finland, to promote the use of timber in construction. And so there's a lot of use of CLT in these buildings, for example. But on the external facades, they've used Accoya. Closer to home, this is a commercial building in Ashby de la Zouch, and there's a neighboring building now looking exactly the same. And here the fins are made from finger-jointed Accoya to get the length requirement. You can make Accoya glulam as well. You can engineer Accoya in the same way as you would any other timber. And then it's been stained with a coating to give the required color. And the final slide, I'd just like to introduce a new iteration of Accoya, not yet available in the UK market, but coming soon. And this is, if you like, a pre-colored version of Accoya. We often get asked the question, particularly on facades, how can we bridge that transition between the original color of the wood and the eventual gray patina, which we all have experience of as being quite patchy at times. Well, one solution is to stain the wood with what we call a non-film forming coating that won't peel off. But this is another solution whereby we have impregnated the wood post-modification with a pigment, a black pigment, and that gives the overall effect of a gray colored wood going all the way through the wood. So you can profile this however you like. You can create a textured finish on it. And this is a non-toxic, water-based material that gives you this gray color all the way through. So far, we've tested it in the UK for 5 years external, and we haven't seen any deterioration in that color, but we just don't know how long that's going to last. But that's just something to finish on for thoughts for the future, really. So I'll wrap up there. And if you've got any further questions, then obviously we have a stand upstairs. Thank you for your time.
So it's break time to stretch your legs, get some oxygen moving again. Don't forget to catch up with people, network, ask questions of the speakers. But if I could just ask the speakers to come back to the stage for a photo op, please, from the first session, that would be grateful. Thank you. Hi, everyone. Thank you for coming back. Apologies for some more glitches with the slides, but our next speaker is Philipp Nuscheler from RAICO Systems. He's the head of project sales, and his title is Timber Goes Unitized. Thank you, Philipp.
Yeah, Tim, thanks for the introduction. I'm really pleased to be here today, and the title of my talk is Timber Goes Unitized. And as you may know, unitizing glass curtain walls is pretty common and pretty famous in aluminum curtain walls. But why do we see this tendency to unitize glass curtain walls? And the answer to that might lie in some current and future challenges we are facing in construction industry. So one of these challenges is green building. Everybody knows the word or the term green building, but green building is not just about hanging some buckets with plants in it on the facade. It has to be more. So that was too much. With green building also comes natural construction materials, such as timber. That's why all of us are here today. And as time is money, reducing construction periods is becoming more and more important these days. So investors want to sell their flats or rent their flats and office spaces as fast as possible. That's why we need to find ways to fasten construction periods. And after all, skilled labor shortage is also something I guess all of us are facing this challenge. So it's always difficult to get good and qualified staff for construction, especially on site. You can find qualified workers for a warm and heated workshop, but for the windy and rainy construction site, it's much more difficult to find good labor. Yeah, and when we think about unitizing timber curtain walls, it's also important to know which types of prefabrications or which possibilities in prefabrication timber industry or timber construction currently offers on the market. One option might be punched hole strip windows, but with the punched hole strip windows, it's not really possible to close the whole building envelope. So application for punched hole strip windows is pretty limited. You have a high degree of prefabrication, but you still need exterior scaffold and so on. So that's why, application scope is pretty limited with that. Another option in prefabrication of timber envelopes is the stick curtain wall system with coupling or expansion mullions. So you can prefabricate timber frames with the glazing system already attached, but you still have to glaze it on site. You need an exterior scaffold, so time savings is also pretty limited with this construction at the end of the day. One option which offers a pretty high degree of prefabrication is timber frame construction, which is based on carpentry constructions. So they combine carpentry timber frames with a stick curtain wall glazing system attached, bring them to site fully glazed, as you can see on the pictures. But on site, you still have to install the membranes for the vapor barriers. You have to do building connections, and you maybe also need to solve the joints between the units from the exterior. So a high degree of prefabrication, but still not really unitized as we know that from aluminum unitized systems. That's a variant of timber frame constructions. That's timber and concrete hybrid structures. There are some structural timber pillars already included with the timber framing. So it's just a variation. And after all, a few years ago, we had a project in Luxembourg with one of our customers for which we developed a prefabricated stick curtain wall system just for this project. So it had not really had something to do with our regular stick curtain wall systems. It was really a bespoke solution developed simply for this single project. The project is called the Konrad Adenauer House in Luxembourg, and it was, at that time, they told us it was the largest construction site in Europe. The glazing system, as I already mentioned, is fully bespoke solution, and the curtain wall units were almost completely prefabricated. The only thing they had to attach on site was the pressure plates and cover profiles for the vertical mullions. So they brought fully glazed units to site, attached them to the building structure, and after installing the units, they had to install the pressure plates and cover profiles in the verticals. You see in the horizontal section, it's still kind of an expansion mullion in the horizontal section, but if we skip to the vertical section, you see kind of the key component of a unitized curtain wall, a component which we know from all aluminum unitized curtain walls. It's the saddle gasket. So this gasket makes the coupling of the units and also, for sure, weather protection, drainage, and everything of the construction. So yeah, you can call this solution a unitized timber curtain wall. This is how the units were brought to site or shipped. You can see them on such racks. They were attached to the crane and then brought to the building structure. The target then was to bring this into a system solution which is available for all fabricators, for all window and curtain wall fabricators on the market, and which is tested to all major or mandatory standards you might need to build that. The result then was our Element Plus HI system, a genuine unitized timber curtain wall, which uses timber as the structural material. The frame width of this new system is 50 millimeters each. You can use glass thickness up to 64 millimeters. If there is more needed, just talk to us. We will find a solution. And element size or unit sizes is up to 3 by 4 meters. I will come back to that later. This rendering shows how our R&D department could have made themselves an easy life. The easiest thing would have been just to use aluminum unitized system, which is being equipped with an interior timber cladding. But that was not what we expected from ourselves. So we wanted to go another way. We wanted to use timber as a structural material and reduce the use of aluminum to a minimum. So the aluminum is just an add-on, as you know, from the stick curtain wall systems. And the weather protection, if you want to say so. And the aluminum profiles include all the things for the gaskets and the thermal brakes, for example. Having a look at the horizontal section, you see the structural timber on the inside, the aluminum add-on system with all the coupling gaskets and everything. And in the vertical section, you see the typical key component of a unitized curtain wall, the saddle gasket. In the horizontal joint, we are working with a face width or with a joint width of 21 millimeters. So you have 2 times the 50 millimeter width of the frames plus 21 millimeter width for the joint, plus minus 10 millimeters as a standard. If there's more required for project reasons, we are open to adopt this solution or adjust this solution to fit for your project. Yeah, and if you wonder which types of wood you can use for this curtain wall, it's basically all types of wood we have within our approvals. So it's timber engineered glue or engineered timber glulam from spruce, fir, pine, larch, or oak. But it's also laminated veneer lumber you can use from spruce or beech. And in addition, you can for sure use veneer plywood in accordance with EN 13986 from spruce, beech, birch, or Douglas fir. And last, you can also refine it with real wood veneer, such as bamboo, for example. It's typically timber types which are not really meant for structural timber. So like walnut tree or babinga, whatever you like. You can also use any synthetic materials as a veneer, but I don't think you want to use synthetic materials on the structural surface. On a natural surface, sorry. Yeah, and to brace the corners of the timber frames, we use corner brackets, steel corner brackets. These steel corner brackets serve not only as a reinforcement of the timber frames, but also as brackets, as hooks to attach them to the building structure, and also as the coupling for bottom and top unit as a floating bearing between 2 units of the curtain wall. Here you see you have a male and a female corner bracket, which serve then as the floating bearing. Here you see how it's coupled. There again, we have these 10 millimeters space for tolerances and deflections, for example. You also see the hook, how it can be attached to the building structure, to the brackets you install at the building structure before hanging in the curtain wall units. I'll skip these. Very interesting is the cross point of the saddle gasket and the coupling gaskets. So you have a vertical coupling gasket which is co-extruded. Co-extruded means in that case you have a hard core and a soft shell, and both ends of this vertical coupling gaskets is notched. And you have an additional notching in the horizontal saddle gasket. And before you stick both together to connect them, you put in some EPDM sealant to bond this connection properly, which is just a safer way to have this cross point solved between these gaskets. Yeah, jumping about the technical highlights. already mentioned dimensions of this system is up to 3 by 4 meter, which is pretty much for a unitized curtain wall and especially for a timber unitized curtain wall. So yeah, you can realize pretty huge dimensions with these units. And with huge dimensions also comes huge loads and huge weights. So weight for the curtain wall units is also up to 1,000 kilogram per unit. Air permeability is tested in the highest grade you can reach with the standard, class AE. Same with the impact resistance, E5, I5. The resistance to wind load is tested plus minus 2.5 kilonewton per square meter, which is enough for the most of the projects we are facing. And what we are really proud of is the value we tested for driving rain resistance. This is pretty outstanding for all unitized curtain walls. So we tested 1,800 pascals for driving rain resistance of a unitized curtain wall. And yeah, that's mostly also thanks to the good solution for the cross points between the vertical and the horizontal coupling gasket. And when we talk about timber unitized curtain wall, we also have to talk about aluminum savings. So I already mentioned we tried to reduce the use of aluminum to a minimum. So aluminum savings compared to regular aluminum curtain walls is up to 60%. We compared to a lot of regular aluminum unitized curtain wall systems, and it always was between 30 to 60% in aluminum savings. Yeah, when developing timber curtain wall system, you also have to check thermal performance. So this is what we did. We did simulation for the isothermal lines. You can see on the picture the isothermal lines for 12.6 degree, for 10 degree, stay within the thermal break, stay completely within the system. So no risk for condensation on interior surfaces. I also would like to invite you to our booth upstairs. We brought a sample mock-up with us. Visit us. You can have a closer look to the sample and have a discussion with us. And coming to an end, I will also show you how we tested the curtain wall. We tested the curtain wall at Austrian test lab. The module 4 in the middle is the large 3 by 4 meter module or unit. So yeah, on the pictures in the next slide, you can see this 3 by 4 meter unloaded by crane on site. So we had to do some special transport with a special flatbed truck and everything to transport this from our Bavarian headquarters to the test lab around 100 kilometers away in Austria. There you see the test rig with all the units installed, and to have a feeling for dimensions, this unitized curtain wall on the test rig is more than 7 meters tall in this case, so pretty impressive. And talking about timber glazing systems, we also talk about sustainability. And that's why we want to prove that with several certifications. So we are currently working on the cradle-to-cradle certification together with our partner EPEA and Dries & Sommer in Germany. And we are also working on the release of the EPD for the system, which will be released with the market launch of the system beginning of April at Bau exhibition in Munich. Yeah, and if we were asked if you had the opportunity to design buildings even more sustainably, would you do it? Our answer is we would. Thank you for the attention.
Okay, thank you, Philipp, for that. Next up, we have the Tokyo Marine new headquarters. If I could get our speakers onto the stage, please would you welcome Albert and Claudia from Renzo Piano Building Workshop and Thornton Tomasetti, respectively. Thank you.
Thank you.
Hello. Yeah. So it's a pleasure to be here today and to present you this project, which is a project under development. We are at 50% technical design now, working with Claudia, with Thornton Tomasetti on facade engineering, with Arup on structural and environmental design, and with Mitsubishi Jisho Design as local architect and local engineer. The project is the new headquarters of Tokyo Marine, a multinational insurance company. The building will sit in an extraordinary location right in front of the Imperial Palace and at the center of Marunouchi, which is the financial district in Tokyo. Right at the crossing of the main commercial axis of the district, which is called Nakadori Street, and the kind of institutional axis which links together Tokyo Station with the Imperial Palace. The project is a large scheme. It's 120,000 square meters, 100-meter tall, but in the context of Marunouchi, it looks quite contained, actually. The project will not stand out by its size, its height, but it will stand out by its carefully balanced proportions, the crystalline appearance of their facades, and by the strong presence of the wood structure. The concept of the building is simple, but yet very strong. A forest of wooden columns rise up to the sky, 2 meter by 2 meter at the bottom, 1 meter by 1 meter at the top, like tree trunks, and they will support a cubic mass of 84 by 84 by 84 meters, which is lifted off the ground 16 meters, so as to leave room for the public realm to occupy the indoor space beneath the building. That cubic mass will have a patio measuring 24 by 24 meters in plan, which will bring light all the way down the building on all the floor plates. And finally, at the top of the building, 75 by 70 meter roof forest will be the perfect amenity for Tokyo Marine employees. The wooden columns not only provide support to the massing of the building, they also constitute one of the essential elements of its appearance and its soul. The perimeter columns sit within the facade, within a cavity facade. The external skin of this externally ventilated cavity facade protects the columns, and then the columns form part of the thermal line and brings down the transparency ratio to somewhere around 55%, improving the energy efficiency of the building. At the corner, the external skin stops and the wooden columns at the corner reveals themselves, and we can see the column going up uninterruptedly from floor to the top. That's the east-west section of the building. showing 2 basement floors with parking and MEP at the very bottom. And above these 2 floors, we have a base isolation layer which protects the superstructure from direct seismic action. Then above that, we have the public floors, 1 basement floor plus 3 floors of the superstructure, which are open to the public, to the city of Tokyo. And then we have the sky lobby, which liberates the ground floor from performing a reception, from acting as a reception. Office floors on top of that, 13 office floors for 85-meter floor-to-floor height. And at the very top, we have an MEP floor with all the services in order to liberate the rooftop for the roof forest. So the roof forest at the very top, it will have around 200 trees, and that roof constitutes a kind of oasis at the center of Tokyo, an inspiring and quiet place where to relax, to stroll around, or just to enjoy the views of the city. The forest will be designed as following the concept of Satoyama, which is a man-made forest, which is left to grow quite freely, not manicured at all. And then there's going to be a band free of vegetation between the canopy of the trees and the ground covering plants, so that everyone can enjoy a 360 view around the building. At the very center of the roof garden, there's going to be, of the roof forest, there's going to be a sunken garden with a small pavilion for the celebration of the tea ceremony, the perfect refuge from the city. And then going down, that's the typical floor plan. The core has been located eccentrically to the east, so that the main area of the office floor plate can be organized to the west, where the best views towards the Imperial Gardens are. Then the office floor is organized around the patio. The patio becomes a bit the heart of the building. It encourages views from one floor to the other, and 2 convenient staircases, which are located on the north and south ends of the patio, allow for the people to go up and down easily, and encouraging encounters between employees. We can see the presence of that forest of wooden columns organized on a 12 by 12 grid at the center of the floor plate, and on a 12 by 16.2 grid at the perimeter. And then for the office ceiling, most of the office ceiling is covered by radiant panels to procure comfort to the employees. But then on certain areas at the perimeter of the floor plate, and also whenever the columns touch the soffit, we don't have radiant panels, and then the CLT is exposed. Resulting in this CGI where we can see we have a 325 clear height below the radiant panels, but then once we reveal the CLT, we can achieve a clear height of 425. And then we have this kind of loft-like appearance, an informal atmosphere, which is also reinforced by the arrangement of various furniture. And then we go down to the ground floor, to the ground levels, which have been conceived as the natural extension of the public realm. The facades are very transparent all around, and everything is there to encourage people to come in and to profit from the public activities that will take place inside the building. That's the main entrance, one of the entrances to the building. In one of the corners, we can see the columns forming an arcade around the building. Then on the west facade, multi-purpose space that can accommodate lectures, concerts, or exhibitions, and to the north, facing the bottom of the patio, the garden, a cafe. The initial ambition for the building was for the whole superstructure to be made of wooden columns and CLT slabs. and with steel beams in order to cover the 16.2 meter spans. But we soon realized that that would not be possible. That was not possible because the manufacturing capabilities, domestic capabilities in Japan cannot procure the necessary amount of wood in time. So we concentrated our efforts in having the office floors in a wooden structure with wood columns and a hybrid of CLT and concrete slabs, and then steel beams. It was the initial plan. And then for the lower levels, we would use steel columns. And that would also align with the client concern of having structural wood exposed at the lower levels to the risk of flooding, which is very present in Tokyo. But then we were very attached, and actually the client was very attached to this idea of the tree trunks, of the forest of columns raising up to the sky. And then we introduced the mass timber cladding as the element that could actually join together the steel columns at the bottom and the wooden columns on the office floors as a single vision. Aside from bringing warmth to the building and the visual appeal of timber, the client also want to fulfill certain ambitions with the use of wood. One being that the wood could convey the symbolic and historical significance of wood construction in Japan, which is very present. Obviously, trying to reduce the embodied carbon footprint of the building. Given the enormous volume of wood that we are mobilizing, also that this building can foster the forestry industry in Japan, and finally to boost the Japanese timber industry in the country. But we wanted to be kind of honest in the way we use the wood. We were not trying to add cladding to the mix as to kind of pretend that the lower columns are in actually glulam timber. So the timber takes a different expression depending on where we are using it. And we created a kind of catalog, different shapes of cypress, because the wood that we see is in cypress. And on the left-hand side, we have the timber mass cladding with open joints, 4 millimeter wide, to allow the wood to expand. And then on the right-hand side, we have the finishes for the internal columns in real glulam, and for the surface of the CLT, and everything in two grades. The lower grade with more knots, which is called NAM in Japan, and a higher grade with less knots or smaller knots, which is called Joko. And then we can see how the cladding is extends on the building. That's the detail at the lower levels when the cladding is covering the steel columns. An image of that cladding. Then higher up, the cladding covers the external face of the wood columns, and it's contained within the cavity, the facade cavity. That's a mock-up that we prepared in Genova in order to get a feeling of the scale of the project. A CGI of how the cladding and the column is integrated in the cavity facade. An image from the interior, how the cladding externally and the wooden column inside relates to each other. And then the image of the corner when the cladding gets exposed to the outside. And then a note on how the columns are done. We are using a system that has been developed by Takenaka, who is the contractor of the building. It's called Moen wood, and there's the load bearing part contained at the center of the column, and then a char layer at the perimeter. And in between the two layers, there's those infills, mortar infills that constitute the fire stop. And everything is a kind of a monolithic glulam piece, and the mortar is poured from the top into the infills. And this system is certified to 2 hours. They are trying to certify it for 3 hours now. But the problem we had is that the factories cannot handle a column of the size we need in the project, which are as big as 2.2 by 2.2 in certain areas, 2.16 to 2.16. So then we decided to actually manufacture the column in 4 different pieces, which would be bolted together on site. And the pieces then would be much smaller, of around 1 meter by 1 meter. And they would be bolted together and then fixed to the steel splice piece that connects each column with the next one. And this is how the column construction sequence look like, where we bring the 4 pieces constituting the column on site, and they are bolted together downstairs on the ground. They are installed on the splice steel piece. The char layer is installed in order to constitute a monolithic column. Mortar is poured, and everything is craned up and installed on the existing structure of the building, connected with the steel beams, and concrete is poured into the splice steel connection piece. And then the slabs, there was the ambition to use CLT slabs throughout, but the fire regulations in Japan are quite stringent. Actually, structural wood needs to withstand the prescribed time without the temperature going beyond 260 degrees. So if for our slabs we have a 2-hour fire rating, the slabs needs to withstand 2 hours below 260 degrees, but also need to maintain or not to exceed this temperature for a period of 8 hours, a cooling period of 8 hours that after the exposure to fire. So we have these two graphics here. This is a testing that was done on another specimen. That's the furnace temperature profile. During 2 hours, the furnace increases its temperature to above 1,000 degrees, and then the furnace is turned off, and temperature goes down quickly. Whereas we can see for the CLT how it goes up for 2 hours, and actually once the furnace is off, the temperature still goes up. So that's a specimen that would fail because the temperature would be exceeded during that 8-hour cooling period. So we needed to use a system, which is the section that we can find at the center, that is capable of aligning with the requirements. And in the end, we see that it's a floor buildup very complex with a lot of layers on top of the CLT. We have the CLT 210 millimeter CLT. At the bottom, we have 50 millimeters McKeevy, also wrapping the beam in order to avoid thermal transmission from the beam onto the slab. And then on top of the CLT, as the McKeevy is not allowed, we have 80 millimeter concrete and 40 millimeter self-leveling plaster. And when we compare that certified system with a 150 millimeter concrete slab, we can see that the embodied carbon of the 2 options, which are the 2 columns on the right, the embodied carbon of the 2 options is actually pretty similar. And then we were doing a bit of research, and then we realized that by using the CLT as both formwork and also to increase the habitability performance of the slab, which is the section at the top, with this we could actually reveal the CLT and expose it. And we could also achieve a much better embodied carbon for the floors. And that summarizes what we have achieved in terms of embodied carbon, thanks partly to the timber structure and also thanks to the use of low carbon concrete with cement replacement. It's a 35% reduction in comparison with recent developments in Marunouchi in Tokyo's financial district. And we the adventure will go on. We hope that this building will be useful to actually push the regulation boundaries forward in Japan, because right now are very strict and it makes it difficult to build in wood. And we also hope that the Tokyo Marine employees will call at some point this building their home. And now I'll hand over to Claudia to go on with the presentation.
Thank you. So I think some of you might have seen my presentation last year at the Zak. It's not the first time that I work on a timber building or on a timber project. And I've got, as you would imagine, a cheat sheet, which is my summary to everything that I need to worry about when it comes to timber. Mostly it's timber cladding, because I'm a facade consultant, but I might have understood something about mass timber and structural timber during the way. The really nice challenge for this project was trying to transpose what I've accumulated as a kind of a knowledge or understanding, limited as it is, over the years, according to European regulations or British regulations, and trying to see if that applies to Japan and how it applies to Japan. And I think the answer is yes, it does apply to Japan, but Japan is a very unique place, so it applies in a very unique way. And it was quite a steep learning curve. I thought I got it, and then actually I had to relearn it all over again. So when I think, or I support architects thinking about timber, what we normally look at is a series of parameters and criteria. Many of them contradict each other and they have to be balanced out. There's always a trade-off between what you want to do, what you can do, what you can afford to do, and where it's coming from. So first and foremost, from an architectural perspective, is the visual quality of the timber. What does it look like? What's the appearance, the number of knots, the type of grading, and all of that. The geometrical stability is super important. Over time, will you need to design joints and fixing systems to allow for a large amount of shrinkage, a large amount of warping, and clearly the weather and the climate in Japan is completely different from, I don't know, the weather in London or designing hospitals in Greece, which is a completely different weather. The resistance to biological attack and rot, the UV degradation, which is unavoidable. It's the color changes in the timber, but it's very much dependent on the treatment and the species that you use, and clearly what is available in one continent is not necessarily available in the other. The resistance to fire is an enormous discussion that I will talk about later. Maintenance is a big thing. How easy it is to access this timber for maintenance, how open-minded is the client in terms of which maintenance regime is accepting to apply to his building. I think it needs to be a very open and straightforward discussion. And procurement. So it's pointless to talk about timber without thinking about where it's coming from, can they do it locally, what's the value of it, and do they have enough quantity. So there is this balancing act between what is necessary for legal requirements, which is very different in Japan, what's the aspiration from the architectural and design team perspective, and then what's the availability. And we are talking for this project about a few thousand cubic meters of timber. It's not a small building, it's not a small quantity. You cannot improvise and think that you're going to put all of it in a container and it's going to come from another place. It's also been quite a learning curve in terms of terminology, because what we call a quality grade here in Japan is called with another name. What we call limited combustibility, they call it non-combustible, for instance, which can be a source of quite a lot of misunderstanding or clarifications required. The important bit is that Japan has a very long and established tradition of woodworking. We wouldn't want to invent the wheel. We know that they can do it, and we also know they have a very strong culture of maintaining the timber building. That's what they do for the temples, that's what they do for their houses. It's part of the culture, and I think it's extremely beneficial for a project like this. It's also, this picture I think is important because it explains why there are some other not necessarily tangible criteria that might define selection of the timber. In particular, the use of cypress was driven by availability clearly, because it's a good type of timber and all of that, but it also smells. It's normally used in temples, and clients love it because it has a very peculiar smell. When they smell it, it kind of brings to their memory, and they hope that it brings to the memory of the employees the sort of peace and cleanness and purity that they experience when they go into temples. So we've been debating for a bit about the relative benefits of cypress versus Japanese cedar. And I think the cypress kind of won because of the smell of it, which is, as I said, it's non-tangible, but how can you not consider that? I might be a bit of a romantic, but I think I can sympathize with that. What we really wanted to do for this project was trying to understand what the limitations of the rules were, what were the Japanese code asking for, and then go above and beyond, because there's no point in ignoring all the learning and all the experience that we've gained from what went wrong in other countries. So the Japanese code at the moment is extremely focused on structural integrity when it comes to timber. But they are not worrying so much about surface spread of flame or combustibility of the surface, the same way that we do in the UK, for instance. So we've been having long discussions about what it means to have a timber cladding, for instance, versus a timber column, creating a cavity, putting the timber cladding within a double skin, which already has a cavity, and what would be the implications in terms of fire. So the recommendation from the local engineers is that there should be a non-combustible treatment to timber. We're having our honest discussions about what they define as non-combustible. We think is limited combustibility because that's what we can get, but it's not a code requirement. So we are trying to set a very high standards with what we want to procure, and at the moment we don't yet have a clear answer. What we know is that we've gone through a process of sampling, big sampling and discussions. What we think we're getting is cypress, broadly speaking, an equivalent quality to a J20 that we would have in the UK, chemically modified with a treatment that is compatible with glue laminating. We've been discussing a lot about what it means aesthetically, depending on where this cladding is located, to have flat grain or finger jointing. We know that there's one clause in the Japanese code that requires particular type of glues to achieve that. So we know what that means in the reality. We've been talking about surface finishes as a combination of surface treatment, how rough or how smooth the surface can be, and it doesn't need to be the same treatment everywhere, and how that would help achieving the performance that you want once you do a fire treatment and or a surface coating. And that's a very, very difficult conversation, because at the moment, what I would take out of my cheat sheet and say, yeah, that's the fire treatment you need, and that's the surface coating that you need, which is compatible with that, problem solved. That product or that range of products does not yet exist in Japan. So they don't have the same type of classification certifications for fire retardant treatments in external application. They might have something for internal application, but not for external application. And we've got quite a lot of surfaces which are external. So what we are doing, and we are at the end of the presentation, what we are doing, we're going to start an accelerated testing for all sorts of different permutations. It's all cypress, but we are essentially trying out 2 or 3 different treatment, which will be essentially chemically modifying the cypress, plus different types of coating and different types of fire retardants. We're going to put them into a process which is Japanese, according to a Japanese standard, fairly similar to the European standard for accelerated weathering, but not quite the same. And that's going to be evaluated over a period of time. It will require quite a few months before we get to the end of it. In the meantime, and in parallel, we're going to have larger mock-ups of the products and with the timber and the finishes that we think have got the higher chance of working, and they're going to be placed on the outside of a building, and they will be left to age naturally, exposed to the environment. What we are trying to gather out of this test is understand how the appearance changes, and we are very aware of the fact that we've got a timber column, for instance, on the corner of the building that at some point goes from completely external to completely internal, going through corners where they may be semi-exposed because it's encapsulated within a double skin. So we want to evaluate how that changes over time. We want to evaluate what the treatments and the coatings are going to do and look like over time, if they are at risk of leaching, and what's the method of maintenance and the treatment of maintenance. We are still debating about the benefit of accepting the grey or fighting it. I think that's up for discussion. Personally, I don't think we've got anything against the timber going grey. The client has a different opinion, so we were hoping that the pictures would persuade the client that there's nothing bad with it. So that's it for the presentation. Thank you very much for listening.
So thank you very much for that. And our next session is a panel discussion. So hence the chairs arriving hastily on my left. And this will be a discussion around the black and white building in London, which has already been mentioned a couple of times. So our panel is from the design team, client and contractor. And our moderators for this session are Kelly Harrison, a structural director at Whitby Wood, and Dave Lomax, who's an associate director at Wall Thistleton Architects. So if you'd all like to make your way up to the stage, that'd be great. Thank you.
Sorry, got coffee this time.
Okay. Oh, yes, microphone's working. That's good. Good afternoon, everybody. We're here all today to talk about the black and white building, as Tim already said. So just to introduce the panel here, my fellow moderator, Dave Lomax.
Hello.
Sophie, from the lead architect at the office group, the client. And we've got Ben Buckley from the excellent Gallagher, sound engineer, and Nick Horton from Pacegrade, facade contractor. Yeah, I think we'll just kick off, and everyone's going to do a little presentation about their involvement in the project, and then we'll run through some questions.
So I'll just start from the client perspective and give a bit of a background of the kind of approach that we took to the project and the brief that we gave the team. We are an office space provider, flexible workspace in London, but also in Germany. We've got over 70 buildings covering 3.1 million square foot. We're a developer, but also an operator. And we really focus on designing to deliver a sense of ownership and flexibility for our clients. Our approach is that we always take each building individually, so their location, the community, the audience, that's all taken into account with the design. We really focus on how buildings perform over time because we're an operator. And that might be through the design excellence, functionality, longevity, but also since the beginning, since the inception 20 years ago, we've had a real focus on sustainability. In the first TOG project, there was a green roof that clients would harvest potatoes from, and there have been solar panels across a number of our projects, but also we've really taken a retrofit first approach up until the black and white building, where we just try and refurbish buildings and make the most of the existing features. But as I said, this building was our first from the ground up building, and as such, we just really wanted to make sure that we were championing sustainable construction practices, that we were really tackling our embodied carbon as well as our operational carbon. And that led us to work with Wortheston. So a little bit of history on the site. You'll see from the photo just behind me, this was actually one of our original TOG HQs. It's on Rivington Street in Shoreditch. So we knew the area really well, we knew the site well. We acquired it in 2013, and it was an old kind of former timber lacquering warehouse that, Shoreditch is really well known for the furniture industry. And we took some time to really get to know the building in the area. We were using it as an office space. It was about 10,000 square foot for several years. And it came to the point where we really needed to maximise our site. And it was a difficult decision to take the building down. But as I said, if we were going to put something back, we wanted to make it the most sustainable building that we could. Our co-founder, Charlie, met Andrew War from Wortheston. And I think Wortheston's kind of passion for timber is so infectious that it really drove us to believe in the whole commitment to doing a fully mass timber building. So columns, beams, slabs, the curtain walling system that these guys will talk a bit more about, but also into kind of all elements of the design. Just a little bit about the building. Dave's going to go into more detail about it, but we're really pleased that through this adoption of mass timber, we could reduce our embodied carbon by 37% compared to a traditional concrete or steel construction. It's 7 floors, about just under 40,000 square foot. We've got another 3,500 square foot of external space. About 25% of the whole building is communal for our members. And like I said, we really wanted to make sure that we took that sustainability agenda through all elements of the design. So we focused a lot on working with local designers and makers. We collaborated with Daytrip Studio, who are also very local to the area for the interiors. And we sourced 95% of our furniture from either designed or made in the UK. Most of it was designed and made in the UK. And that also kind of pervasive thinking went right through to the kind of collaboration pieces that we did along the way. So we worked with the Poor Collective, who are a Power Out of Restriction collective, to kind of nurture that next up and coming generation of designers. And we took 3 students and paired them up with makers that we had creating bespoke pieces for us, and gave them the brief to create pieces for our project. And I guess this is just to say that if you really let that whole sustainability agenda into every aspect of your design and process, you can actually get a really rewarding result across all different aspects. And that we really hope that the message kind of goes beyond this building. To us, it's a statement to the real estate industry that it is possible to build better, to build more sustainably, and you can create a really beautiful space that clients love as much as we do. And I'll pass it over.
Oh. Yeah, thank you very much. Right, am I on? I'm on. Right, the warning for this bit is I'm going to try and tell you quite a lot of stuff really very quickly. So given we're being recorded, maybe it's if you've got the podcast half speed button, maybe you can watch it back. But I'm quite keen that we get a chance to get the conversation bit. So I'll give you a quick overview of who we are, what we've done, and hopefully why we've done it. So here's us in sector appropriate gear. We don't make everybody dressed like lumberjacks every day, but that's one of our Christmas card photos. But what I think it says is that, we are not a huge practice. Whilst we think we punch a bit above our weight and we think we're world leaders in a particular sector that we're really passionate about, actually a large part of what we do is to try and make change, not to make every building. We can't do every mass timber building that happens in the world. So what we do alongside designing buildings is we generate new knowledge, we do research, some of that for the EU, some of that you've heard about this morning in terms of the Building Wood, funded by the Louders Foundation and Built by Nature. And we publish books, studies, all those sorts of things to share. But the top image is, not just a kind of humble brag that we were shortlisted for the Sterling Prize, but I think what's incredibly important to us is that sustainability should not be about compromise. It shouldn't be about having less, doing less, having lower quality spaces, having mice running up and down your hay bale walls. It should be about really high quality architecture aimed at the people using it and their needs. So we share all over the world. We currently have projects on each coast of the US, one breaking ground in Milan. And people often ask, well, what this mass timber thing, surely you can't do everything in timber, can you? Well, I think our answer is probably yes. It only really stops at what should you be doing? And there's a conversation around very tall buildings. But here I think you can see the kind of scale and breadth of the work that we managed to get out into the world from our little office of 25 in Shoreditch. I think I'm preaching to the choir here, so I'll do this bit a little bit quickly. But for us, it's not actually about wood, it's about carbon. We've done lots of buildings where we cover up all of the wood. We're really excited and glad to have the collaboration with TOG where we can tell a bigger and louder story. But for us, it's about the fact that, yes, maybe over the course of 50 years of lifespan of a building, the operational carbon becomes the majority of carbon emitted. But I don't think any of us are talking about having 50 years to solve this problem. So if we don't start talking about embodied carbon right now, we are not going to achieve the things that we set out to achieve. We're not going to hit 2, maybe even 3 degrees of global warming. So that's why embodied carbon is so important to us. And when you consider that iron, steel, and cement from this World Resources Institute graph make up about as much of the atmospheric greenhouse gases that are emitted every year as all of the residential buildings in operation, given everything we're doing about operational energy, it seems to us absolutely fair game to look at that equivalent 10% of embodied carbon going into making buildings. And our message to the room here today is actually similar. I really liked Tim's fact earlier about this 250 multiplier of your handprint against your footprint. And this message is to reinforce that. I'm not saying don't go vegan, but I'm saying that pretty much everybody in this room has agency over massive, massive decisions that can make much bigger impacts. And that's why we go out and share, and that's why we tell people about our work in this way. I think you probably all, by virtue of being here, know about carbon into trees, trees into buildings, but the principle is about keeping that carbon in the place where it can last for the longest whilst we regrow those trees in the forest. But a really important part that was part of the black and white building is people often ask me, how do I make a building out of wood? How much is a building made of wood? And actually the big question is, well, have you designed a building first or have you designed a building made of wood? Because it is not a straight line. And I think one of the opportunities of black and white that was fairly unique was the opportunity to have a client really engaged in this from day one, a client that really wanted to continue their relationship with the building into the future. And so we could start to make really bespoke decisions about the structural technologies that we look to implement. So building in Shoreditch, East London, funnily enough, we've got a hybrid steel and timber building right by in the dotted line there, which is on Curtain Place. But as you can see, a relatively modest building in the first instance with failing foundations, crumbling brickwork, really not viable for refurbishment, albeit that actually, as part of the BREEAM requirements, we diverted 80% of waste from the site away from landfill. So we were still thinking about the impacts of that. The timber columns and beams have been repurposed and retooled as permanent art pieces within the building. So not even on day one saying, well, look, that's gone, let's deal with it. But thinking really carefully about that. Quickly, you can see some constraints. We've got a railway line to the top left there. We've got a very narrow site frontage and a yard attached to Rail for London to the northwest. Diagram of the building is concrete basement and then 6 floors of wood above. But I think just talking about those constraints of a narrow site and the adjacent railway, you can see from the plan on the left, actually, whilst lots of the photos show a very glassy building, it's actually only about 57% glazed on every floor. So really important to us from day one, not to design problems like lots of overheating and then design solutions using more materials. Actually, this is much more about the constraints we have on the site to deliver glazing. Key stats, I'm probably going to click off before you've read them all, but I'll dwell very quickly on the kind of extrapolation of that 1,774 trees that Sophie showed you, which is, if we're talking about this availability of wood and our ability to replenish it, we need to think about where that wood comes from in the context of the whole forest. So all this wood in this building is from Germany, in the particular forest that Zublin and Pohlmeier operate and take their wood from. If we look at the whole forest growing at the same time, about 52 minutes of wood in this building. So we think that's pretty achievable for a lot more. But also, we're building really quickly. So a few facts I'll throw at you here. Hopefully they'll come out a bit in the discussion later, but kind of crazy. We get why people build basements. There's value in them, but we'll come back to the impact of the basement in a bit. But it took us 32 weeks to get a building down, dig a hole, get to ground floor. Then it only took us 14 weeks to erect the rest of the building. We had to make really clear, careful, and bespoke decisions about different types of timber technology. That was helped by having an end-user client to talk about how to move services around the ceiling. But, you know, some counterintuitive decisions, like choosing a much more expensive product in LVL, but gaining lots of floor space. So the columns here are absolutely comparable with a steel or concrete equivalent. They would have been about 100 mil on each axis bigger had we used glulam. So little things like that along the way. Mapping daylight onto the building. So every component of the architecture here has a function. There is nothing that is, we like this, therefore how can we make it in wood? It's not about saying, I've thought of a shape or I've thought of the best color of pink this week, now how can we make that into a building? This is a building where the design of the architecture for timber, for TOG, for people, works through the layers of the building and becomes the architecture. So in a similar way, using really advanced tools like mapping parametrically sunlight data onto the facade, we get to a solution for the potential overheating with the minimum amount of material whilst being able to see the timber from inside, which then becomes part of the architecture. So all of this is about how can we layer up super functional things into a sort of an architecture of sufficiency. How can we get the most from the absolute bare minimum that we have? So here you can see the louvers change depth and opacity as we go up the building. But none of this is about compromise. And hopefully when you see the photos in a second, you'll see that all of this is also about a really, really high quality product. So here's, well, I mean, I would call this the proof. It didn't actually go quite this fast, but you can get a sense of how erecting an off-site manufactured component from a very narrow site frontage can be a real benefit. And we were going up about a floor per core, if you like, front and back, although it's only one core, per week, with about 6 to 8 people on site. This was erected during COVID. So if you've only got 6 to 8 people, that's pretty good for social distancing. So that wasn't quite the bump in the road that perhaps it might have been. So here you can see, I'll quickly flick through some pictures. Here the evidence that, you know, it's coming straight off the lorry, onto the crane, into position, small numbers of people, skills that, you know, we don't like to talk about low-skilled jobs, but these are people with transferable skills. So this is being competent person on construction site. This is not 7 years City and Guilds bricklayer, because ultimately all we're doing is designing this building to be simply assembled with bolts, preferring bolts over screws and screws over glues is our rule, so that we can take the building apart again in the future, if indeed it becomes redundant or needs to be changed. And here's some of those spaces starting to emerge. Our most Instagrammed building yet, so you know it was quite striking to see this timber structure go up on the street side. We always like to put in a little before and after. You know, did we do what we said we would do, Sophie? I mean,
I think you have.
Yeah, I think so. So you know, some changes on the way. Ollie talked earlier about opening windows. That was something really important to TOG and to us, that people had control and ownership over their environment in the building. They changed size slightly. I think those big windows there were a bit ambitious, but I think we've delivered pretty much what we said we would, and we're really proud of what we've achieved here. Flicking quickly through the photos, because I know you've probably seen half of these this morning already. But just to kind of finish the story, I think it's important to say that we don't just make all these claims and then not test them. So we have established not only the carbon impact of the building itself, but also comparing that against various different standards, and also a model concrete equivalent. So what you can see in this graph is that for the equivalent concrete building, we would have used about a third more carbon, or actually, sorry, I'll put that the other way around. The timber building is a third less embodied carbon at Letty stages A1 to A5 than the concrete equivalent. But if we then go on to include the sequestered carbon, and the disassembly of this building is a big part of that story as well, we can talk about a building that is actually 2/3 less embodied carbon. Where does all the carbon go? Well, so close your ears, Sophie. We know why we've got a basement, lots of good reasons, but actually still a third of that is in that concrete substructure, albeit lighter than it would be with a lighter construction material. So to put that in context, the equivalent concrete building at 670 there on the left, the timber building as built in the middle with sequestered below the line, that gets us from a Letty target D building down to target B. But again, depending on how we design our buildings to reclaim components, keep that carbon in the timber for longer than the life of the building, we could be talking about a building with sequestered carbon that is 70% better performing through those stages. There you go. I told you it'd be quick. I set myself a budget of 10 minutes. I've done that. So I'll pass across and let Ben tell you a bit more about the facade engineering.
Lovely. Thank you very much. Oh, where's it gone?
Uh-oh. Pressed the wrong button.
Have I? Oh, hang on. Right, I seem to have lost my presentation, so one second.
While we wait for that, perhaps
Lovely.
I have a quick question for yourselves, if that's okay. You touched Dave, on sequestered carbon and demountability. Was that also designed into the scheme in terms of details and connections? And
Yeah.
how did you achieve it?
Yeah, absolutely. I mean, it's a really big part of our work. I mean, as you know, we do a lot of funded research pieces. You know, a big piece of funded research that we're doing at the moment is for the EU to try and kind of systematize the way we build in timber against EU building codes, against the products we got. We're doing test data work on that. But, you know, through that whole process, we keep hitting this barrier of, yeah, that's all great, but isn't that going to be biofuel in a week? Or isn't it going to go into OSB or MDF and go into a bar fit out and go in the bin 6 months later? So kind of taking that really holistic view of all the products available on the market, detailing how they all go together with lots of other products, has really fed into this way of thinking to say, look, it's all very well saying we've got a vibration problem, we've got underfloor heating, let's bury it in concrete. Well, look, that doesn't give us that potential to reclaim high quality components. So that layer of it, specification, careful connections detailing, you know, substituting dry and back-to-back tolerance products like screed boards rather than poured screeds. That's a really important part of it for us.
Thanks. And Sophie, I was just wondering, now that the building's finished and you started to use it, what feedback are you getting from the user? How are they enjoying the space?
We've been really pleased with the response. Those that have moved in already really like the space, and we get comments a lot about the smell. I think it came up in the previous lecture, but you can really tell even from like day to day, season to season, it's smelling different, you know, from the summer to now. And I also think because it's so visible, the CLT, the LVL, it's all exposed everywhere, it gives this really lovely warmth to the space that you wouldn't get if you were just, even if you painted it yellow. It's not the same kind of tangible connection back to the timber. So that's been really well received, yeah.
Great.
Right.
Lovely. Thank you very much for sorting that out. So I just wanted to talk a little bit about the facade and the practical issues that we had to face during the design, and a little bit through the construction as well. So I was going to talk a little bit about the way that the curtain wall was conceived during the design stages, then a little bit about the movement of the structure, how we could accommodate that, and about fire compartmentation, which was an issue that we had to talk about, and then a little bit about the procurement process of the shading fins. So the architectural intent really, or the architectural brief was to try and frame out the structure with a curtain walling system, really to try and expose the structure as much as possible. Now, in order to do that, the key challenge really was incorporating quite a large spandrel at the top in front of the beam to expose the beam. So we went away and we kind of conceived and proposed a stick curtain walling system that spanned from slab to slab. We had some tall mullions near the columns, and then some smaller mullions between the top of the beam and below the beam above. Now, with a stick curtain walling, what are the issues? Well, we need to think first and foremost about how to accommodate that movement within the curtain walling system. So we do get the typical movements such as live load on the slabs, wind loads acting on the building, leading to some interstory drift of the building itself. But not only that, we also need to think a lot about shrinkage and swelling of the structure. So a piece of lumber will swell differently depending on where it's cut from the raw piece of timber. You might get some radial swelling, some tangential swelling. Now, how does that translate to fabricated timber elements? In this case, we have Balbuca beams supporting the facade, shrinkage and swelling varied depending on which orientation you looked at. So that all needs to be taken into account. In addition to that, we need to think about the swelling rates at the time of manufacture, at the time it's completed, and within and once it's in a heated environment, and that can vary from 12% up to 18%, and then back down to 8% once it's in there. So, how did we do that? Well, first we had to coordinate quite stringent requirements with the structural engineer in terms of which was EOC as well. But we had to coordinate quite stringent requirements in terms of the beam deflections to support the facade. And in addition to that, we knew that we couldn't accommodate all of the deflections, so we had to introduce some larger transoms horizontally, which were 80 mil thick, and we ended up having vertical 60 mil mullions so that we could accommodate a little bit more movement. Now, another issue that we faced, so the whole concept of the building during the early stages was to have a single fire compartment across the building, which was agreed with the fire engineer and building control at the time. Since then, since 2017, we've all seen quite significant changes in the building regulations since then, and also in fundamental interpretation of the regulations as well. Now, in stage 5, there was a change in stance in building controls view on this, and we had to introduce a fire stop between the glass and the timber to ensure that we had compartment floors at every level. And what that led to is that during the early design stages, the idea was to have a transparent facade so you could see through the beam. In the end, we ended up having to accommodate that fire stop and apply a frit, which Nick, I believe, will go on. We'll talk about a little bit later on. Now, a little bit about external shading. As Dave mentioned earlier, we kind of carried out some solar studies. Really, the idea was to try and minimize the depth of the vertical shading on the outside to minimize material. And so we conducted some solar studies and tried to optimize the depth of the fins depending on the elevation of the building and the orientation of the facade, and ended up with a range of fins between 100 mil and 250 mil, depending on where they were installed. Now, moving on into, we also went through quite a few timber species that we wanted to look at, but Tog and Moore Thistleton were quite attracted by tulip wood, which is American hardwood. And there are 2 examples here which are in the UK. One was the Smile Pavilion built for the London Design Festival in 2016, and the other is Maggie's Centre by dRMM Architects. So we engaged with the American Hardwood Export Council, and they provided some very useful data on the strength classifications. It wasn't a timber that we necessarily knew too well in the UK. But one of the beauties about tulip wood, it's a hardwood that's grown quite abundantly in the US. We have a growth rate of about 35 million cubic meters per year. We harvest about 13 million cubic meters per year. So we end up with a net growth of about 22 million cubic meters per year, which is quite significant. So it's a very sustainable source of timber. Now, we checked the different types of strength that we could get with tulip wood versus other types of timber. We checked the durability as well. And the raw tulip wood actually performs quite poorly in terms of durability if it's untreated. So we had to go through a thermal modification process to improve its durability and ensure that we could achieve the design life that we wanted. Another issue that we had to face was fire again. So we had to take into account the fire spread over the facade. And with the fire engineer, we understood that we had to achieve Class B for these tulip wood fins to ensure we were fully compliant. So tulip wood has not been tested with a fire retardant resin before, so we ended up having to impregnate it with a fire retardant resin and get it tested by Warrington Fire. So those are it underwent quite a few processes. In terms of procurement, from the lumber which was sourced in the US by Northland Forest Products, it then went through that thermal modification treatment in the US. That took overall 5 months to do, after which it was shipped over to Vincent Timber in Birmingham, where it's machined and planed. It then went to the fire treatment facility to be impregnated, which took another 9 to 10 weeks, and then sent back over to Vincent Timber for the final cross-cutting and QA checking before it was installed by Contrasol on the building. So it really went through quite a few suppliers. Now, one of the issues that we faced was the certification of the fire certification of the tulip wood itself. The fire certification specified there had to be 44 mil thick. But going back to swelling and shrinkage, we have to take into account the fact that this timber will cup, which is shown in the shape just here. Therefore, when sourcing the material, you have to account for that additional thickness to ensure that we can get a nice rectangular section for the end product before it's installed. Now, unfortunately, some of the timber had cupped too much. Luckily, not too much of that timber had cupped. But there were a few instances where some fins we couldn't plate it down any further, as those would be invalidated by the fire test. So ultimately, they had to be rejected due to those machining marks. Now, a little bit about embodied carbon. We all know the advantages of mass timber versus concrete in terms of embodied carbon. On this building alone, the structure, we saved about half of the embodied carbon relative to a concrete and steel equivalent. And we can't just think about the structure, we need to think about the facades as well. So facades contribute to about 15% of the embodied carbon on a new build, extend up to 25% on a timber new frame build. And then if we were to refurb projects, it would contribute about 55%. So if we looked at a conventional aluminium stick gun walling system that we use everywhere in the UK on commercial projects, we're saving, just in the facade alone, about 40% in embodied carbon, assuming taking into account the timber curtain walling, the fins, etc. So that's quite a significant reduction there. That's it. I think I hope that was a useful insight into the challenges that we faced, and now I'll hand over to Nick.
Fantastic. Hello. So yeah, I guess my role is just to explain a little bit about how we solved some of these problems that came down the line. So I've picked out a few topics to talk about. One is the timber sourcing, where we actually got the timber from, and then following on from that, the installation, I have to say, was pretty standard installation for us. There were 3 specific areas that we had challenges with, and those are listed down there: the movement, which Ben's mentioned earlier, dealing with the differing fire requirements, and the design of the brackets to support the breeze slay. So let me just start with the timber sourcing. We the business has now moved into facades, and been 95% of our business is now facades, primarily timber aluminium composite. But we are at core a 45-year-old joinery business, and I can still remember back in the early days, most of the timber that we received into the works was simply cut logs, so it was just a waney edge board that we'd be dealing with. And by the time we'd cut a piece of timber out of that waney edge board, we'd be dealing with 100+% waste. It's interesting as we go through the cycle now and see what the modern engineered timber is providing in terms of waste. We all talk about or think about wood as this general material, but there's a lot of science and a lot of effort that's been going into developing it moving forwards. And we've been noticed over the years, particularly in the facade business, when people are talking about glulam timber structure, a lot of it is just talking about glulam in its simplest form, whereby people are just laminating lamelles together, and that includes all the inherent defects that comes in that timber. The product that we chose to use on the black and white building is actually a defect-free, finger-jointed timber section. I'll just go through the process of where that was sourced and where it was and how it's manufactured. What is a nice story, just to close the loop with this, is the company, James Latham, who import the timber from the supplier in Germany that we're going to talk about. This was actually their warehouse back in 1850, certainly in the early days of the business. And it was actually used to support the furniture business that Sophie referred to, with timber coming up, being stored in the warehouse and laid down to dry. So it's a nice circle that those guys actually supplied the timber moving forward when it was rebuilt 150 years later. So the first thing you notice when you go and see this this factory over in Germany is just the pride that they have in their whole process and the attention to detail at every stage of it. They're sourcing their logs locally. They're literally cutting the surrounding forest to the works, and once the trees are actually felled, they're actually only buying the part of the timber log that has the least defects in it. So the lower part, they cut the root bulb off and use the lower part of the trunk before the trees, and that reduces the number of knots in the timber. So we've Ben touched on earlier the different grains in the timber, and probably although it's the biggest item, the biggest piece of machinery in the works, this is where the finesse really goes into it, where the guys are actually cutting the boards to get the greatest yield out of the logs and capture the correct grain direction that they're going to laminate together, which we'll touch on later. So after the logs have been band-sawn down to size, you saw them stacked in the previous slide, and they were taken away to the kiln to be dried. Once they're actually at the correct moisture content, they're planing them into 20mm lamellas, and those lamellas will still contain any minor defects. So the next stage is to put it through it's a smart crosscut, call it the wood eye, and there's a radar actually on that machine that as the timber is fed through, it will see any defect, any major resin pocket, any knot, and it will literally cut it out. And further up behind that machine, you see there's this whole line of stillages, and there's different stops on the machine. So if it's between 300 and 400 millimeters in length, it will throw it into one stylage, and if it's the next length up, it will go into another, and so on and so on and so on. And that's where you see down there, these stacks that are down the side. Now at that point in time, those timbers will be hand inspected, selected for grain direction, and put together to form a lung lamella. So each individual piece will be finger jointed and joined back together in either a 6 or 12 meter length, depending on what the production run is. Now, once you get those series of lamelles, and the beauty of using the engineered product is they can then choose the grain direction of each specific lamella, where it goes in the construction. And normally you'll find that they will put again, going back to Ben's earlier slide, where you see the radial grain, so where you see the grain stood up on the face of the timber, they put that in the center of the beam for stability. And then on the face, they put a flat grain, which is generally deemed to be more aesthetically pleasing. The other thing that they do is they have different standards. So on the inner lamels, they'll have a minimum finger jointed distance of probably 300 millimeters. On the outer lamels, it starts at 500 millimeters as a minimum. It goes up from there, but for every additional length between finger joints, you're talking about a cost premium, but it is available. And here we get to the product that's kind of looking very similar to what is seen in the black and white building now on the top left. So that is a defect-free glulam beam that's just been cut, ready to be packed up and transported over here to the UK. What's interesting about the process is they reckon that the 70% of the timber, the bulk timber that goes into the yard, is actually turned into these usual timber beams. We don't plane it in our process. All we do is add fabrications to join it together. So that 70% from what actually comes out of their factory pretty much goes onto site. There's a certain wastage with cross-cutting length. When you're talking about curtain wall, a lot of that gets turned into the transoms, which will obviously take up that waste. The other 30% of the log isn't wasted. They mix the sawdust and the shavings together to form fuel pellets, which are sold locally. And the remainder, the shavings off the machining process that they have and the bark that is stripped in the process actually goes into their fire-burned kilns. So you can see it's very well thought through, very efficient process. So yeah, just moving on to the next, the first issue that we had to deal with, I guess, on the building was the movement. And the RAICO system, which we used, not the RAICO unitized that was presented earlier, but the RAICO stick system has the benefit that it comes with a 50 millimeter wide section, 56, 76, and less common, but if needed, a 96 millimeter section. And the beauty of it is, which gave us the flexibility to satisfy the movement, was that we could interchange the different systems. They all interconnected. So in this instance here, we have the system width of the mullions on the east, south, and west elevations that were 56. Throughout the whole project, we had the transoms at 76 millimeters. The movement in the system is kind of halved in the height, because the glass cannot move on the bottom layer, because the glass shoes pack it securely. So that's why we ended up with a 76 millimeter transom. And on the north elevation, which is the road elevation, which is the one that you see in the pictures, that's where the elevation moved the most, and we ended up with a 76 millimeter mullion and a 76 millimeter transom. This is just a very quick slide to show you what the reason for that. But you can see on the 76 millimeter system, the distance between the glass edge and the nosing is far greater. So it just enables us to move in that. The jury's out on whether you'd want to move the glass out 15 millimeters and risk seeing daylight in between, but we won't go into that. The difference in fire requirements on the project, I described it earlier as trying to squeeze a balloon. Things changed as the project went on, and we overcame all of the design requirements and managed to provide something that was fit for purpose. This is really interesting to see how this far on, how things can still move, and I don't believe there's enough clarity when it comes to direction over fire requirements and fire strategy. So the original section was no fire compartmentation at all. It literally was a standard glazed unit. The fact that we had a glazed unit in front of the floor joists was carried over from design intent. It caused some complications with the breech-lay brackets, which we'll come on to in a minute. But the idea was that you'd see straight the way through that the intermediate transoms and see the bow bucker beam and slab edge beyond it. So we then had one screen on the building on the north courtyard, which was from the get-go was required to be a 30-minute fire screen. And that fire screen is a standard RAICO offering, and the test certification, it was within the test certification, apart from the windows and doors, which, again, there's an acceptance that the windows and doors within that particular screen would be ignored, and we rely on the surface area that was actually certified, or certified, should I say, with existing test evidence. We then get to the as-built, and as Ben touched on earlier, we now had to introduce a fire stop at slab level, which under normal circumstances wouldn't have been too much of a problem. The problem was the design intent required that you saw the timber behind that, I'm going to call it a spandrel panel, but you see it's a glass panel. So to get over that, we then actually screen printed. We took a picture of the bow bucker, screen printed, and had that actually screen printed on surface 2 of the glass. So when you look at the building now, if you don't look close enough, you actually still see that timber ribbon that goes around the outside. And great care was taken with that. I know Worthington worked on it with regards to the graphics, that we didn't just want this tiled repetition that went around the building. So there's a good deal of skill, graphical skill, way beyond me, that I took the picture, but then they stretched it to the required dimensions of each panel. Further complication was on the northeast corner of the building, and just because its proximity to the railway line, that screen needed to be EI60. And we started off down what we thought would be a very easy route by specifying or going out to a number of system manufacturers, Schuco, Foster, Janssen, to name some of those that we approached, to provide us with a 60-minute fire screen. It was always intended at that point in time that, during the design stage, that screen wouldn't be timber because of the requirement for it to be 60 minutes. But we actually found it was impossible to procure a curtain wall system in that scenario that was 60 minutes. And the reason being is that all the existing test evidence has an interface on all 4 sides, or if it's a door frame on the ground floor, on the 3 sides. In this instance, because it actually joins onto a non-fire rated curtain wall screen, that test evidence became null and void. So again, we had to think again how to get over it, and the solution, as it turned out, was actually pretty simple. So we reverted back to a timber curtain wall screen, which I think you appreciate. You would like to do that from the outset. We used the standard RAICO system on the outside to give all the weather tightness and air tightness properties. And initially treated the 60-minute fire requirement as a secondary screen on the inside. And for that, we used the Pilkington Pyrostop glass and stitched it into actually the curtain wall frame, but worked within the constraints within that fire cert. And then finally on to this is, throwing this in, I don't have an answer for this. This is just one of my frustrations. It's just to show you at the level where we're trying to satisfy building control faced with architectural intent, what we're coming up with. This was actually quite a prestigious building in northeast of London. And we'd originally been specified to use a 300mm by 80mm oak glulam structure on the inside of the building. I know we talked earlier in a previous presentation about the word being non-combustible. It doesn't matter what treatment you put on timber. As far as I know, you've still got to classify it as being combustible. So for that reason, it was rejected, and we had to go back to the drawing board. The solution was to build the facade for a 14-storey building with an aluminium mullion and transom section, and then to satisfy the client's wishes and the architect's intent, we went back and cladded it all in timber. It doesn't make any sense to me, but I'm just giving an example of what's come down the line that we've dealt with literally in the last 2 years. I have no gripe about it. We were due to make the original facade in timber, and we were actually awarded the contract to clad the aluminium in timber. So there's nothing there. I just thought it'd be worth mentioning to see the challenges that are out there. And yeah, the final slide was to support the brise-soleil. I'm not sure we'd given it enough thought in the early stages of this, but it was obvious that the brise-soleil with the vertical fins would attract a lateral loading, and the standard RAICO curtain wall bracket, I think, which is pretty similar with all system houses, because they're all very similar in design. That fin or beak offers very good vertical loading, but virtually non-existent lateral loading. So we were searching around for a solution to overcome that, and it was actually quite simple in concept. We just thought the transom section is exactly the same as the mullion section. So if we turn one of those on its side, we know the properties in that plane, and we'll be able to satisfy it if we couple the three together with a coupling bar and consider that junction as a node. Again, it was the flexibility of the RAICO system that enabled us to do it, because the RAICO system would normally mullion drain, but there is also the option to have transom draining. And the biggest problem that we had is that in between the fins on a transom, to make sure the water could get away. So in those areas, we transom drained with the rest of the screen mullion draining as a standard detail. I think that's just about it. Thank you for listening.
Thanks, everybody. Fascinating project. Lots of interesting details. Just sticking with the facade for a moment, you mentioned that you used a RAICO stick system, but not a unitized system. Just circling back, is that because of the movement issue? Is that the reason?
The primary issue is the RAICO unified system wasn't available at the time. This is hot off the press here. The other reason is that we actually overcame the movement requirements with a stick curtain wall, so there's no need to do that.
Another thing I'd add is we did study both options quite extensively during the design stages. But given that we wanted to have those 4.5 meter wide spandrels spanning between column to column, actually the unitized system ended up being quite large to be able to accommodate that. And we looked at reducing the spandrels and all the rest, or a different panelization for the facade. But ultimately, what did make sense at the time was that curtain wall for the size of the building and all the rest.
Thank you. And just also thinking back earlier, we had a presentation from Ollie about the costs and the QS side of things. What was the cost implication of using a timber facade here rather than an aluminium? What's like an aluminium one?
It's interesting. We've recently done the exercise, and I think we were actually do it with Steve Rogers, who's also here today from RAICO. And RAICO is one of the few system houses where you can directly compare it, because they do a timber offering and they do an aluminium offering, and it's identical system in front of what I call the back box. So from the front of the timber, the system's identical. Go back before the recent troubles, I think the common understanding or thought would be that the aluminium would be 15 to 20% less. Don't really think you ever get the opportunity to compare it apples to apples, because most of the projects that we get are quite bespoke and small by nature. Whereas if you're talking about runs and runs of curtain wall, it would certainly level up the price. But recently, with the price rise in aluminium, nothing's changed over in Bavaria. The timber there has remained pretty stable. When we actually did the price comparison, we were really surprised to find that the price in the section alone is actually 20% more expensive now in aluminium than it is in timber. So it's actually the most cost-effective solution as it stands at the moment.
I think the other thing for us, though, as well, is we often get these questions about timber frames as well. You know, oh, well, Balbuca is X amount per cube more than concrete. And I think all of it has to be done holistically. I mean, we've been talking about and delivering timber frames for about 20 years now. And we realized very quickly that going in and banging tables and saying, I want wood, wasn't going to cut it. And we realized really quickly we had to talk to people about their own motivations, which often is cash, because, you know, the legislation isn't really dealing with embodied carbon. So this was asking them potentially to spend more money for something they didn't have to do. And actually, in a lot of cases, we're going to sell the building on, so didn't get any long-term benefits out of. So the other way to look at the facade, I mean, fascinating to hear that it's coming back into parity or even better. But as a whole building, you know, we didn't approach the brief from TOG as an open checkbook, you know.
No, we wouldn't let you do that.
Exactly. And, you know, the whole building is really carefully designed around this idea of how much building do we need to achieve what we want to achieve. And so, you know, those tulip wood louvers are a big part of reducing energy load, which costs Sophie and her team money because they operate the building. You know, so all these things that can be seen through the lens of an individual capital cost. You hear a number of 20% more expensive, you think, right, well, that's an easy win. But actually, you know what, over the whole building.
In the scheme of things, it's not.
Yeah, I mean, we saved quite a lot of money with really simple things that we should be doing on every building, like using recycled raised access flooring.
Yep. And also, if you do have your exposed CLT walls, beams, columns, then you're not having to dry line anything, you're not having to decorate it, and actually you save money there too.
Sure. Yeah, absolutely. Yeah. I mean, you know, you could see the difference between the basement situation and the upper floors. And again, you know, it's kind of flippant to say don't build basements. Like, you know, we're in a conservation area. There's a cap on the height of the building. But you know, if you're a commercial developer and you've borrowed money, you know, in our CLT 100 UK book, the average that people reported to us across 100 buildings was 20% saving on total program, and that's with really traditional ways of buying buildings like D&B. That's not even thinking about construction management, you know, so that 20% program is money, you know, when or particularly for a business like TOG that actually has a primary relationship with its customers, or I'm sure you've got a much better, cooler word for your customers than that, but, you know, those people need to be coming in and paying their rent, otherwise, you know, that's money left on the table. So, yeah, lots of layers to it.
Absolutely, thank you. I think we heard from Ben and Nick that there was a bit of a change in the sort of regulatory opinion really, or regulations themselves, but also various different people's interpretations of those regulations. And that's sort of just what's happening in the construction industry post-Grenfell generally, I think. But it's really interesting because this building was built throughout all of that happening. So I'd really like to hear from you what lessons you learned by going through that process whilst everything was in such flux.
I mean, quick start from the kind of architectural point of view. I mean, I think we've kind of shown you behind the curtain on a few things, like, oh, they've got printed wood on the back of, you know, and things like that. But I think the lesson from me was, actually, I've never worked on a building project where there wasn't a point where the approved inspectors, if they're out there, but where the approved inspector didn't change their mind at some point, or maybe read that package a little more thoroughly the day before it was being installed. And these are normal building a building challenges. But I think what scares people about delivering in timber is the idea that those challenges, I guess, are more explicit. The sands they're definitely shifting. But I can promise you, they're shifting in concrete and steel buildings, and they're shifting the day after you've erected the curtain walling and you need to work out how to get a fire bat. And so what I learned was, you know, building a timber building, you can be as nimble and responsive to these challenges when they come if you have a competent, skilled, passionate design team, if you have a client who's invested in the solution, not just, oh, stuff it, let's cover it in plasterboard, it's cheaper and easier. You know, it really is possible to kind of find your way through those shifting sands.
Yeah, I think I second that. I think if you're steadfast to the vision, but you're happy to flex and adapt in how you might have to get there, then you can achieve what you need to achieve. And that the design team has a huge impact on that. The collaboration and passion from everybody really helps you get through those sticky points.
And one thing that I'd add as well is that fundamentally we need more certificates proving that these systems can be assembled together rather than one system being applicable for concrete but not for a mass timber structure. We need that testing done and those certificates so that we as designers can then comfortably be able to specify these elements. Otherwise, it just goes through a question mark exercise of what's being tested and what hasn't.
The first time we asked for more regulation, I guess.
Yeah, well, I think that's an interesting point, because the clarification would actually narrow this down so that manufacturers would have the confidence to go away and spend the money to do the testing. A lot of these projects that have been spoken about earlier, you can see fire as a prime concern, but they're also big enough to have project-specific testing. Project-specific testing in a fire is going to start at 50,000, probably go up to 75,000, depending on the scope. The kind of cost of building that we're talking about here, and mainly, just doesn't have that budget. So that's where we have to rely on existing. And as Ben says, if there's a plethora of existing evidence out there, it would be easy. But that costs money, and people aren't going to do it if they're not sure that that's going to be stable for a foreseeable future.
I think as well, just to kind of extrapolate on that, one of the big responsibilities or opportunities for those of you, I'm sure there's lots in the room who are involved in manufacturing mass timber products and things like that, is, early in the adoption of these technologies, what we were finding was this kind of deeply held belief that making a slightly thinner panel than the other manufacturer was your intellectual property. And, I don't want to be dismissive of that, but if we can all sell more wood products, not me, I don't make a penny out of it, but if we can all sell more mass timber products, then it's better for everybody. And I think, specifically in the research we're doing for the EU Horizon 2020 fund, it's really been really inspiring to see not just your storers and your Binderholzers in the same room and your Finzers or whoever, but also your Knaufs and your, the people who don't really have a lot of skin in the game for this. And it is slowly becoming something that is more systematized, so at least we know what to test. And right now, we have funding from the EU to build a prototype building, which will go on site soon for this program in Copenhagen with the Danish Technical Institute. So it's come in, but it takes a little while.
Yeah, I mean, collaboration is key, isn't it? And it seems like you had a great team there that were all willing to get on board and go forward, and as much that you can share from that journey and inform the industry. People like Timber Development UK, Structural Timber Association, they're all collecting this data and trying to print the lessons learned so that everyone can move forward rather than just individuals moving forward slowly together. I suppose my next one is really about circling back to the insurance talk we had earlier with Dom, water. What challenges did you come across with water on the project?
Yeah, maybe I'll go first again. People have asked me quite a few times, what did you learn from this building? And there's loads of things that we learn, but in another way, actually, with this being I think it's number 28, I think I had 26 up there, it's ticking over. This being our 28th mass timber building, it's actually, all those lessons are in this building. And so a lot of those things are, believe it or not, yes, more water and less fire, and that's really borne out. So, lots of people in a concrete building will tell you can have 100% flat slab and the membrane is warranted and that's all fine. And I think we've all seen projects be stung by that. No different in timber. So, we're not designing flat timber roofs for starters, but also just little things where, we know, for example, in the structural diagram of the building that the vertical core is working structurally, but it's the walls that are giving that bracing against the wind load and helping the building to remain stable. The floors aren't doing any work. What's the other thing that goes in the core? The wettest bit, the bit that fails all the time, that's the WCs and the showers and those sorts of things. So really simple little things like taking out the CLT from that core where the WCs are, replacing it with joists. It goes right back to the kind of first ethos slide that I put up, which is we're not there to use as much wood as physically possible. We're there to use the minimum amount of material and the right things in the right places. So, you know, I'm sure you know much better than me, Sophie, but, you know, one of the things I sense in these buildings, the first things to get a bit of a zhuzh is the loos.
Always the first thing to fail as well.
Well, exactly. So, you know, you want to move those pipes around.
Yeah.
It's just a good idea not to have a CLT floor. So, you know, things like that, and talking to insurers and saying what worries you and taking the easy wins. Because, again, it's not about wood, it's about carbon.
And I suppose as well, in terms of the facade, I heard you mention, Nick, about the way you detailed it so the water doesn't get trapped, etc. Are there any sort of specific things that you can share about that?
Well, I mean, going back, thinking about the tulip wood fins, for example, that's less to do with actually the water going into the building, but more how to ensure that we preserve the timber as much as possible. We had to ensure that we had the right slope at the top of the timber fin so that the moisture wouldn't be too absorbed and the water could run off. In the early design stages, we had an aluminium cap, but then we thought, well, actually, you know, we want to again try, with the interest of trying to avoid introducing more material. Why don't we just design it so that we can allow for that water runoff?
I remember some long conversations about the stability of a pigeon.
Yeah,
thinking of angles of, throwing things off.
We have not seen any pigeons so far, so fingers crossed.
Good.
Yeah.
And well, listen, we talked earlier a little bit about demountability and circularity, but also I'm just wondering about the design life of the building. How long did you see it lasting for, being used for, and what's been built into the design to enable it to be a long-life building?
Well, we want to see it being used for as long as possible. Obviously, the longer that it's there, the less you take it down and mess around with it, then you're really making sure that you've made the most of that carbon that you have inevitably used in order to put it up in the first place. I guess there was a lot of work with the services in really making sure those all align and coordinated with all the kind of beam cuts and things. Yes, LVL beam is a bit less flexible. You have to make those notches before, but I think because we're used to retrofit, we work with buildings that are a lot more complicated actually than this very kind of simple timber frame system. So for us to kind of invest early on the design and really coordinating those services, that's fine. It's part of what we do anyway.
I think from an architectural point of view, you know, it's one of the joys of having the end user client in the room on day one is that we can also design the timber to support that on day one. And a lot of the questions that we ask are, what do these things actually mean to you? You know, so take vibration. You know, vibration is a comfort criterion, but with the particular characteristics of timber, it can add tens of thousands to the budget for a project to meet criteria that are kind of not statutorily binding, just guidance. And so, you know, having a conversation with Sophie and the team and taking them into our office, which was a wooden joisted floor, and sort of dropping 5 reams of paper on the floor, saying, right, did you feel that? Yes. Do we all think we need to run out screaming because the building's going to fall down? No. Well, maybe then that is fine. And I think flexibility was a similar conversation. What does flexibility mean to you? So really simple things like making sure that in the long part of the building, we have a very long 17-meter run of beam in one axis, then a 7.5-meter bay each side with 0 beams in between. And the CLT does the spanning. So that level of flexibility, just one place to cross the beam, that's okay, that constraint, because we've really carefully understood it together. But what we've not done is just assumed it's just like a concrete building. You know, we have to make those decisions on day one.
Thank you. Great answers. I think we're actually coming to the end now, so unless anyone else has any final thoughts that they're dying to share with us, I think we might wrap up and we can all get a bit of lunch. Thank you. Thank you.
Thank you. Thank you.
Okay, good afternoon, everyone. Hurry back to your seats because we have a great first speaker for the afternoon session, the one and only Alex de Rijke from dRMM Architects. And he's going to be talking about the Charlton Work Stacks, which is a really cool project. So please come and take your seats, and I will hand over now to Alex. Thank you.
Good afternoon. Hear me okay? Yeah. I guess talking about timber here is preaching to the converted, right? I don't need to persuade you, so I won't. You already like timber. You've already chosen a timber coffin over a concrete one when your time on this world is up. But I want to talk about work, not just why we work or how we work, but where. And this project we've been working on a long time. It was conceived in 2015, the end of 2015, and is literally finished now, as in a couple of days ago. So you're the first to have a look at it, and I hope say what you think. It's not going to be a talk with diagrams and details. It's going to just really talk about why timber needs its own typological inventions. You know, it's not enough to simply substitute steel and concrete for timber. You know, it's a material in its own right that has many qualifications, not just carbon hoarding. So we're always, at dRMM, we're always kind of searching for the right expression for the material. So, yeah, you all know light industrial units, and you know the problems, you know, not least the fact that they devour land. You know, the classic industrial typology is a ground-hugging shed with a lot of parking. So there's a big expanse of tarmac, and then you get a steel portal frame with a thin steel sheet envelope. And if you're lucky, you'll get some poisonous insulation sandwiched into the steel cladding. So that typology and that construction system is still the default, but on the other hand, not just intellectually, but you know, climate consciously, an exhausted typology. But with the pressure on home building and the release of land for change of use by this government which simultaneously, I should say, bans timber. At the moment, it becomes a law. You know, it's literally obligataire in France to have 50% of public buildings in timber, and same is happening in Holland. So whilst there the change is perhaps more recent, timber has been used in a more experimental and, I would say, valuable way in the UK until recently, obviously that moment being the knee-jerk reaction to Grenfell, which lumped timber in, even though it was nothing to do with that tragedy. So at the moment when we should be building timber, we have governments trying to stop it. And we have this typology, which cannot continue because of the demands of home building, which pushes it here to the outskirts of cities and also into the countryside, where it creates other problems, not just the banality of the architecture. You know, you're lucky if you get a window kind of architecture, but also the fact that you get a monoculture. So our challenge really was to work with a very visionary client. That's always a good challenge, because the GEB, Greenwich Enterprise Board, had an idea that rather than take on home builders who could buy large post-industrial sites in order to develop their own monoculture of desirable residences and coffee, that the GEB would make on a smaller footprint of land that then was desirable to those house builders. They would try and retain workspace within cities and stop it getting pushed out. So we've developed this model for them. It's a kind of modest typological invention, if you like, to take the principle of the shed and the area of the shed, the floor area, and put it on a much smaller site. And obviously that's based on the idea of a large lift that you can get materials in, rather than simply driving in and parking at grade and servicing a single-story volume shed. Hence the name, work stack, which you already guessed, I guess. But suffice to say that this was conceived of then and is finishing now, because it was really the victim of all of those moments, not just the Brexit and COVID moments, but also a very long time in planning and difficulties in procuring the wood. So it's organized very straightforwardly as a series of units of different sizes. They're about 5 meters wide and range in length from 10 to 20. So the whole building is a bit like an eroded cube of about 20 meters squared. Sorry, each side and height 20 meters, not 20 meters squared, but square. And the construction principle is CLT. We used Storre Enso and Hasleger. They, and I suppose the structure really is to try and demonstrate the potential of CLT to work as a cantilevered structure. Very good in shear. So obviously the walls do all the work. But we've used it for the floor slabs too. It's a timber cube standing on steel. It's in a flood zone. So the ground floor is a steel frame with infill, block infill. We considered concrete, but in the end, it became to do it as a steel frame. Wasn't a preference, but a reality. And it keeps the timber out of the damp zone, which is obviously sensible practice. You're all familiar with CLT as a process of construction. It appeals, I think, to architects like myself because it replicates the thought processes you go through when designing. So in other words, making the building can even be the same as making the model of the building. So you can kind of predict how the building will be at model stage instead of representing it. You can make a timber model which really is like the building. Right down to the way it's pinned together and the way holes are cut in it. And it's a very satisfying process that provides on site a much happier environment. We've seen evidence earlier of the benefits of speed and obviously carbon hoarding. But I think a really interesting aspect of building in timber is that you have a psychological difference and you have health difference in the use of the building, as well as the construction of the building. And this is something that's proven by research I can speak more of later. The building's organized very simply with workshops either side of the big lift at the back of the plan. So the corbelling form of the building provides an overhang which gives you a kind of backing in dry zone out of the rain. And at the back of the plan is a big escape stair, big lift, and a small lift as a passenger rather than goods lift. The units are a very straightforward expression of the construction process. All of our buildings have exposed timber internally. The structure is the finish, not the floor, but the walls and soffits. It was important for the client to make a statement about not just working within London and retaining industrial uses within central London. This is being Woolwich. This is the Woolwich Road. It was also to make a statement about not defaulting to the automatic steel shed on the ground with a portal frame. So the idea that the wood had to be clad externally, we wanted, of course, to use timber, but that was not possible. this was submitted before the regulations changed. The 18 meters is higher than 18, but we got the approval before that. But in a way, the driving condition that has been referred to all day, and I'm sure many people are familiar with, is that you have to somehow make timber buildings compete on the level of cost, not only value. And my challenge to QS is always, do you know the difference between cost and value? These units offer the tenants the opportunity for their company to grow as their business might grow. It's an affordable principle, almost encouraging startups, but it's definitely keyed around manufacturing, making, so it's not desk jobs. People look at it and mistake it for housing because, I guess, of the proportions and the fact that it's interesting formally, but really the three-dimensional quality of it is an expression of the different sizes of units and how they're arranged actually quite rationally. 1.7 cantilever on each level, unit to unit, is perhaps not rational, but it does give you the smallest possible footprint of land with the biggest possible accommodation ratio. The facade was very simply installed off a cherry picker like this, or rather a scissor lift like this. We've used a combination of polycarbonate and glass and insulated opening panel. And the reason for that, rather than just glass, was because we really wanted to have a facade that wasn't overglazed and didn't need any kind of external brise-soleil system, rather that the heat gain could be limited by the material itself, and that you could get enough light through a translucent, combination of translucent and transparent facade elements. And obviously it reduced the cost and the weight, glass being not only heavy and expensive, but also its own carbon content implications. And the polycarbonate cladding, which is on top of the insulation, was carried around the building in the delivery areas and to the soffits, as you noticed in the last slide. But the rest of the building is very simply clad in corrugated steel. This after we'd really failed to be able to find the timber that the client was happy with in terms of cost and maintenance schedule. So in that sense, there is a familiarity with the automatic light industrial shed, but it stops with that 2 millimeter thick external cladding, because everything beyond that inside is more benign materials than the portal frame shed. That's what it's all about, the big lift, which takes you up to all the levels. The junction of timber structure and glazing is kept external, so you don't see the window frame encroaching on the diagrammatic structure, if you like. All the components are boiled down to the absolute essential. Things like, structural balustrading or straightforward rubber flooring, straightforward radiators powered by heat exchange on the roof. Actually, that's not true. It became geothermal. The side units, either side of the central bay, have dual aspect. So they have additional windows to the sides, which gives you straightforward natural ventilation. The central units, which back onto the lift space, obviously are a single aspect, and they have also the opening panel in the facade that you can see here, dark. But they had those, only the central units get extract at the back, mechanical extract. the ceiling heights were determined really by the material itself, so that 3-meter wide CLT panels determined the ceiling height. This isn't really high enough for some light industrial processes, and it's definitely a building that will appeal to, certain manufacturing and not others. You couldn't do a microbrewery here, but you could do leather garments or perhaps some joinery. We originally designed a timber stair, as we've done many CLT stairs and CLT lift cores since the early 2000s. But here we're obliged to do a steel escape stair, and the answer here was to make one that, again, was the least steel possible. I think that's a guiding principle really in the whole project, that what was the least amount of material that we could use. The building sits in a plot which was already demolished warehousing. It's a very narrow plot. It's about 60 meters long, 20 meters wide. So we've filled one end of it in order to be able to get delivery into the building, and then planted trees down this side with the fence, which gives onto Selco and other big, DIY giants. And on the other side, straight onto the road, right next to a zebra crossing. So we're able to make a light industrial building that didn't only serve its function, but also became public space. And the client was, I think, extremely, impressively dedicated to the idea of making a positive contribution to the area, not just doing a very efficient box somewhere, but actually allowing people onto the site and through the site. So it's not a fenced-in compound. The fence you can see here is the temporary Harris fencing during construction, which is about to come down. So it stands like a sort of modest landmark in apparently familiar external materials, lightweight cladding, but is a fundamentally different kind of topology. I guess these become much more muchness. It's supposed to really be a sort of mini manifesto which directly confronts a key problem, that's not only of cities becoming residential monocultures and the lack of manufacturing, which is endemic in the whole country, not just limited to, say, London. But so it's encouraging industrial intensification, but within cities, and it's also seeing it not as a lowest common denominator form of architecture, but as a site to be proud of, to make a building that offers joy and offers a great place to work. The tenants that can't believe that they get a space that looks good, smells good, is extremely durable, simple, and not a kind of gloomy shed devoid of even a window. So that's the project, and I think I've probably used up my time. Thank you very much.
Thank you, Alex. Great building, great talk. And next up, we have Stefan. If you'd like to come onto the stage and join us here. Project manager at SJB Kempter, Fitze, talking about timber in form. So a good follow-on from Alex's talk. Thank you.
Thank you very much. Yes, as he said, I'm a project manager and I'm structural engineer with SJB Kempter Fitze. And I'm mainly involved in international timber projects. and usually those projects present themselves with some challenges, and those challenges can be, maybe it's structurally complicated at some point, maybe it's an unrealistic tight timeline, or maybe we are doing something new, something innovative, or maybe it's just a very complicated geometry. And if I'm get really lucky, then all of those present themselves and drive my day. And as it turns out, I get lucky quite a bunch of times. And today I'm going to talk about timber in form. And I'm just going to show a few projects I've done the past years. And along with those projects, I'm going to show how we realize them from a structural point of view, using digital processes, along with traditional connections. And what's also a very big important point is mock-ups. And the first project is this one. It's a very small project from last year. It's actually just a skylight within a private building in New Delhi. And it's structurally not that complicated. It has a difficult geometry, yes, but basically it's a column with a roof on top. And what is very special about this project is that the requirement from the client was that it has to look like furniture. So we were not allowed to show any screw heads or steel parts or whatever in the connections, just the flush timber surface. And what then made drive the detailing is especially those requirements, because we have connections where the beams cross, and those beams are visible from 3 sides. And now we have to get a connection in there, which you don't have to see at the end, which made it quite interesting. And what we also used the first time with this project was steam-bended beams. So no double curve glulam as we usually do. So those beams were steam bended because we were not allowed to show cutted grains at the end when it's done. This project was from a few years ago, designed by Forster and Partners. It's a pavilion for Kulm Hotel in St. Moritz, and we always try to meet our architectural design as close as possible. And there is some changes happened. So the V structure of the columns happened along the project. It was a design idea of the architect because we needed more structure because of the high snow loads in St. Moritz. But it still, I think, looks very nice at the end. And the architects and the clients are very happy with it. Then this is a very interesting project, also a few years ago. I think it was 2019. And it's basically, it doesn't look complicated. It's a square box with a roof on top. It's on the Maldives, designed by James Turrell, the light artist or light designer. And this simple structure also makes it complicated structurally because we only have 4 walls and the roof on top to stabilize the building. And it's, as I said, on the Maldives with high wind loads. And all we have is the vertical studs and the horizontal bracings. And along with that, even though it's structurally complicated, we need to find details and solutions that are being able to be built at the end. Because, as in this case, the project was assembled by a team from Singapore. And I'm guessing lots of those workers, they are the first time on a building site, and not even to mention that it's probably for all of them the first time assembling a timber building. So we designed the details for them to, like getting furniture from IKEA. You have a manual, and then you have the pieces, and you put them together, and it works structurally. So, for example, for this detail, we needed a fixed connection to the base plate. And there is the red ones. Those are glued inwards from the edge beam running around. And instead of fixing the rods into the slab, we fixed them first into the beam. And then the beam with the rods was part of the formwork. And then we poured the concrete in, and the connection was done. And the same principle, or the same simple idea of just putting it together, we used for the walls. So we needed all four walls to stabilize the building. And on site, they had a jig for those wall elements. And we used for the bracing, that's ironwood. It's actually quite interesting. It's heavy enough that it doesn't float. And the ironwood was cut into two wedges, and those two wedges were just drawn into the studs from left and right side. So we have a connection to the studs with 0 tolerances, which works structurally the way we needed them to. And yeah, as I said, 4 walls and the roof on top. Not that simple, because the roof has a hole in the middle, which is structurally not at all perfect, but that's the way it is. So we also needed a connection, a fixed connection from the wall to the roof, with on every stud to the roof beam. And we did that the same way. There is just putting it together, putting the steel dowels in, and the connection is done, and it works structurally. Then another small project that's actually just a design from an artist. Simple one, not a building in this case, but very complicated geometrically, form of a Möbius strip that's based in Germany. And we used here the same principle as we did in the Maldives. So this structure came in 4 pieces on site. So in 4 quarters, the ring came in 4 quarters. The bottom one with the steel rods you see on the right side at the bottom, and then the other 3 parts. And we did the same. We placed the first quarter, placed it on site, exactly where it has to be, and then we poured in the concrete, and the connection was done to the concrete base. And then all the other 3 parts came, and the ring was done, I think, within 1 or 2 days or something like that. And for the digital process, you can see it here, the pictures, the 2 pictures on the right side, that's from the structural model. And I like to do the structural model as close as possible, geometry-wise, to the final build structure. So I don't have to worry about a bunch of things like eccentricities or whatnot. And even the structure or the geometry is very complicated. We like to use traditional connections, because those connections, they worked for a while now. So why wouldn't they work for a structure with difficult geometry? And so in this case, you can see it here. Those battens, they are connected with the wooden dowel. Very simple, put together. And all we did on site was up here at the joint. We put a few screws in, and it was done. Then this is the last project I show. I'm going to go a little bit more deeper in this one. This is quite recent. I worked on that one last year, and it's currently being built. That is the Wisdom in Stockholm. That's going to be an extension of the Technical Museum. And the visualization you see on the left side, this is from the competition, which was won by Elding Oskarsson architects and DIFK engineers. And the very special requirement about this project is that all the material used for this project is sponsored by Stora Enso. So this was a given. We had to use material from Stora Enso. And the building basically consists of two parts. So you see on the left side, the inner dome, and then the roof structure. And for the inner dome, we used CLT plates. And for the rest of the building, we used flat LVL panels. And as in many connections, as in many projects, as well as in this one, this is the team I'm working in many times. And it starts on the upper left side with creation holds. Creation holds, especially Hermann Blumer, comes up with the structural concept, as he did in this project, and also Maldives and the Ring for Peace, for example. Then there is design to production, who is handling the whole geometry and does the parametric planning. Blumer Lehmann, the company for the construction, timber constructor. And then I'm in between doing the engineering. And on the left side, this is the Limmat Bridge by Hans-Ulrich Grubenmann. This is one of the inspirations Hermann Blumer used for the concept of this project. So Hans-Ulrich Grubenmann basically just used flat panels, put them on top of each other to make a bigger beam, connected them mechanically, no glue, and made it structurally work. And Hermann Blumer did exactly the same for the Wisdome, except that the geometry is a little bit more complex than the bridge. And the second traditional connection we used is the principle of the dowel beam. So basically just taking two beams, putting shear dowels in between those beams to make them act as one big beam. And that is the same we used for the Wisdome. So you can see on the right side, or let's start with the one in the middle. You can see the 4 layers of beams. Each layer consists of 5 lamellas of LVL. And always 2 of those beams are connected with shear dowels to make them structurally more capable. And on the right side, you see those beams and the shear dowels, and also the cylindric ones. Those are the cross dowels where the beams meet. And since this is a geometrically very complicated structure and it's a parametric design, we have on each one of those locations, for the shear dowels example, we have different forces. But we don't want to use the highest stress one on every location because that would be wasted material. So we made different types of shear dowels. Maybe there's a single one, maybe there's a double one, then the next one is a bigger one. And fed them, as a result from my structural model, fed them back into the parametric model. So on every location, there is a different shear dowel, just so what is needed at that specific location. Then we like to do mock-ups, usually not as much as with this project, but this was something new. For this project, we actually did 3 mock-ups. And the special thing about this project is that usually if we do freeform structures, we use pre-bended beams, doubly curved, single curved, whatever. And this project, we had the material from Stora Enso, LVL, flat panels. And the concept was, okay, let's take those panels, cut them in shape, and then deliver them on site and bend them into shape on site, screw them down, and that's it. So that was the idea. So we started the first mock-up on the left side. The idea was putting those panels together to one beam with clamps, bending them into shape, and then putting them into the CNC machine, drilling the holes for the dowels, putting the dowels in, as you see in the middle, and then that's the final beam. So that was the first mock-up, and we learned that's a good concept, but we are not quite there. We need a little more knowledge to get in there. And the second mock-up was one for the architects, design mock-up, so they have an idea how it's going to look at the end. Then the third mock-up, a little bit later in the project, we had a little bit more knowledge at this time. We had an idea how we want to build it, and we took an actual piece out of the final project. So we have the final geometry. It's basically geometrically the worst corner. And this was our third mock-up, and also the guys who are going to build it at the end were building the mock-up, so we have the experience of those guys going into the planning process. And this is how it was in this project. So design to production did the reference geometry. There is base information in there, master surface, columns, building grid. There was a lot of going back and forth with the architects to get there. But this is the basis for, on one side, me, for my structural analysis model, and on the other side, for Blumer Lehmann for their fabrication model. So we work all on the same basis. And what I do, I go forward with a parametric process. I use Rhino and Grasshopper to do my structural model. Because of the complex geometry, I can't just start putting points and beams into the structural model. That's getting me nowhere. So this is the way I do that, and this is what comes out. The structural analysis model, with all the information in there I can get in there. Here you can see 24 hours calculation time. If I do all the calculations, that is quite annoying, but it's also my fault because I like to do very detailed and complex models. And the next step is the detailing, which is sometimes also annoying, as it was in this case. This is the connection we see from the roof to the column, and we have a frame connection there because this is basically all we have to stabilize the building. And because of the geometry, on each location of those columns, I have different forces, and also the geometry is different at every location. And as it has the way it is, as it has to be the way it is, the location with the worst geometry isn't the location with the highest forces. So I have to look at every location, and that's why I designed the details parametrically. So for each of the columns, I do the details, check the forces, and redo the detail if necessary. And this is what comes out at the end, the fabrication model, based on the reference model, and there is everything in there, what is needed. There is every beam in there, every cutout. You can see on the right, there is every screw, every steel dowel, every steel plate, every hole in there, because that is needed for the CNC milling of the parts. And this is what it looks like at the end. So on the left side, we see the visualization, and on the right side, this is a very recent photo from December last year, right before Blumer Lehmann finished their work. And yeah, you can see on the left side, we have the 4 layers of beams. On the right side, we have the 4 layers of beams, the wooden dome, and all is made with Stora Enso material, CLT and LVL. And yeah, just a few impressions. What was also special about this project, the whole building was housed in a temporary tent. Because of the timeline, we couldn't build it outside because it's timber and we didn't have time to cover it all the time. So we had a tent there, which is quite a luxury, I think. But everyone so far is happy with the project. So Renzo is happy, the client is happy, the museum is very happy, and we are all looking forward how it's going to turn out at the end. Yeah, thank you very much. Thank you for having me, and enjoy the rest of the day.
Thank you, Stefan. So our next speaker is Adam Salt. Good, he's coming up quick. He's the Business Development Manager for Proctor Group, and he's going to be talking about technical membranes for engineering timber.
One second. Hello, there we go. Hello, everyone. Yeah, my name's Adam Salt. I'm from the Proctor Group. I'm the Business Development Manager, mainly focusing currently on modular off-site and high-rise construction. At the Proctor Group, we have a range of technical membranes suitable for a number of different types of projects, but today we're going to be looking at focusing mainly on the engineered timber types of projects that we worked on. But let's start off with how we approach a lot of our projects. First of all, we want to create a successful hydrothermal design. And by doing that, we need to start from the first stage, looking at the internal environment. That's the occupants, making sure we're building our buildings fit for purpose and designing them for the moisture loads that are going to be generated. For example, a care home will have a lot more moisture generated in than, say, a warehouse. So there'll be different designs from that point of view. Next thing, once we've looked at the internal environment, we will then look at the external environment, taking in the weather conditions, the orientation of the buildings, solar gains, sheltering from adjacent properties, or even geographical features. The final stage is the building itself, the one that as designers you have the most control of, and it's looking at the materials we select. Timber will have a lower moisture load, so it can dry out quicker than, say, concrete on construction. Then we look at whether we build off-site or on-site. That will affect the moisture loadings as well. So we've got control at this stage, selecting the correct building fabric from that point of view. Once we've got a good understanding of those three elements, we can then look at the heat, air, and moisture movement and how we detail that in accordance to the BS 5250, which is now called the Management of Moisture in Buildings Code of Practice. So let's have a look through our facade design. We'll build up. It's important to understand that vapor drive. It's going to be different in different countries. In the UK, we will see our vapor drive from internal to external, where that warm moisture air is trying to escape through our build-up. If you were building in, say, Dubai, you would be looking at the opposite with that warm moisture air going into the building. So that means we might position our membranes in different places, depending on those climates as well. It's important to take a holistic approach and look at the heat, air, moisture movement, and rather than just focus on one. I've come from an insulation manufacturer, and we just wanted that igloo of insulation. Membrane manufacturers might just want breathable everything, but as a company that get involved with all these products, we look at every element and go, what's actually best for the design? One of the projects that I worked on was the world's first passive house leisure centre down in Exeter called St. Sidwell's Point. I love this project mainly because a lot of people, when they talk about passive house, they think of a box, a very simple design. But as you can see from here, lots of unique shapes, a very tall building, and really pushed the design boundaries. It's a great example of taking in that holistic approach of all the heat, air, and moisture movement, because there's a lot of moisture generated. A swimming pool is one of the worst types of projects to deal with moisture. You've got wet zones, you've got gymnasiums in there, and we tried to optimize that building as much as possible with using that initial moisture loads within there. Really low performance criteria, so passive house is 0.6. This project went for 0.4 and achieved 0.3 in terms of air leakage, so really low performances. And that was mainly achieved to the involvement of everyone, the collaboration between all the teams, the contractors, the training that was put in to achieve these really good installs using the airtight membranes. A number of different facades presented on this build as well. We had SFS, we had CLT over the swimming pool areas. Again, making it very challenging and really important to look at the moisture within there. So under the EN 15026, which is referenced in the BS 5250, we run a calculation called WUFI on these projects. WUFI is an advancement on the Glaser method. It takes the exact site location. It looks at minute-by-minute predictions. So rather than just your next 12 months and how it's going to perform in your condensation risk, we're looking at minute-by-minute predictions over a number of years. And we can see the temperature gradient through that facade, the relative humidity, and along the bottom there, the moisture content. And the best thing about these types of calculations is you can intersect at any point and have a look at within the year what moisture contents from the external surface temperatures and really analyze in a lot more detail. So let's look at the types of membranes we can achieve or have within our build-up. Typically on the inside of the plasterboards, you'll be used to having a vapor control layer. These play that dual function of being air and vapor tight. But they can add a lot more features now. You can have low emissivity faces that can benefit with a service void to give you better thermal performances. You can have fire-rated ones such as the A2 on screen there, giving you an A2 fire rating. You can have ones designed for swimming pools with the chlorine resistance. And there's a couple of examples there of a low emissivity facer vapor control layer installed on some of our timber frame projects. That's our A2 fire rated one. Now moving on to the breather membrane, or as we prefer to call it, a vapor permeable underlay. The reason we prefer that term is because when we say breather, we are talking about the transfer of vapor. You can have a breather membrane that is airtight or air open. So that's why we prefer the term vapor permeable underlay. Again, they can offer a range of features to your build. You can have a black UV membrane, great for any full exposure. You can have an airtight vapor permeable, fully self-adhered membrane that can go on the outside. One with an intermittent facer for fire protection, really good on timber frame projects with in boundary conditions. Self-adhered membranes allows for all different shapes. And one of the big benefits with a self-adhered membrane is off-site construction. So the transportation with membranes on off-site construction is a big problem. This project here was modules manufactured in Turkey and then shipped all the way to New York. With it being fully adhered, it didn't get damaged during that transportation stage and protected the construction as well. You could do early air tightness testing with your airtight line being externally, so you can crack on that early in your project. There's an example as well. You can go over the openings and then do your early air tightness tests on your project rather than waiting for the internal fit out as well, which is just giving you a bit of an advancement on where you're going to be. This project here called Tickety Boo is actually our MD Kira Proctor's house using a SIP panel construction. Decided to use SIP because it want to aim for a thermal bridge-free design. Using our wrap-tight membrane again over the SIP panel to benefit from the air tightness, especially at the junctions of those SIP panels if there are any air leakage, but also being fully bonded, less damage on site. Internally, she used one of our reflected vapor control layers with a service void to enhance that U value as well. That's another photo without it going on clicking off. That's the ones that went to New York from Turkey in transportation stage and didn't get damaged. This is a project I worked in Wales, which was timber build. They actually built a first house using a traditional vapor control layer internal as their airtight line, and they struggled to achieve their target air tightness of 1. So I got the phone call from Kenton Jones and said, look, I've heard about your product wrap tight. I want to move my airtight line externally. I think it's going to be easier to achieve my target of 1. So on the second house in his factory, installed the wrap tight and then craned in on site. And just like you have with the internal vapor control layer, the external breather membrane can also have a low emissivity facer. Very common in timber frame construction. So when you put on your timber battens with that air gap in front, you're going to improve on your U value. And that can save on the thickness, which is vital when you've only got a certain amount of insulation you can put in between your timber studs. This is our office up in Blairgowrie, being a Scottish company. And you'll see here a wide range of our membranes. I think the main message from today is there's not one shoe that fits all projects. It depends on what you're trying to achieve, whether your primary focus is fire, there's membranes out there for fire performance. If your main focus is air tightness, there's good solutions out there from air tightness point of view. If it's exposure, you've got UV performance membranes, and if it's air permeability, we have membranes for that as well. So thank you for listening today, and hopefully you took something out of that.
Thank you, Adam. So our next speaker is from Accsys Leo Callahan, and I'm looking forward to this, the resurgence of bio-based materials in facades. Thank you, Stéphany. Over to you.
Thank you. There is a problem with the colors. I don't know if it's just this slide or in general. There is a bit problem of graphic. It's not a good one.
No, it's fine. When you look close, it looks like that. It's fine.
Oh, okay,
Yeah,
right.
it's fine, yeah.
Sorry. Well, so good afternoon, everybody, and well, thank you very much for the invitation today to speak at Zak. So I will be speaking today about the bio-based material in facade and the growing interest we have for them in France. So at Accsys Leo Callahan, we are facade engineers and structural engineers as well in the consultancy. And yeah, I'm sorry, there is a problem of graphic in general. It's not the good version. I mean, there are problem of graphics. There are problem of graphics. It's not the right version, but we can go ahead with it. It's not the good version. So the graphics are supposed to be a bit different, but that's okay. Well, so at EOC, we have different offices around the globe, and today we'll focus mainly in the French market with regards to the UK market, speaking about bio-based material. So as you may know, in France, we have a big passion for concrete. And indeed, 50% of our houses and 75% of our collective houses and offices are done with concrete. And for offices, when we do them in concrete, generally they are cladded with aluminium and glass with a high window-to-wall ratio. But it has been a few years that we've seen a change and that there is new romance for timber that actually represent today 8% of the construction in France. And the impulse was mainly given by this project. It's for the Olympic Games in Paris in 2024. And so there is an Olympic village on the border of Paris where there is a requirement to build for 30 to 50% of building with timber structure or mixed structure, and more importantly, 80 to 90% of timber facade, which represents in total 22,000 meter cube of structural timber, so which is a lot. And actually, it has been really a springboard for the whole industry because there have been new guidelines thanks to this project for facades especially. For example, how you can put terracotta or plaster insulation on top of a timber wall facade. And so it has really changed the way we build. And the impulse has been given to other projects. You can see, for example, here the campus of Arbonetum, which is located just next to the financial district in Paris. And so it's creating a massive change with it. And the quantity of timber is even higher than the one that we've seen for the Olympic Games. So this one is under construction at the moment, and it's also changing the landscape. And to see that it's also adopted more generally in France, we can see here there are many examples of scholar buildings that are being refurbished with timber wall facade that have the advantage of providing very efficient skin while having the building 100% occupied. So now we can wonder why we have such a passion about timber in France. And well, the first answer is definitely sustainability, because as per UK and many other countries, we have our national low carbon strategies with target for 2030 and 50. And to achieve the net zero emission and the neutrality by 2050, we have to divide our emission by 6 with regards to 1990, and to multiply our carbon sinks by 2. And it's here that we have a role to play with timber. And this strategy has been translated into standard that has been enforced last year for all the new buildings in France. And it was one of its first because we have very clear targets with regard to energy, carbon, and summer comfort. And for the carbon, then we have clear targets for embodied carbon. And this is really the novelty of this standard. And well, we can see in this table that we have clear targets with regards to embodied carbon with steps that go down every 3 years. And they regard the whole life cycle of a building for 50 years. So we have decreasing steps, and up to now, and for the next target, it's well, we can achieve a target without changing completely the way we build, meaning that we can still use timber and concrete, and low carbon concrete. But by 2028, it will be very complicated to achieve these targets. So for this, we will have to do lots of reuse of building and material, but also to use the bio-based material. Because actually in these targets, they include the biogenic sequestration. And well, so the bio-based material have a great role to play, because if they are done with sustainable management, they are renewable. And first, they have a lower embodied carbon respect to other material, because the energy that is required for harvesting and turning into product is lower than with aluminium, for example. So it's generally minus 60% with respect to standard facade components. And then the great advantage is that the carbon which has been sequestrated during the growth of the timber and the crops, then it's sequestrated within material in the building. And so this is the great advantage. And at the end of the life, we have a release of the CO2, except if we manage to have an efficient circular economy. So in France, when we do the life cycle analysis, we consider this biogenic sequestration. We consider it during the phase A, and then during the phase C, we consider that it's fully released in the atmosphere. In UK, it's more complicated. You have to report it separately, for example, when you do the traditional A1 to A5 LCA. And another difference that we have with our standard RE 2020 is that we have our very own way of calculating the life cycle analysis, which is called the dynamic method. So try to bear with me for this. Well, we consider that an emission which is emitted tomorrow will have less impact on the climate change than an emission which is emitted today. And so this is related to physics, because it will less accumulate in the atmosphere, and so participate less to the radiative cumulative forcing, and therefore less to global warming. So this has been embedded within our code, and it has been done this way, so it's called the dynamic methodology. It means that we have dynamic coefficient according to the time of release of the CO2 emission. So for example, if an emission is emitted today, it is accounted for 100%. If it's emitted tomorrow, it's better, so we have a diminishing coefficient. And so after 50 years, we consider that it's multiplied by 58%. Whereas in UK, for example, it's the static method. You consider that the emission, if it's emitted today or tomorrow, it's 100%, it's the same. So the difference is really for us to prioritize clearly in our construction the storage of CO2. So let's see an example of the difference it can bring in terms of number. And so let's consider this LecoLab wall system for which we have a clear EPD on the fossil and biogenic carbon. So when we compare the life cycle analysis that I've done in France or in UK, we can see for the phase A that you have a positive phase A because you consider the biogenic carbon, which is reported separately. Whereas in France, we consider that there is a sequestration during this phase, so it's negative. During the phase C in UK, we just consider the amount of energy required for the construction, whereas in France, we consider that the emissions are released. But as I told you, there is a dynamic method, so this part is multiplied by 57% because it will be in the future. So at the very end of it, you have a number which is positive, 1.6, and in France we have a number which is negative, which is minus 1.1. So we have a difference of 170%, which is just related to methodology. So it's really a clear difference that we see in the construction and also the pushes for biogenic construction. And so all these differences were based on the fact that sequestration is a topic for debate. Because actually the forest, especially for timber, is a very slow ecosystem that is difficult to control. And also the sequestration is a forward-looking approach. So it's a process that lasts for 50 years. And it will be done when the new trees will replace the old trees. And also, there is debate because when we harvest timber, there is a spike of CO2 and then a gradual sequestration. So it's more difficult to control in terms of timing. So as an alternative or complement, we could be looking at faster growing bio-based material that have a greater yield. So let's come back to the definition of a bio-based material. They are materials that are derived from renewable organic matter of plant or animal origin. And so generally they can come from agriculture, so with the crops, with the fibers, and also the wool of sheep, the forestry with timber, and also the recycling with the textile, the cellulose wadding, and the cardboard. So actually in the building, there are many types of bio-based material that we can be using. And well, especially for facade, we have an opportunity to use different types of fibers for insulation, and also different types of bio-based material for cladding and window frames. And in terms of sequestration, it's quite effective compared to timber. So here I have put an example. So let's consider 1 hectare of hemp, which is cultivated annually, turned into insulation that lasts for 50 years. And let's consider that the CO2 is totally released at the end of the service life. Then we have a first scenario. So let's consider 1 hectare of hemp, which is cultivated for 50 years and then left uncultivated. So when we look at the CO2 sequestration, we can see that during the first 50 years, the insulation is turned each year into a product, into insulation, so it's sequestered. As we said, after 50 years, the hemp is not cultivated anymore. And in the very same time, the first insulation panels start to decay and the CO2 is released each year. So at the end of it, after 100 years, we are carbon neutral. We have emitted as much as was sequestered. So now let's consider a second scenario, when we have 1 hectare of hemp, which is cultivated this time for 100 years. So during the first 50 years, the same thing happens. The CO2 is sequestered. And then the first insulation panels start to decay, and so they release the CO2. But in the very same time, we continue to sequester the carbon with the new crops. So it's continuous, and at the end of it, we've seen that in 100 years, we have been very efficient in terms of sequestration. So with respect to timber, we see that really we have an optimization of the sequestration, which cannot be questioned that much. And this is due to the annual nature of a crop. So we've seen that there are great advantages in terms of carbon storage, but also the fibers, typically, they have many other advantages, such as high thermal fast shift, nice hygrothermal capacity, and they are good humidity regulator. So thanks to all of this, they are great for summer comfort, which is also a target for our RE 2020. But we have also inconvenient, and we have to learn how to build with them. So they can be weak in terms of fire, in terms of moisture also, and they are generally bad in acoustics, so we have to build with this. Well, I have put here some example of quite promising bio-based material that we see emerging a lot in the market. The first example is the straw. So we have been actually building a lot with straw, but as the shape of bale. But they are quite ineffective because they are thick and they are not really good for thermal performance. But now they have invented some machine that you can transport and you can chop the straw thanks to this, and you can have it as blown within walls. So they are a co-product, so it's actually a waste, and we have plenty of them in France because we cultivate our French baguettes thanks to this field. And so it's a great way also to relocate the economy in the rural areas. Another very interesting example is the waste grass for Gramitam, for example. So they collect the waste of grass on the roads, on the airport and canals, and they turn it into insulation. And actually from this, you can do quite lots of volume of insulation. With 1 ton, you can do 200 meter cube, so basically 5 houses. And with thin layer of insulation, 120 millimeter, for example, you can sequester 10 kilos CO2 per square meter. And we still have a good thermal conductivity. And so we have different ways to build with this bio-based material. We can have plaster insulation, insulation with ventilated cladding, straw ball, and also the timber prefabricated walls that are really promising for us in facade engineers. And indeed, in France, we have all the regulations, which are called the DTU, to build with these timber prefabricated walls. So it's very well documented. We know how to do it to respect the fire standard requirements. So everything is really clear and defined. And thanks to this, we can use them up to 28 meter high, and we can go beyond with tests. And also great opportunities that we can integrate the bio-based insulation with Emit because they have a system of encapsulation. For England, it's more complicated, as you know, and so for residential and offices, if we go higher than 18 meters, then we have restriction on the surface and the wall buildups. And we can go beyond with tests, but again, we have a question of building control. So we start to use them a lot in France, and they can come in a very great format, which is great for installation and for control of quality. They can be horizontal, vertical, so you can have flexible design. And generally, also, they are great for experimentation because you can put within it straw, you can put raw earth, you can put hemp concrete, so many experimentation and versatility. And in terms of embodied carbon, they are very efficient. Here we've done a comparison between an aluminum curtain wall, a timber curtain wall, and then timber prefabricated wall. And we see that we can decrease a lot the embodied carbon. And also, if we reduce the window-wall ratio, we have more opportunity to integrate bio-based insulation and cladding. So actually, it has changed a bit the way we work for the new building. And we can see it's changing the landscape. There is more opacity, different way to design, and it has also redefined the way we consider the internal comfort visually. And we have also a very interest of building in timber. And so let's be honest, we have also the potential of having the industry for it. Because in France, we have the 4th largest forest resource in Europe. And when we compare to UK, the surface of forest is actually 5 times higher than in UK. And also, we are the first producer of fiber plants in Europe. And we have crops spread around the whole the territory, which is great for resilience and for localized bad weather, for example. And another also positive aspect of timber is that we found out at EOC that it has actually a great support for circular design. So it's what we will see quickly through a case study of a project which is called UNESCO in Paris that we've done with the architect's Patriarch. So this is the building that we had to refurbish. It has been built in the 70s by Zerfus and Jean Prouvé. And so it was a very innovative and modular facade of great quality. But 60 years later, it was obsolete. And we had several weeks, so we had to refurbish it. And so during the competition, because of the high heritage value of the framing, we proposed to reuse this cladding that you see on the left and to put it on top of a new facade that will be performing and low carbon, and we didn't know exactly what it was at that time. So we won the competition, and we were able to test this principle in the design phase. And so we studied the material, the documentation, and we've seen from the drawing that it was actually a great kit of parts. So we were able to disassemble very easily one material from another. And it's what we were able also to test during the design phase. So we've taken some modules and tested the concept, which was positive. And during the site phase, we were able to dismantle everything and to store the material on site, to renovate and repair them. And so what we propose is to have a timber wall facade with bio-based insulation and to have this existing cladding on top of it. And we found out that it was actually a great system because it's extremely flexible. Basically, you can fix your cladding where you want. So it's great when you have existing geometry. And in terms of insurance, it was also great because actually this system, they always come with a waterproofing membrane on top of them. And so if this waterproofing membrane is resistant to UV, then it could be considered as a cladding. And so if you want to reuse an existing cladding, you don't need to prove it's a cladding. It can be considered a decoration. So it was a great trick to be able to get the insurance. And so in terms of embodied carbon, again, lots of advantages. The combination of reuse and timber wall system that enabled us to save 50% of the CO2 with respect to a traditional curtain wall with new cladding. So this is the system that has been developed for the facade with the timber wall facade. And this was the prototype that has been done in the factory. And then the construction, we can see with the big modules, it has been very fast. In 3 months, we've done all of this facade. And it's still under construction, but the results are really great. And we can see also the patina of the existing, which is quite interesting, and here as well. So, well, in this project, we were very happy because it was a great demonstrator on how to preserve the resources by reducing the carbon thanks to a timber wall facade, by reusing the material, the cladding, and also by recycling the glass, which we have done in this project. And so, as said, we found that it was really a great opportunity to use this timber wall facade. But in general, speaking about the resources, for the conclusion, we can ask if bio-based materials are truly sustainable materials. And well, the conclusion is, as always, it's not that simple, but for sure they could be sustainable material if they are used efficiently in a low-tech approach. And just to illustrate this, I taken a study done by Will Arnold from the Instructi, and so he considered, let's consider 1 acre of forest, and you chop all the trees. From this, you can get 80 tons of wood. And optimistically, you could get 40 tons of structural wood, which is basically 10 kilos per square meter of 1 acre, instead of these trees. So he was asking what you can do with 10 kilos of timber per square meter. Well, you can actually have a 19 millimeter thick plywood. So if we replace all the trees by a structural timber, we can have 19 millimeter thick plywood. And so I did the same exercise with the facade typologies that we've seen earlier. And actually from this, we could get just 0.7 acre of timber wall facade, considering the framing only. And with a curtain wall, 2 acre of timber curtain wall facade. So as we see from this product and the forest, it's clear which one has the most value. And so we should be very careful when we design to be responsible in every inch of timber we use, because we should as well preserve our social value with the resources and territories that we have. So that's it, thank you.
Thank you, Stéphany. Our next speaker is from Hain Tillett Steel. If you'd like to come up, Gustav. And Gustav is going to talk about how we realize a commercial timber building, some practical tips on getting it built, yes?
That's right, yeah. Thanks, first of all, to everyone here and to Zak for having me and to all the fantastic speakers. I thought Stefany makes a great point about how we don't really address sequestration appropriately at the moment in the UK. And as an engineer, I loved Stefan's presentation where you looked at this beautiful sort of tree structure and said, it's a roof and it's a column, you know, very straightforward. So I'm going to talk about commercial timber and sort of, because we've had the pleasure to work on a few of those, how we actually get it built and what the constraints are. Hopefully the button will work. There we go. So this is me. I've been in the industry for sort of 9 years now, and from the onset I've been lucky enough to work in timber. So I worked on lots of timber projects, starting in the residential and the educational sector, and slowly moving over to the commercial, which we see a lot more of now. So at Hain Tillett Steel, I worked on quite a few commercial timber projects. Timber is something we really invest in at Hain Tillett Steel, at HTS, and believe in. And we have our internal timber research group, which focuses entirely on developing our understanding and looking into research around timber. Laura Batty in the middle there is a full-time research engineer, so she's not resourced to projects at all. She focuses entirely on helping us better understand the industry, which is great. Here are just some images of things that we've looked at in the past year or so. If you have any questions at the end of the presentation, I'm happy to talk through it. But just to let you know that we do a lot in the industry to try and promote timber. And I won't dwell too much on our company, but what I will say is we have 62 timber projects under our belt in our 15 years, and we won 25 awards for those projects. So some things being done right. I think partly it's being lucky and working with great forward-thinking developers and design teams, but I also do think that there is that we are learning some tricks and some ways of working with timber that work. So just some examples of these timber projects. We have our own office building that we designed, Chart Street, which won the AD Retrofit and the NLA Retrofit Awards. We have the old Gramophone Works that's made the rounds recently with a few awards. Technique, which you might have seen in central London, is a 3-story timber extension on an existing concrete building. And I have our Chart Street again here, which won the Structural Timber Awards for both Commercial Building of the Year and Pioneer of the Year. And finally, we have the Export Building and the Import Building, which both won the SDA Commercial Building of the Year in 2019 and 2020. So we've been lucky enough to work on some really cool stuff. And I think the first question is, why are we all here? There's lots of benefits to building in timber, but in my mind, it really comes down to carbon. We've had some great talks on that today and how we can really promote the saving the planet. So I've put these slides in because I really like them. These are examples of what a person can do in a year to improve their carbon footprint. We have eat a plant-based diet. You can save nearly a ton of carbon dioxide. Upgrade light bulbs, that's 1/10 of a ton of carbon dioxide. Having one less child, really beneficial, 60 tons. I don't know if anyone's a taker. But actually, as structural engineers, we specify over 1,000 tons of carbon dioxide a year. So changing the way we design can have a profound impact on our impact on the environment. So what we do is on every project we work on, we do huge amounts of optioneering studies to understand what the benefits of timber can be for this particular plot, what the issues can be. And even where we're not asked to consider other materials, where we're lucky to work with forward-thinking clients, we will still go through these exercises because it's so important when you get challenged further down the line, when you come across challenges in these projects, to understand and remember why we're doing this and what the benefits are. So the main bulk of this presentation is really the challenges. I prefer focusing on more positive things, but it's about how we get it built. So let's look at the 6 largest issues in my mind with how to realize timber. And I would say that actually this slide hasn't changed a lot for the last 5 years. We see the same types of challenges. Some of them we've become a lot better as an industry at addressing, and some of them have morphed, but it's the same sort of categories of issues. So I'll try and touch on those briefly now. Starting with durability, what we tend to focus on is moisture in construction, moisture in use, and as a consequence of both of these, is there a safety risk, and also is there an aesthetic impact? A lot of the projects we work on are exposed timber. A lot of us in this room want to see that lovely timber on show, so how do we make sure that it looks nice and doesn't get damaged? Here's an example of a small timber extension that I worked on a few years back. It's built inside the courtyard of an existing building, so timber was great for access and install. And as this was erected by G-Frame, the specialist timber contractor, they did everything right, protected the timber, but then there was an awkward sort of handover to the main contractor who didn't fully appreciate how to manage water protection of timber. I don't know if you can see the image on the left here. You have the raking roofs of the existing building, and you have sort of a tarpauling sitting on top of that and leading the water on top of the CLT. So what you can see there on the right is effectively a pool sitting on top of the structure. Not ideal, and it sat like this for a while. It was over winter, it was cold, it was rainy, But structurally, we find that timber for these sort of relatively short-term lengths of water ingress is completely fine and robust. Visually, it was another story, and they ended up paying G-Frame to come back, sand it down, what's the word I'm looking for? Repaint the structure effectively, and it now looks great. But at the time, it was a bit of a concern. So this sort of thing we see when timber moisture isn't managed in construction, and the way forwards on this, as we see it, is to really develop that moisture control plan between all parties. I was speaking to someone from B&K earlier who mentioned really putting together a robust strategy. I think that's the right way forwards. And also educating main contractors on how to manage timber is really important. Because the moisture damage risks that we see with construction wetness really come down to two things. Prolonged construction periods with poor handling, and then moisture that's locked into the timber at the end of the construction. Technique is one of our projects which is recently completed, and we think that it looks great, but there were a few snags as well on the project, some things that maybe that sort of could have been done better, and well, actually, it could have been done better. The main thing is we had in one small area, a bit of the roof membrane wasn't installed appropriately, and that resulted in use, we start seeing some sort of ugly discoloration to the timber, and it was dealt with really quickly. Unfortunately, the roof membrane had to be re-repaired, so that quality is really key. And structurally, again, there was no real concern with a deep moisture content. The big thing for us is making sure that we have robust ways of dealing with moisture. This is a sketch that I pulled from a project. It's not completed. It's not the finished product, but these are some of the options that we work with to try and provide robustness as a project team. We often see joisted solutions in bathrooms because everything is often hidden away. There's a good way of detecting leaks early. We look at things like CLT to falls. Concrete topping is often promoted where we have plant on top, which might vibrate and create noise. That comes with its own challenges because of the water and the curing of the concrete itself. There are ways around that. But beyond this, there are lots of different technologies that are coming together with monitoring, with ventilated voids, with double layers of protection that we think can really help provide a robust solution. So next fun challenge is fire. Some of you in this room will be aware of the STA process for justifying fire in tall timber buildings, or all timber buildings, really. This came out probably in 2019, and it's a risk-based approach to looking at what sort of building am I building, what sort of approach should I be taking to justifying the fire performance of this building. Is Eurocodes enough in charring, or should we be looking at a burnout assessment and maybe carry out testing? So this is what we've been looking at over the last few years. And what we find is that there are absolutely ways of doing this and doing it safely. The important thing is to get the right advice on your project. Make sure that you have fire consultants on board who understand the material, understand how to work with it. And that's a bit of advice that we will give our clients early on. Get the right advice on fire. That'll help guide you through the design process throughout and get it to work. Here's an example of a project we funded with Ignis, an Austrian fire consultant, to try and understand the interface of steel and timber. Because there's this perception in the industry that hybrid structures are safer than all timber structures, which I don't necessarily agree with. And actually, this interface where intumescent paint on steel activates at a higher temperature than the charring temperature of the timber promotes these risks of things charring from the inside. But the study we did showed that we could really manage this as well with the right parameters and with the right approaches. There are ways around all of these issues as long as we think ahead and plan. Fire testing is another thing which is coming up more and more on projects. We've had that on a few of our projects now. Timber Square is an example. And the advice we're getting from the fire consultants varies, actually. On a few of our projects, we have fire consultants who say, A fire test will only ever give you one result, and there can be 1,000 different types of fires. We have loads of testing out there, and we can model it really accurately and run all these thousands of iterations. So we think a fire test is unnecessary. Other fire consultants say the opposite, and they say this is by far the best way of proving that your structure is going to work. And the one thing to bear in mind is these tests can be expensive. I think the one we did was set up in France. We didn't do it ourselves, but we were part of a design team. A few £100,000, but more than that, there's also a program consideration which needs to be built in early to make sure that you understand when this is going to happen, how it ties into your construction phasing, etc. And this is just a slide to say that there are ways, with all of these different approaches, there are ways of then designing our structure. So we get information back from the fire consultant, and we can then look at burnout methods, sacrificial timber methods through Eurocode or encapsulation where that's appropriate. So just to close off the thoughts on fire, it's really, it goes beyond structure, and I think that's really important. The impact of timber relates to things like boundary conditions and boundary fires. It relates a lot to construction. We have the 16 steps of fire safety, which are really critical. For example, how do you build a tall timber building without having the risk of a big uncomparted timber structure burning with a large fire spread? Do you construct your facades in sequence with the timber, or do you build sort of temporary membranes? So there's all these different considerations that need to come together, and working as a team, it's something that a design team can work through with the right advice. And I would also mention that obviously the most important thing is to have mitigation measures in place, passive mitigation measures. How do we stop the fire from starting to begin with, and how do we keep it contained? Easy stuff, really. On acoustics, I've stolen this image from Ahmed from a project we worked on them with, by the way, so thank you, Ahmed, unwittingly sharing this with me. On acoustics, we did lots of testing back in the day to try and understand how CLT structures work acoustically in offices. But we've come to find that with the typologies that we use, which we tend to see 9 by 7.5 meter grids, which are quite large grids for timber, but we think they work really well. We end up with quite thick CLT. And actually, we find that acoustic consultants can generally achieve BCO with just a 25, 35 mil cement board on top, which also is needed for fire to stop that top surface from being combustible. So in my mind, this is sort of simplified quite a bit. And at the other end of acoustics is vibrations, which is more of a structural issue. And there's been lots of recent research and testing into vibrations. And a whole new paradigm is being developed for the new Eurocode, which we're incorporating now into our designs to get both a structure which isn't going to be annoyingly bouncy, but also one that isn't overly conservative. Historic vibration methods were designed for heavy materials like steel and concrete and aren't appropriately refined for timber. So taking all this into account, we can design something that's more appropriate. Here you can see Wen Xiao sitting at the table from the University of Sheffield, helping us do some vibration testing in our office. And we've also carried out some vibration testing in other offices. I think that is Laser House on the right, which has really helped inform our vibration studies as well. And it all comes down, it all leads to us being able to predict and analyze vibrations and give proper advice to clients on what the structure can achieve. Connections and detailing is really, really important in timber. We talk a lot about things like wastage and cutting and making sure that our structure is optimized for the panel sizes so that we don't end up, you know, on some projects you end up wasting 30% of the material you use, which is a shame. And on the other side of that, some of you will know that connections often decide the sizes of timber members. So getting all of this right is really important. And we try to, from early concept, work through how things are going to work. And then where we get the opportunity to do so, take it all the way through to the other end to construction and sort of get this full puzzle together and work through how it's going to fit together, which we like to do. Finally, I'm going to touch on insurance, which I know has been covered to a fair bit today, so I'm not going to say too much on that, other than our advice is early engagement is really important, but there's sort of a caveat to that as well, which is that no insurer is going to tell you that you can definitely have this premium in 5 years' time. So it's a great way of getting the insurance side of things in early, understand their concerns, what they value, and build that into the design. But it's not that magic bullet on any project, which is going to sort of say, this is what it's going to cost in 4 or 5 years' time when the building is built. It's all about risk mitigation, and importantly, it's not just fire, because I think there is this link between insurance and fire, but actually on any building, I think around 60% of insurance costs come down to water damage. And we have a benefit in timber construction in the UK, because the insurance market is used to insuring old, poorly detailed buildings. And actually, anyone who's worked on a timber construction site knows the level of scrutiny that goes into it, the detailing that we have to achieve. And that should really help. We should convey that and let that help us in terms of risk and in terms of issues. Last slide, I promise. Cost. Greg from Hybrid kindly shared the picture on the left with me. The other one I stole from the internet, so you might have to blur that out. Timber used to be quite stable, as you can see, and we used to be able to give finger in the air cost approximates for timber. But in the last few years, with everything that's been happening in the world, it's skyrocketed for a while, and we're slowly seeing it stabilizing back down again. Interestingly, if you look at the steel graph on the right, they're eerily similar. And actually, this isn't necessarily a timber issue. It's an industry issue. It's a world issue. And what we try to do now is give clients, is get contractors in early to give proper advice on where costs sit and to get the scheme tested at key stages, go out to helpful timber contractors who can help steer us in the right direction, and get that cost estimate right. I think the final thing to mention on this is what we do see is that with this fluctuation, the things that become really important is when can people fix prices? How do we deal with the euro to pound conversion rates? And all of those things become really important questions and discussions to have as a design team with contractors, with the client early on, to try and understand how that works. And that's it from me. Thank you very much.
Okay, welcome back to the last session of the afternoon. We have two parts to this session. We have a talk first from Cullinan Studio, and then a panel discussion. So I'd like to introduce our first speaker, Carillo, who's the practice leader for Cullinan Studios. Do come up.
Hi, thank you. Thanks for staying on to the last talk. I'm going to go through some of the work of Cullinan Studio, and our practice has been around for over 50 years, and we've done a lot of buildings in timber. So I kind of thought I'd show some of our latest work on the boards and things, but also go back a little bit in time, because I think there's just been an evolution in thinking and philosophy that has run through, and I thought it might be useful to review that. So, as I said, I'm Carol Costello. I've worked in the practice for over 30 years and been involved in a lot of our projects that involve timber construction, and had the pleasure of working with Ted Cullinan when he started the practice. I just wanted to say something. Our office is just down the road. And we're in an old warehouse on the canal, really lovely location. But when we bought those buildings, they were quite dilapidated, and we were going to demolish them and build a timber frame office. Historic England had a different view and locally listed the timber trusses and the wall on the canal. And actually, that was probably the best thing we could have done, really. But it's interesting because when we were thinking about that project some 20, 15 years ago, we weren't using the same language we're using now about embodied carbon and operational energy. So we've been looking, we finished a deep retrofit 10 years ago, and now we've been looking at it again and remeasuring the embodied carbon and our operational energy with our lovely tenants, Etude, helping us with that. And we think we can get it to net zero if we just add a few more solar panels. So it's been an interesting kind of living lab for us, and it kind of shows how our thinking's changing, how we're talking differently about buildings and carbon, as opposed to, I think when we did this project, we were thinking more about energy reduction. That's Cullinan Studio, which was founded by Ted Cullinan. And he had a great philosophy to life, and people came first. He was obviously very creative and loved building things. And his own house in Camden, which these are the drawings he did, he was using the materials he could get hold of and that he could self-build with. And that was a bit of reclaimed bricks from the area, but also timber. And specifically, like to say, timber he could go and get at B&Q and screw together himself on the weekends. But there was a kind of other philosophy about designing with timber, and we've kind of touched on that. This idea of oversailing eaves to protect the cladding and overlapping details, that was also then the kind of expression of the architecture, and it kind of carries through to the legacy of our design practice today. And when I first joined the practice, I got to work on the Fountains Abbey Visitor Center, which was finished in the early 90s, which was super interesting because we were using reclaimed roof slates, dry stone walling as cladding, and then this lovely cedar board cladding system, which we'd probably never do now because it was probably really bad on air tightness, but it was slim pieces of double glazing between very large, thick, 8-inch wide Western red cedar from Canada. But I'm going to talk about a couple of projects that were sort of experimental that were done to the late 90s, early noughties with Bureau Happold, who we've worked with a lot on projects. One of them was the lodge at Hook Park. And this is one of Ted's drawings at the beginning, because we're always thinking about the cultural side of these projects and not just the technical. So this was for John Makepeace at Hook Park, and we were looking at experimental timber structures and specifically being asked to look at what can we do with timber thinnings that would normally get chipped, typically, and see if you could actually make structures from that. So our commission there was to make a lodge for visiting students to live in out of timber thinnings. And we were thinking, well, how can we do that? And thinking about how these thinnings, when they're green, are pretty flexible. And then looking at a kind of curved roof that we could make with those timber thinnings. And doing experiments there. There's Richard Harris from Bureau Happold. I don't know if any of you remember him or worked with him. We got to work with him on a few projects, seeing how we could weight down that green timber to get the bends, and experimenting with kind of crude joints that could be built on site there. And it's now occupied by the Architectural Association, but the lodge still stands and is enjoyed by students. And then a follow-on project really from that, again with Bureau Happold, was the Downland Grid Shell. And this was built out of kind of 50 by 25 oak laths that were scarf jointed together. And then there was this patented connection detail that we developed with Bureau Happold, which allows, you know, when that lattice is flattening down, the connection detail allows the slats to move over each other and form that kind of peanut shape, which is really fantastic space, and was designed as a workshop, but it's super popular and it's used for all sorts of events. And then a project I worked on for Kew Gardens, and again here, the reason for using timber was they wanted to use UK-grown cedar. It was an archive, though, so we had lots of fire and archival issues, but significant areas of the cladding could be made from timber construction, and we worked with Patrick Hislop at Trotta to devise this system where we were just hanging fin joists from the edge of the concrete slabs and then putting insulation between those. And then we're looking at ways to kind of create variety with the cedar cladding by varying the shape and spacing of the final timber battens on that project. Again, working at another botanic garden, the John Hope Gateway. This was our first project where we got to use mass timber, CLT, even though we tried to use it on several projects before and never kind of got through persuading people to do it. So this was finished in about 2008. And again, with Björn Happold, worked on a lovely kind of assembly of very slender steel columns with glulam beams, expressing those connections and making this lattice roof for the roof deck. And it's a lovely space to be in. And life, you know, for the Botanic Gardens to be able to use timber and plant material as an expression of the architecture was really important. And that was almost like a kind of prototype for a much bigger building. And my friend Aditi's here, who worked on this with us, for the National Automotive Innovation Center at the University of Warwick. And we had kind of a tough sell on this with Jaguar Land Rover and Tata Motors because timber wasn't really part of their kind of aesthetic world in automotive design. But we were able to convince them that actually, if they're all about designing a low-carbon automotive for the future, their building needs to consider these issues about carbon. So we're able to have kind of two significant parts of the building made from timber, the roof and the walls, which I'll show you. Internally, it's a concrete frame, partly to do with a lot of vibration issues for the sensitive labs and areas that we're dealing with automotive design. But we had this mega panel, which was covered in a Ferrari membrane and then had a kind of aluminum mesh cladding on it. And this seemed to go up so smoothly and quickly, and it has so many advantages in terms of the build and speed. You don't see this timber inside, but it was a great substrate for all the follow-on trades internally and very airtight and really good solution. And then this was the roof. All this was done with Arup on structural engineering. This idea of this large roof canopy of glulam beams and CLT with 7.2 meter timber span, and then that extended with the steel trusses. So really beautiful combination of steel and concrete. And we were told at one point it was the largest timber roof in Europe. I don't know if that's actually true, but it's quite a big structure. And there it is completed. And the building's got a lovely quality because of this timber and great acoustic kind of quality to it. And we know that Jaguar Land Rover then went on to design some more projects with timber roofs because they were so happy with this. I don't think I need to explain this to this audience about the advantages of using timber, but it's been interesting because the project was kind of commissioned before we were really being asked to meet carbon targets, but we're signatories of our IBA Climate Challenge 2030 and using those guidance and going back and measuring carbon on projects. And it's within for embodied carbon, the LETI targets for 2025. And considering the amount of concrete that's in the frame, the timber's doing a big job in getting those levels down. Another project we're working on at the moment is It's just finished actually at Alderhay Hospital, is Catkin and Sunflower House. This is a center for children and young people with mental health issues and their families. And we were looking at biophilia and thinking of timber specifically because of the new research that's out about how timber in the environment is actually calming to people and helps with their recovery. So this is just finishing on site. And this is a photo of site. There are certain elements that we were going to use timber cassettes for the facades, and we haven't been able to do that, partly because of these insurance issues. But we've got exposed timber in all the treatment rooms and overnight stay rooms. And this is just some visuals of that on site. And another project we've been working on with Bureau Happold is for the Getty Foundation, which for the antiquities at Neopaphos in Cyprus, they needed a solution to replace some of the covers they had for their archaeology and particularly mosaics, where they had, this was a timber and steel solution, but it has performed really poorly. The weather's quite extreme there. They actually get tornadoes, etc. They needed a whole new solution for that. So we were working with Bureau Happold. And just kind of going back to some of our other projects, this idea of the canopy, and particularly with timber, the expression of the architecture in timber is kind of probably most noticed in that kind of idea of canopy, and it's an idea that runs through our projects. And for this one, the canopy is the key factor to protect those antiquities, but also protect people in the kind of climate in Cyprus as they visit these areas. So it was a system that really wanted to touch the ground very lightly, and come up with a system that was quite flexible and demountable, that would have as least impact on the antiquities as possible, and be something that they could try at the first site, but actually replicate across sites in the Mediterranean. And really looking at a kind of simple solution and being able to use timber that was sourceable within Cyprus or the Mediterranean countries as well. So there's a real practical drive in this project, and of course, get the carbon down as far as possible. And these are just some of the visualizations of this project. And then the last project I'm going to mention is a small one again, which is for the Bankside Open Spaces Trust. And they are a charity that looks after green spaces around sort of Borough Market. You might have come across some of their lovely spaces like the Red Cross Garden. And they, I think, are the first client that's come to us with a circular economy brief. So the idea is that we reduce waste wherever possible. And that's kind of led us, we're working with Ingenuity on this, to thinking about more reuse of materials as opposed to virgin materials. And we've been looking at places where we can source reclaimed timber, and there are some places, and also reclaimed steel, etc. But it is interesting that some of these salvaged timbers are from old piers, and some of these timbers, they're tropical hardwoods, but they're 200 to 300 years old. And actually, once they're refinished, they're in really good nick. But the lengths you can choose are shorter. So we're looking at how to design a roof with shorter spans and propping up that roof with reclaimed steel tubes from the oil industry instead of timber, again, to show reuse of materials. And that's our visualization for that. So that's on the boards now, going into kind of our construction detailing phase. And it just shows a bit of a journey and how we're thinking. I really like the talk that Stéphany gave about thinking about all materials and how to use them wisely and think about their end of life and how they can be dismantled. And that's kind of where we are at Cullinan Studio. So thank you.
Thank you, Carol. That's a great talk and a great line to finish with. Think very wisely about what you do with all materials. If that isn't a summary for the day, then I don't know what is. So next we have a panel discussion, which is about the role of engineered timber in our new regulatory landscape. If I'd like to invite the panelists to come up onto the stage, please. Alan, if you'd like to bring your team up. So Alan Dowdall will be moderating this session. He's a structural director at Ramboll. And come and join us.
Can you hear me? That's it? Great. We've got, I think, a fantastic panel to round out the event today. So we'll start off with a few introductions. I suppose I'll go from me on down to Farabegoli. My name is Alan Dowdall. I'm a structural director with Ramboll. I suppose my career is focused mostly on timber, which I'm here. So if we go through each one of you, I'll start perhaps with you, Sam, if you want to say a word about yourself.
Thanks, Alan. So my name's Sam Williams, and I'm part of the commercial development team at Related Argent. Currently, we're focused on roughly about 1 million square feet of commercial buildings coming through in the next 3 or 4 years at Brent Cross. And all of those buildings we would like to be either a full timber or a hybrid timber building.
My name's Kate Fairhead. I work at Marsh, which is an insurance broker. I sit in the construction practice, but have some experience with property-based clients. So I'm going to sort of speak from the perspective of the insurance industry on both the construction and property side.
Hi, I'm Ed Marchant. I'm an associate director at Bennett Associates Architects. We've got quite a portfolio of timber buildings, either hybrid or all timber. I worked on the community sports hall in the King's Cross for Related Argent, actually, which was an all timber sports hall. And we're currently looking at an all timber office scheme in Brent Cross.
Finally, I'm Greg Cooper from Hybrid Structures. I'm managing director. We build a lot of mixed material structures around the UK, including all timber, different species, different types, and got lots of lessons, a lot of scars, and hopefully can share some lessons today.
Thank you, Greg. So we have a developer, an insurance broker, an architect, and a contractor. I think we've got well covered in the industry there. So let's start perhaps with an easy one. An easy one is why timber? We seem to be a big demand for the use at the moment. And as we have a developer here, he's doing a lot of timber schemes.
Trying.
Why using timber?
Yeah, so I think part of the risk of being at the end of the day is that you do end up repeating some of the things that others have already said. But the obvious ones for us are around embodied carbon. So for Brent Cross Town, we've committed that that's going to be a net zero carbon town by 2030. And for us at the moment, we think that timber is going to be pretty fundamental in terms of us being able to get to the embodied carbon targets that we want to. I think speed of construction is also pretty important for us, and the ability to do off-site manufacture as well is great. So having a kit of parts you can bring to site and erect very quickly is really advantageous for us and helps with things like finance as well. But probably some of the more interesting benefits for us, I think, are around the fact that it seems to be more and more market-led. So when we're bringing tenants and potential occupiers around the building, and we've got sort of like a space up there where we showcase what we're doing. They all gravitate towards the buildings that are kind of obviously timber. And I think that's partly because of how businesses' ESG strategies have developed. And to be able to give them a building that kind of overtly shouts about being sustainable, I think is something that is definitely coming through much more than we've seen before. And I think the final sort of benefit, if you like, is it's pretty tough out there in terms of finance and capital raise. And we are seeing that investors and financiers are looking much more favourably on projects that have good green credentials. So in a tough market, we want to make sure that we're kind of leading the pack on that as well.
Thank you. What about the rest of the panel?
Well, as designers, we've got good grip on kind of how to design buildings to reduce the kind of operational energy of one, but in terms of achieving the LETI 2030 target, the focus is much more embodied carbon. Of course, timber is very much part of that journey. It's one of the, if we can design buildings in a way that we can allow for sequestration of the timber, then it's definitely one way forward to achieve that target.
I'm not really meant to have an answer for this because I appreciate I'm not building in timber, but from an insurance industry perspective, the more that are in the pipeline, the more that there are, the more my market has to move to find the right solutions for you. So I want to see them. I want to see as many as possible, despite it being a challenge right now, because it's going to have to force insurers to find solutions for their clients.
Right. I mean, from my point of view, I think just the naturalness of material itself makes it interesting to work with, and it's natural beauty. So it does. Yep. It has that sort of biofilm bit, which in the last presentation you can see, feel the warmth from the space that you create. Okay, that was the only easy question. We'll move on. I mean, you know, the UK has seen some significant changes in our building regulations over the last few years, and you know, the likelihood is that's going to change as we go forward in this sort of net zero carbon world. What do we think as a panel are the upcoming regulations and rules that we're likely to see soon enough? And Edward, I want to put it up to you first as the designer.
Yes, I think there's a difference between kind of resi and office schemes, for example, where building regs very much determine what's allowed in resi in terms of cladding. Working on a workplace project, it's, as it's been mentioned several times, driven by the insurance, and actually it's the lack of regulations and the lack of codes and the lack of standards that is actually factored into the risk assessment of the insurers is driving the cost up of insurance. So as a designer, you don't have a set rule of thumbs that you can design by, because none of it is actually certified as a safe design. So you're relying on the approach of the fire engineer, on bespoke testing for every single component. So therefore, it's what we would like to see is actually sharing of data that leads to a market that actually can insure these assets, which makes it then easier to design them and become more mainstream. So it's actually the lack of codes and standards that we're currently struggling with.
I'd probably just echo that point around, I think we're almost trying to create our own data set. Yeah. Each developer, each project is kind of going out and going, well, we've got this bespoke detail, this bespoke structural base, so let's go and set fire to it. And then we've actually got some data that we can give to insurers. And then the next project comes along and it's a slightly different detail. So that previous set of data doesn't count, so you have to go and do it again. So yeah, I think...
And even the testing environment is different on certain tests, when in closed environment, open environment. So there's no set of rules on how to test those build-ups, those details. So even that is not really standardized.
Yeah, and we've talked about it as an industry, definitely from the construction perspective, but I'm very confident property insurers have at least had the conversations between themselves. But at the moment, the industry is relying on your expertise. You guys are the ones with all the knowledge of it, but now it does mean that it gets segmented into each individual scheme, so it's becoming a bit circular, and it almost just needs a collective brains.
I think from our point of view, we have to start looking at things as systems. rather than individual problems. A lot of people today have spoken about fire and water. They are the big two things, but when we look at the solutions to both of them, fire, we want to bung every little hole up, we want to seal it. Water, we want to let it get away and escape, both during construction and post-construction. So we have to look at the problems as a bigger picture and work out individually how we're going to close them out and how we individually deal with them. But we have to look at the system as a whole. So all the regulations need to come together, need to settle down to allow us to build these buildings that we need to for the future.
Interesting. It's interesting what you made, Sam, about everyone seems to be climbing a mountain rather than building off what someone has done previously. So it's that sharing of knowledge. So if someone else is doing something progressing from that, they're not standing from the same point as everyone else has been before, right?
Yeah. And I think that is changing as well. I think the attitudes have changed a little bit in terms of people being so protective over their IP and their data that they're sharing. And there's a number of different forums at the moment that involve a lot of the kind of top developers in the UK. And we're definitely starting to share a lot more of that information. And I think, Kate, you mentioned the pipeline as well. We're trying to get a database of all these projects that we've got over probably 8 to 10 different developers that we can then go to insurers or go to government bodies and say, look, there's 1 billion square feet of wooden buildings that we want to bring through here. So something needs to change to allow us to be able to do it.
Yeah, I would say, interestingly, and maybe because I'm external to your industry, albeit tied in, I actually think between yourselves, you share information a lot better than the insurance industry does. And sometimes we are coming apart by the fact that a certain individual insurer doesn't have the claims data. Now, I appreciate that they're not all fully advanced yet, but another insurer does have some experience, but they're not necessarily intertwined with one another. And I get that because there's sensitivity around information, but if there was connectivity there as well as your side or even as a whole, it would definitely help the process.
Great, thank you. I wonder if, just going back to regulations and rules, we can see next year, for example, SUDs will become a legal requirement. I wonder if within a certain time frame, like the circular economy will start to become, your buildings have to be designed for to be demountable, reusing that. That is a potential thing that we're seeing potentially now. I mean, you guys see something similar where you need to feel that you need to have your buildings circular economy ready for this?
I believe so, yeah, because if you, I mean, that's probably something we'll touch up on later, but it's definitely an important factor in bridging the gap between supply and demand. So building less and wasting less in the design process and the construction, but also making sure that what you do design can be reused once the building has reached the end of its life is actually potentially reducing that demand. So designing lean buildings of which the components can be reused, not recycled, but reused as building components is probably an important factor. So circularity will definitely be a main focus in the next few years.
From my point of view, I think there's a lot of materials within our cities
that we don't use. Yeah.
And I can see a future where, taking timber as an example, we've got urban forest. It would be a case of, before you look to use virgin timber, could you source it from means that it's already been used once? Okay, we talked a little bit about insurance and fire and water, and there's been a bit of talk about it today as well. So just to ask another question to Kate, because you're an insurance broker. What other insurance-related issues could you share that perhaps we're not talking about?
Yes. Oh, sorry, carry on.
And how do you see the industry addressing?
I think the biggest issue that is the hardest for everyone to address is all around partial damage. Insurers are concerned that there would be an exacerbation of loss driven by the fact that a lot of the timber is prefabricated, and how do you fix something that's built off-site, on-site? And we've seen a couple of cases with modular construction where the costs have been quite substantially higher to fix it than it was necessary to build it in the first place. And I think because how mass timber is being used a lot in the UK, it's relatively new, they just don't understand whether what would typically be a lower attritional loss that they can adequately price for goes from small to big, and it blights their portfolio, so it drives them into an unprofitable state. We saw that with water damage, where previously water damage losses weren't, they were attritional and they were priced, and then escape of water hit such a point that those attritional losses were in the millions and millions of pounds. And I think their concern is here, what would have been a small loss will be a big loss, given the fact they don't know how the mass timber is going to respond to an incident of escape of water particularly, or ingress of water, and even a small fire.
I suppose that comes back to your point earlier about having a series of buildings that have built up a history that we're aware of, and you have to get more data available.
Exactly. And I think in lack thereof at the moment, like what we're certainly trying to do with our clients, and Dominic mentioned it as well, so it's an industry thing of we're going to, have you thought about it? Like, tell us how long it will take to replace something, or how easily can you replace something on site, or have you designed out the risk? And it's the things that you've probably thought of, managed, just need to get conveyed and presented in such a way that they understand that the risk is as low as it can be. And I mean, it is going down to those small things of like listening to the presentations earlier around bathrooms. It's managed that they are less exposed to water because of how you've designed the building and keeping the timber away from all the pipes. Telling insurers that, they've not thought about it. They're just going, oh, there's loads of pipes, particularly like in a residential building. And to be honest, it's getting your expertise in front of them.
I think there's a point that links into the circular economy point as well, and I'm definitely not trying to like get rid of innovation in structural frames, but I think there's something around standardization that will help with both of those things. If you've got a building that has a very standard sort of member size for a beam or a column, then you're probably likely to be able to get it much more quickly than you would if you've got this very bespoke piece that you need to replace. And again, with the circular economy stuff, if it's a standard 6x9 structural grid, then great, you can kind of take that apart and then reuse it to do another scheme afterwards.
I'd say the biggest thing we've forgotten on all that is digital technology, where every building has a unique reference, a unique number that's tracked back to the member that was made in the factory. So if we understand what member's damaged, we've already got the fabrication drawing, we've already got the details. It's then just going through the process of reordering that component. Depending on the component, they can generally be from anywhere from 2 weeks to 12 weeks. It depends on the complexity, but that data is already known. So if you identify where the problem is, we can trace it back, call it off, and then it's working out a strategy of replacement.
And that level of detail, like, that's what the insurers would love. I know it's breaking it down and presenting it to them in a way that they understand it, but we, albeit not timber, it was a high-rise modular. They said, how long will it take if you need to replace one modular unit? And they came in and said, right, if this one's damaged, it will take us this many days to replace the unit. Right, okay, we know our lead-in times, we know our financial exposure. They then gave financial loss cover for a high-rise modular building, which in the UK, like they're nervous about, just like they're nervous about timber.
It's interesting, you're saying better communication between designers and brokers will make inroads. And it sounds like there's a lot of low-hanging fruit. It's quite simple.
I strongly believe, and again, I'm probably in Dominic's optimistic land, but I've seen the market move in the last 2 years. Like, we have one insurer that turned around and said they wouldn't touch mass timber. then they are a very big participant on the timber yard scheme. Like they've transitioned to now writing construction insurance for a timber project. It is at the board level of insurers. They're being pressured by you guys, they're being pressured by us. We just need to keep the process going, and we will keep moving forward.
Great. Okay. I'm going to move on. So, cost certainty plays a big part in the early design stage of the project. Sam, you answered the talk. How do you deal with the cost certainty about insurance and regulatory requirements?
Yeah, I think, I mean, one of the previous slides, I think Gustav's slide that he had about the price of timber has been one that we've been sort of monitoring. So the actual cost of the material is something that I think we're a bit more comfortable with now than we were probably 9 to 12 months ago. But for me, that sits in the same pot as everything else, that you're always forecasting what your construction costs are, and probably not many people predicted there was going to be sort of 11% inflation on construction costs last year. So you're dealing with that, I think, whether you're dealing with timber or steel or something else. I think one of the difficult things for us, particularly around the insurance side of things, is being able to understand what our exposure is early. And this is a really difficult conversation because I think on all sides, everybody's saying early engagement is good and we can design out some of that risk. But the question that we really want an answer to, and I know why it's not possible for insurers to give it, is particularly around asset insurance. At stage 2, how much will it cost for us to insure this building long term? And I think the construction insurance part of it, we are less concerned about at the moment because we've seen more of that happen, and it seems to be probably a little bit more of an engaged market, and the premiums are probably not as much as when you're talking about asset insurance. I mean, we've had high-level estimates, and when you're looking at construction insurance, the feedback that we've received is it's probably 50% more for a timber building than it would be for traditional construction, in inverted commas. But asset insurance is potentially 7 times as much. So that is quite a difficult thing to then go back through boards and say, we love the timber, it's going to be fantastic. Oh, but by the way, the insurance is going to be 7 times what it was before, and that's going to flow through a service charge to a tenant. That's the bit that at the moment is quite difficult to unpick. And I think you have to, as a business, really want to build in timber to have, I'm not sure confidence is the right word, a big appetite for risk to say, well, we understand that there's going to be fluctuation and we don't know what the answer is, but we're going to keep going on the basis that we think it's going to get better.
Well, thankfully, because people like yourself, Kate can see more buildings going up and the risk will go down. Therefore, it takes the premiums.
That's what we're hoping.
We're hoping. And hopefully we'll hit a soft cycle at some point that will help it as well. Yeah. But we've got to rely on economic factors to get us there.
You mentioned the cost of material. We have a contractor. Any thoughts on material cost now?
I think the end cost that clients see, the cost plans, it's about tracking where the costs are attributed. So much is in material, so much is in buildability, there's design, and it's understanding the products a little bit better to understand what is that cost point, what is the premium to pay for timber, how does that feed back into insurance, how easy it's to replace. So the species of wood, the type of wood chosen, and how it all fits together does play a big role in that cost and how it's built up. I mean, we're always having conversations with clients, how much does it cost? But it all depends on the application and how you're using it. And there's a massive range. It can be 4 times different on the same square building, depending on how they form it. And you really have to think about the form, what you want to do, what you want to achieve. But the costs are stabilising, the costs are getting better out there. But it's just the raw economy as you described, external pressures.
Do you think there's a danger that we're all striving to build loads of timber buildings, and there's going to be a point where so many of us are trying to do it that the supply and demand doesn't work, so then the prices end up?
I don't think there's ever going to be that point in the next 30 years.
Okay.
Because I believe there's enough investment going on manufacturing processes, on methods, on planting the trees, right back to the origins that we need. People had these visions in 2000 and hectares of trees were planted, and if we can't even get the raw product, forget everything else, we can't do it. So we have to be visionary, and we see a lot of investment in manufacturing processes that enable us to do that. And the other one that we need is we do need universities to do the test data, to find the data for fire, and there's so much going on in those processes, because the wood we're building today, probably in 15, 20 years' time, we'll be talking about a different wood. I don't know what it is, but I'm sure there will be something different out there that we'll be building in every day, because we need to change, we need to get this climate, we need faster growing trees to get that biodiversity back into society, so it will happen.
Yeah, I suspect you want a range of trees, different species. So we're not having a monoculture of spruce, which is pretty spread its own business, I think.
Yeah.
From my thoughts as well, in terms of cost, is the timber industry can still innovate, can still do more for less if they can do. I think there's potential. We put a lot of timber into our mass timber buildings. So it'd be nice if in a couple of years' time that changed, that term mass became lean timber buildings. And whether we can use the same amount of timber and put it over different floor areas. And I guess that could be done through different types of species and using different timber products, a combination of different products, rather than perhaps relying on one product to do the whole thing too. Okay, so moving on to any other thoughts that we have about the front of that? Moving on to regulation changes that have had an impact. We talked about regulations potentially in the future. Regulations have been made, changes been made. The ban on combustible materials on the perimeter wall for residential buildings over 18 meters, it's fair to say it has had a detrimental impact on the residential sector. But also, not just on high-rise or mid-rise, but also on low-rise. It seems to be that it wiped it out for a bit. So a couple of questions really on that. One for Megan, for Philipp. Do you see a route back to residential buildings coming back online from an insurance point of view? And how would you see that?
Yes, you have to say yes to that, because it's the way we are all moving forward. And I think the way to do it, it's similar to your £200 million office scheme that's a hybrid with timber in. It's you speak to insurers incredibly early and you take them through that process with you and how you get there. I think if you just approach them 1 month before the scheme is starting, it's going to be a real struggle. But if they're there in that design phase and they understand the process, and when I say that, I mean both the construction insurers and the property insurers need to be in the room. I do feel for you guys, because before you start on site, you've had to think about 10 different insurance policies, because everything is split up rather inconveniently for anyone that's not in the insurance industry. But it's thinking about all those pieces and pulling them together to create a presentation that gives the market as much comfort as they can get at this stage. But I do fear that, at least if I had one on my desk right now, it would be more punitively looked at than a traditional build, and it would be more punitively looked at because it's residential. Like you said, that there is that tarnish there, fair or not, because of Grenfell, and then the sort of instinct regulation change that happened straight after.
Thank you. Greg, have you see a lot of these, but have you seen much change over the last few years with residential?
Yeah, we saw a massive change. Probably 1 in 3 jobs with residential pre-Grenfell. It's now significantly lower than that, massively lower. I don't think the regulation change in the grand scheme of things to build better buildings for the future, in the future, will be a problem, because I think we'll have better buildings, safer buildings. I think in the future, if we can get the regulation right, we can get the pathways right, I think it will give assurances to insurers that they once have had already, that these buildings are safe, that a small problem doesn't lead to a bigger issue, because we know we're dealing with the big factors that came out of Grenfell. It's going to take time. We've got to change perception. We've got to do it. But I think more importantly, listening to everybody today, I think we need it. I think the world knows we have to do it. It's just how we do it safely and in the right way. And I think that's where it'll come round. So I always like the stop button or the pause button. I think we've paused. I think we're going to pause for a little bit longer, and then I think it will go and open up.
Okay, I think we're going to start wrapping up. We might have time for one more. Sam, the timber is pretty new in terms of asset management. How do you plan that going forward? Is that similar to what we talked about in terms of just having strategies for removal, or is there any sort of formed updation?
Yeah, I think it probably, I suppose when we talk about asset management, it covers quite a broad spectrum of different topics. The obvious ones are around maintenance and repair and things like that, and a few of the buildings we're looking at, quite a bit of external timber as well. So I think there's a bit of education that has to go on internally for us around understanding how that timber is going to weather in 10 years' time, 5 years' time, what maintenance needs to happen to that to keep it, if it's doing a structural job, to make sure that it keeps doing that job. But there's also another side of asset management for us, which is more kind of focused around the tenants and their fit out as well. And I think that's something, you know, when we started, I was talking about the appetite of occupiers coming in for kind of overtly sustainable buildings. But it does have some complexities around fitting out the space that perhaps are not always obvious to everyone at the beginning. So if you're used to doing let's call it a traditional steel frame building that's got castellations in the beams, very easy to bring your services through. When you're thinking about fitting out the space, often we're building a building before we know what the fit out is going to be. So you have to be either thinking about some sensible sort of preemptive moves within the CLT and the glue down structure and things, or you're just bringing your tenant along the journey to try and make them understand that it's perhaps not going to be quite so easy to just bring a load of fan coil units through at a high level to cellularize a space. So I think that's definitely something that, yeah, we think about quite a lot.
We were talking earlier about column spaces. You bring your tenants through that, if you've got a smaller column space, potentially. Do you find that hard sell or easy sell?
I find that we probably worry about that, and dare I say agents probably worry about that more than tenants themselves. So I think if you can bring somebody around a space that has got a 9 by 6 metre grid rather than an 11 metre span that you might get in a steel building, unless you have kind of a very deep floor plate and a sea of columns, I think the impact is actually, people are more thinking about actually the timber is a lovely aesthetic and provides a really nice environment to be in. I don't think they're so worried about the fact that you've got a column that's kind of 2 metres closer than you might have in a steel building. That might be a personal view rather than a corporate one.
I think you're on. People who have the same opinions.
Okay, that's good.
Yeah.
Okay. If anyone has any other points to share, please say something. Also, we'll start to wrap it up.
Well, I just want to try on what you said, Sam, about designing in timber does force you to think twice about flexibility, adaptability, making sure you design lean buildings, maybe reduce the complexity of the geometry of the design, so you avoid transfer structure, you maximize the exposed finishes, of the timber, and all that helps a lot in kind of getting the carbon down and making the most of the timber.
And following that, make sure your insurers know about it.
Yeah.
Just make sure they know everything you've thought about, because you've already thought about it. It's more, when you hit the market, you've thought about so many more things than a traditional building has.
Yeah.
They're designed this much more.
Yeah.
Let the market know.
And I think we're trying to do that in an incremental process, which we think we're probably being quite brave at the moment. So the building that we're working on with Bennett's is about 140,000 square foot. So it's quite a big timber office building. But we have taken design decisions along the way because we're sort of preempting what insurers are going to come back with. And so we've got a concrete core, and we have a non-combustible facade. So we decided for this building, we're going to focus on trying to a pretty big timber frame building, but let's not go too far. And then the next one, perhaps we bring in some,
Incremental.
exactly. Yeah.
Drag them along with you.
Okay, well, thank you very much. I think we're a few minutes early, but that means everyone gets a few minutes free time back. So I think I'd like to thank all the panel for giving their time and effort to it. I think your opinions and knowledge have been very valuable. Thank you.
Thank you. Thanks.
Okay, we've come to the end, and special thanks to Alan for wrapping up early, not just bringing it in on time, but making up for the 20-minute screen glitch at the beginning of the day. And for a great discussion panel that pretty nicely summarized a lot of the things we talked about today, bringing out again the discussion between cost and value. Many investors have very tight ESG requirements now, so green finance is looking for green buildings. Costs of insurance aren't necessarily just a problem for timber buildings, but it's a problem that's common across the market. So, and again, the same is true of costs. The same is true of all things in the construction industry at the moment. So if people start tagging these issues onto timber, maybe we remind them that it's an industry issue, not just a timber issue. But certainly we've touched on the need for certified details and sharing and collaboration in order to make sure that we don't have to retest the same detail that happens to be very slightly tweaked from the other detail. I thought it was really great to have Stefany's input to show us that other countries are actually way ahead of the UK in terms of regulation and guidance on timber and robust regulations. We see the same thing happening in America, Australia, and around the world. So maybe the UK industry should be looking around at adopting some of that best practice. We've mentioned circular economy several times. And the need to treat materials with great value. They are a precious resource. And actually, maybe we need to start to think of our materials as not just a resource for our decade, but for not just our generation, but maybe generations to come, and make more of an effort designing our buildings to be deconstructible and demountable. I was glad we touched on the idea of lean timber buildings in the last panel discussion, because there was a time not so very long ago that people were boasting about the amount of timber that they were sequestering in their CLT residential buildings because they were stacking up walls and walls and walls of solid timber. But of course, if you're sequestering more carbon, then you're probably not designing a very lean and efficient building. And we need to remember that, you know, we have only so much forestry on the world, on the planet, when we're going to also have tensions with agriculture and urbanization to deal with. So the land take of forests will be limited. So we really do need to share the timber out across as many buildings as we can. And that means probably not being too purist about timber and being not shy about embracing hybrid solutions where steel and concrete and other materials that will be coming online in the next few years will help us to produce more sustainable, more circular buildings. So just like to end the day with a big thanks to all our speakers, to all our panelists. Thanks to everyone for coming, and have a good journey home. Thank you.
And just a second, hold on. A round of applause for Timothy himself. I think he was excellent in steering today's session. Thank you so much. As I mentioned in the morning, we've recorded today's event, so we'll do a little bit of editing. There are a couple of presentations we've been asked not to share. We'll do the editing and have the link shared with you by Tuesday, Wednesday. So thank you all for taking time out. I hope you enjoyed this year's edition. We've tried to to give a twist to mass timber the way we envisaged it. So I hope you enjoyed it, and looking forward to hosting you next time soon. We'll have the final mementos done for the day, and then we are done for the event. Thank you so much. Thank you all for coming.